and welcome to this Vue.js Fundamentals module on getting started with the Vue CLI. In this module, we'll spend a few minutes gaining a high-level understanding of Vue.js applications, and then we'll dive into creating our first project with the Vue CLI. We'll even start writing some of our own code in this module, including building this homepage for the Build-A-Bot application that we'll build throughout this course. We're going to have some fun in this course using Vue to create a simple website for building and buying custom robots. This application will be rich enough to demonstrate all the fundamental concepts you need in order to create your own applications with Vue, but it will also be simple enough that we won't waste our time building unnecessary features that have no educational value. And this is what it'll look like when we're finished. As you can see, I can come to the build page and start customizing my robot, and I can build the robot that I want and then click add to cart to add it to my cart. And then you can see it shows up in my cart here, and I even show which robots I saved money on if they happen to be on sale. And back on the build page, I can click on any of these parts and learn more about the individual parts. This site doesn't seem like much, but there's a ton of concepts and learning built into this. It will be just enough to allow us to dive into things like creating components and child components, communicating between those components, routing and navigation, state management, and even API calls to a separate server. We'll even explore how to build and deploy this application to production. So let's jump right in and start learning about Vue. At the heart of a Vue.js application is the Vue instance. A Vue instance, or Vue app, is created whenever you call vue.createApp. In a typical Vue application, you will only have one Vue instance. When you create a Vue instance, you will usually tell it to render your main app Vue component, which you do by importing your app component and then passing it into the create app call. The app component is your top level component in what will become a hierarchical component structure. So you can imagine your Vue instance wrapping your entire application, and inside that you have your app component. And the app component may have a child component, which then may have other child components, etc. This should feel familiar if you've written any Angular or React applications. The component structure is similar, other than the Vue instance. In a Vue application that includes routing, which is probably most Vue applications, there's another piece. Basically, instead of the app component containing other components, or maybe in addition to it containing other components, it will also contain a router view, which shows the content for the current URL. And as the URL changes, the content inside the router view is updated. And while there is a lot more to a Vue application, this is a pretty good conceptual overview of the main structure of a Vue app. To understand the rest of the details, let's jump into creating an app from the ground up. We're going to need a few tools installed to get going. First, we'll need Git installed. I'm on Windows, so I'm going to use Git for Windows, which can be downloaded from here. If you're on a Mac, you can install scm-git from here. And if you're on Linux, you can just run a command like this one from the terminal. I'll go ahead and download and install Git for Windows. And then I'll run that, and I'll just use the defaults throughout the install. And now that that's installed, I have this new Git bash console that I can run. So we'll use that in a minute. And actually, while I prefer to use this bash console, sometimes Windows users have issues with it. So if you're getting weird errors, try using the Windows console window instead. The next thing I need is Node. I prefer to install Node using Node Version Manager, just because it makes it easier to switch between versions of Node as I develop different applications. On Windows, I can download that from here. For Linux and Mac, you can just run this command from the terminal. Of course, these each have their own README with instructions about installing them, so you may want to read through those for your environment first, but I'm going to go ahead and install this on my system. And I'll just use all the default options here too. Okay, now that that's installed, I'm going to open my Git bash console. On Windows, be sure to open it as administrator. Okay, now that I have MVM installed, I can just run mvm install, and then the version of Node that you want to install. It's recommended that you use this version for this course if you're following along to avoid any compatibility issues. And now I can just tell MVM to use this version of Node. Okay, we're good to go. with Git and Node now. If you have problems using NVM to install Node, you can try installing it directly from here. Just choose the correct installer for your system. Okay, let's get coding. We're going to use the Vue CLI to create our new project. If you're using Vue to create a project that you're going to deploy to a production environment, I highly recommend you use the CLI. The CLI represents a lot of thought and effort by the Vue team to create an environment where you can easily work in development and, when you're ready, create an optimized production build. So to get started, let's install the Vue CLI. We'll do that from the terminal. On Windows, we need to use the bash terminal we just installed. And then we just need to use npm to install the Vue CLI globally, like this. Typically, this is all you'll do to install the CLI. But for this course, we're going to install a specific version like this. If you're following along with this course, be sure to use this same version to ensure you don't run into any surprises or problems along the way. Okay, now that that's installed, we can use it to generate our project. So I'm in my dev folder where I want to create my project. And now I can just run this command. So this is going to create a new Vue project, and it's going to create that new project in a Build-A-Bot directory. Okay, so that brings up a series of prompts. Now, you might be seeing something a little different. If your prompts are missing color and the arrow keys don't work, then you'll probably need to run this command instead. This is a problem with the git bash console, and running this command should fix it for you. So just run this and you should be good to go. Okay, notice that I can choose from a default preset here, or I can choose to manually select which features I want included with my new Vue app. I want a little bit more control, so I'm going to choose manually select features. So you can see that the Vue CLI starts with a handful of out-of-the-box features to choose from. Each of the features listed here has the ability, when you select one, to do several things, including things like prompting you for more information on the command line, modifying the Webpack config, installing npm packages, and generating files. This is all based on a Vue plugin architecture, and the whole idea is to create a zero config environment, meaning they've done a lot of the thought to create all the Webpack and other configs so you don't have to worry about that. Now, usually that sort of thing makes me nervous because when framework developers say you won't have to worry about it, it usually means I'm going to have to worry about it and it's going to be a pain to work with when I do. And as you look at this out-of-the-box list, you might think, well, this is great if this list contains the features that I want, but what if I need something else? Or what if I don't choose something here and I want to add it later? Well, not to worry. Forget to install one of these? No problem, just add it later. Don't see a feature that you want? No problem, anyone can create a plugin and add it later. And there's a good chance you'll find that the community has created one for you. And when you do need to make changes to the Webpack config yourself, you can do that too, all without ever having to eject from the CLI. This is all part of an attempt to create a zero config or low config environment, and they've done a stellar job of it. Of course, if you need to do some custom configuration, you can do that too. You'll notice that the first option listed here is to choose your Vue version. This is so you can either choose the latest version or an older version of Vue. We'll leave that selected so we can choose our version. And then we also want Babel and a linter as currently selected. We're going to use a router and Vuex later, but we'll add those then so you can see how to do that. So I'll go ahead and hit enter to move ahead with these options. Now we get to select the version of Vue that we want to use, and we're going to be using the latest version of Vue, so I'll select Vue 3. And now we need to choose our linter options. And I'm going to go ahead and choose ESLint with the Airbnb config. I really like the Airbnb configuration for code styling, so I'll go ahead and select that. So I'll hit enter, and then I'm going to select lint on save so that it will execute my linter whenever I save a file. Now I'm going to go ahead and hit enter again. And then I have an option here as to whether to put my config in my package.json or in dedicated config files. And I like it in dedicated config files, so I'll select that. And then here I have the option to save all of these options that I've selected as a preset for future projects. If I do that, then when I create a new project in the future, I can select that preset instead of having to go through all these options again. But I'm just going to go ahead and say no here. Okay, so now it's generating our project for us and installing all of our npm dependencies. Cool. Now that that's done, let's take a quick peek at what it generated, and then we'll start writing some code of our own. So I'm going to open up my code editor, and I'm using Visual Studio Code. So I'm going to change directory into my new Build-A-Bot folder, and then I'll just type code dot, and that should start Visual Studio Code in this directory. I highly recommend VS Code for working with Vue because it has a lot of great Vue extensions that offer some incredible support for working in Vue. In fact, let's take a look at those extensions. So notice here that I have an ESLint plugin, a Vter plugin, and a Vue plugin. I recommend you install each of these if you're following along, or if you're going to be doing Vue development in Visual Studio Code. And then lastly, there are some ESLint settings that we want to configure here in our workspace settings. I've configured some ESLint rules for formatting Vue files. So notice here that I'm telling ESLint to validate HTML, Vue, and JavaScript files. And then notice down here that I have this setting that will fix any ESLint errors upon saving the file. These settings will make ESLint work well and make it easier to auto-fix small linting problems as we code. You can ignore the rest of the settings in this file. These are just my settings to get the font size and other things right for the course. And if you're working on Windows, there's one change that we'll want to make to this ESLint RC file so that it doesn't have any issues with the Windows style line endings. Right here in the rules section, we're going to add a rule to disable line break style checking like this. And then there's one more change that I'm going to make that just works better for formatting code for the course. You can ignore this one if you want, but I'm going to turn off the operator line break setting so that I'm free to format the code as necessary to fit on the screen for the course. And that's it. We should be set up now for ESLint. All right, now that we've got our editor set up the way we want, let's take a look at what the CLI generated for us. We'll start with the package.json file. If we take a look at the scripts in the package.json file right here, you can see that it created these 3 scripts for us, all of which call the Vue CLI service. The Vue CLI service manages a local dev web server that is based on Webpack dev server. We're not going to cover the Vue CLI service in depth in this course, but you can learn more about it here. For now, we're just going to go ahead and run this serve script. So back in our terminal, we can just run npm run serve. And that's going to compile our application for development and then start a development server for us on port 8080. There we go. Now let's go take a look at that. Cool. So you can see that we have a running application here. And this is the sample web page that always gets generated from the CLI. This just gives us a good starting point that we can start editing. So let's take a look at how this is all working and being rendered. So back over here, we'll take a look at our main.js file in the source directory. This is the entry point for our Vue application. And you can see it's really simple. Notice we're just creating a new Vue instance here with the create app function imported from Vue. And we're passing the app component into the create app function. This is a Vue component that was created for us by the CLI. So when Vue bootstraps our app, it will start by displaying the app component. So let's take a look at that next. So first of all, notice that there are 3 sections to this file: a template section, a script section, and a style section. Clearly, this is not a file that a browser could understand. So the question is, how is this getting used? Well, consider a couple of things. First of all, there is a Vue-specific Webpack plugin being used to parse this file into its individual parts and compile them in a way that a browser can use them. And secondly, this component was passed into the Vue instance, so Vue will work with what's generated by Webpack to render this component. We'll talk more about components and each of these sections in the next module. For now, all you need to understand is that this app component is the top-level component in our app. And as we build our app, it will remain at the top level of our component hierarchy as it is used to display routed components and their child components. Right now, there is no routing at work here. The app component is just displaying this hello world component. So the app component is displaying this as a child component. And if we go look at that component, which is in this components folder, you can see that here is all the HTML and all the links that are currently being displayed in our app. Cool, so that's how everything is wired up that was generated by the CLI. Next, we'll start replacing this content with some of our own. All right, in this clip, we're going to start creating some of our own content. We won't be exploring any new concepts just yet. We're just going to spend a little bit of time replacing this generated content with some of our own content. This will get us a little more familiar with what the CLI generated and with the layout of our new app before we start digging into key Vue.js concepts. So let's start by renaming this Hello World component. This will become our new homepage, so let's name it homepage.vue. We could just name it home.vue, but one of the Vue style guide rules says that components should be 2 words at a minimum, so we'll name it homepage. And let's update the component name down here too. And then we'll have to update the import for this in the app component. So instead of importing Hello World, we'll import homepage from homepage.vue, and then we'll use that down here. And we'll change it up here in the template. And we don't need this message attribute anymore, so we'll delete that. And I'd like to put all of this inside a main element. And we don't want this Vue logo up here anymore, so we'll delete that. All right, and then let's add a couple of styles and clean up some styles that we don't need. So down here in the style section of our app component, I'd like to add a gradient to the body of our application. So I'm going to give it a background. I'm going to set linear gradient to a gradient from top to bottom. And then I want to set the background attachment to fixed. And then down here on the app element, I'm just going to remove everything except for font family. And then I just want to add a few styles for this main div. So down here, I'll add a main style. And I want to set margin to 0 auto. So this will center the main content. Then we'll add some padding and give it a background color of white and a width of 1024 pixels, and then just a min height of 300 pixels. Okay, we'll talk more about components and styling them in the next module. We're just trying to get a decent starting point set up here, and then we'll delve into this stuff more. So let's go see what our site looks like now. Okay, ignore the main content area, but notice that our background has a gray gradient now, and our main content area has a white background. Now let's go replace all of this content with our homepage content. So back in our homepage component, up here in the template. All right, so let's delete all of this content inside the outer div, and we'll change this class to home. And then I'm just going to go ahead and paste a little bit of content here. If you're following along,
go ahead and type this in.
And then notice that we just have a couple of divs here. One just has an image of a robot, and the other has a get started link. So notice that this image is loading robot home.png file out of the assets folder. But that file doesn't exist in here. This is just the Vue logo that came with our Vue CLI sample page. So let's go download that robot home PNG file. To help us with this and a number of other tasks throughout this course, I've created a little helper repo over here in GitHub for the Vue.js Fundamentals course. And there's just a few files in here that we will occasionally use to download things as we go throughout this course. So in the source folder, notice we have an assets folder, and here is the robot home PNG file. And we'll actually need this other image too, so we might as well download them both. So first I'll click on robot home, and then click on download, and then save image as. And then I just need to go find my build-a-bot folder. And in the assets folder, we'll just save it here. And then we can go back and do the same thing for this build-a-bot logo. So we'll save that here too. So now that robot home image exists in our assets folder. Now we just need to clean up some styles down here. And we don't need any of these. Okay, cool. I'm just going to add a few classes here. So we have a home class, and I just want that to be text align center. And then a robot class. And I just want to set the height to 300 pixels. This is for that robot image. So let's go see what our site looks like now. Okay, cool. This is looking great now. And you may have noticed that I didn't need to hit refresh on this page in order to see my changes. That's because we are using, behind the scenes, Vue CLI is using the Webpack dev server, including hot module replacement. So as we make changes to our code, the changes immediately show up in our browser without us having to refresh. Okay, awesome. So now we've created a new home page. But let's add one more thing that we're going to use throughout this course. Our site is missing a navigation header. So let's add that quick. And we could add that to our home component. But then when we navigate away from our home page, we would lose that navigation header. So really, we want it to be on our app component. So up here, just above our main element, we're going to add a header element. And that's going to have a nav element. And this nav element is nothing special. It's not Vue specific. It's just a normal HTML element. And then inside here, we're going to use a unordered list to list out each of the nav elements. And for now, that's just going to have one list element. And that will have a nav item class. And then inside here, we're going to have an image, which will be our logo. So we'll give that a logo class. And this is going to be the other image that we downloaded. So in our assets folder, it is the build a bot logo PNG file. And then we'll just say build a bot here. And now we just need to add some styles to style that. Again, we'll cover styling in more depth in the next module. But rather than have you type in all the styles, let's go over to our helper repo. And in the source folder, there is this header.css. And we're just going to click on the raw version of that and copy all of it. And then let's just paste that all in right here. Okay, so you can see we're just adding some header and nav item styling here and some styling for our logo. Okay, let's go take a look at that. All right, awesome. So you can see here, again, without having to refresh, hot module replacement just updated our page for us. And we now have a navigation bar at the top with a list item here on the left for navigating to our home page. And that's not a link yet or anything. We'll update that later. But now we have a home page with a navigation bar in our app component. And I realize that this clip was just a bit of just following along, not a lot of new concepts. But hopefully as we moved around in the app and replaced some HTML in our homepage component and our app component, you began to become a little bit more familiar with the layout of our application. And hopefully that will help it going forward. In the next module, we're going to dive into components and template syntax and start learning a lot more concepts. So in this module, we just learned some high-level things about Vue and how to use the Vue CLI to create a project, and a little bit about working within components and making some HTML and CSS changes. In the next module, we're going to take a much deeper look at components and template syntax. So let's go jump into that. In this module, we're going to explore all the fundamentals of creating Vue.js components and working with component syntax. This includes creating components, using bindings to display data and handle events, conditionally displaying elements with vf and vshow,
Repeating elements with v4,
styling components, working with component lifecycle hooks,
reducing duplication with mixins, and lastly, we'll also take a look at the composition and reactivity APIs. There's a lot here, so let's get started. Before we jump into coding, we should understand the difference between global components and local components. In this course, we'll be working primarily with local components, but in the wild, you'll likely run into Vue code that is using global components, and there are some valid use cases. So let's briefly talk about each one of them and why you might use one over the other. First of all, let's take a look at the app and homepage components we just created. The template and script sections of our app component look like this. And highlighted in orange, you can see what we did to utilize the homepage component inside our app component. You may have missed some of these details because the CLI generated most of this code for us, and we just renamed the Hello World component to make it this homepage component. But in the template, you can see we used our homepage component like an HTML element. And in the script section, we imported the homepage component from another file and then registered it in the components section of our app components metadata. We were required to register the homepage component like this because the homepage component is not registered globally. So our homepage component is an example of a local component. With local components, you need to register them in the components where you use them. Let's contrast that with global components. This is what our main.js file looks like right now. This was generated for us by the CLI also. Instead of making our homepage component a local component as we just demonstrated, we could have registered our homepage component globally. If we wanted to do that, we'd do it right here in our main.js file. First of all, the createApp function returns the newly created Vue app, and we'd need to access that. So first we'd set it to a variable like this. And now we can use that app variable to declare components globally. So if I wanted to declare the homepage component globally, first I'd import it, and then I could register it globally like this. So notice I'm calling the app.component function, and the first parameter is the name of the component, or the HTML element name that I want to use to render this component in other components. And then the second parameter is the component itself. This component is now registered globally, and as such we can just use it inside any component in our application without having to register it inside those components. So if we look at our app component again, we would no longer have to register it here. So we can remove that section from our app component. And we can still just use the homepage component in our template like we're doing here. In fact, since it's registered globally, we can now use our homepage component everywhere in our app in any component, just like this without having to register it. On the surface, this seems nice, but as always, there are downsides with using anything global in our application. First of all, global components have the same drawbacks as any global variable in any application. In larger applications, global variables inevitably cause problems because they can be hard to locate, but more importantly, it's easy to run into naming conflicts. Secondly, and perhaps most importantly, global components can lead to increased bundle sizes, increasing the amount of JavaScript your customers have to download in order to run the application. This is because global components will always be loaded, even if the user never visits a part of the application where that component is used. So global components reduce the amount of tree shaking and optimization that your application can do. For this reason, it's generally best to use local components unless you have a component that is truly ubiquitous in your application and used everywhere. So for the rest of this course, we'll be using local components, and we'll be using a format called single file components. A single file component is a component with a .vue extension. There are typically 3 sections in a .vue file, including a template section, a script section, and a style section. The template and script sections are required, whereas the style section is optional. We'll dig deeper into everything you can do in these sections throughout the course, but basically, the template section is where we define our HTML template. The script section is where we define the JavaScript functionality of our component, and where we export it so that it can be imported elsewhere. And finally, the style section is where we define the CSS classes used by our template. Of course, if you look at this file, no browser is going to be able to render a file like this. So .vue files are compiled by Webpack at build time to generate HTML, JavaScript, and CSS files that the browser can work with. This compilation comes for free, already configured for us if we start a project with the CLI. This all makes using single file components a no-brainer when building full-featured web applications with Vue. So we'll be using single file components throughout our course. And you may remember that this is what our app.vue component looks like that was generated by the CLI. The app.vue component is a single file component, and so is the homepage component. Okay, now that we understand a little bit about the different types of components, Let's jump into creating our first component from scratch.
All right, now the real fun begins. Let's start creating our own components. We already have a homepage component. Now we want to create a page where we can build our custom robots. A new page means a new Vue component. And I could just put that new component right here in the components directory. But I don't think that scales very well as applications get larger. I prefer to structure my apps by feature areas. So let's make that change now. We'll start by creating a new home folder. And then we'll move the homepage component into that folder. And now I can delete this empty components folder. All right, now we just need to update the reference to our homepage component over here in our app component. It's now in the home folder. And that should be rendering fine, so let's go take a look at that. Okay, yep, that's working just fine. Now let's create our new component. So this is going to be a robot builder component. So let's create a new area for building. We'll call that the build folder. And then in here, we'll create a new single file component called robot builder. Remember, component names should be 2 words. Okay, so let's create our 3 sections in here. So we'll have a template section and a script section and a style section. All right, our template's complaining just because we don't have a root element in here yet. We'll fix that in just a minute. First, we'll go ahead and create our component element and export it. So we're just going to export an object, and we'll give it a name. So this is our robot builder. And notice that ESLint ran when I saved it, and it just removed some extraneous spaces at the beginning. So that ESLint will run every time I save. Okay, now for the HTML and CSS. I don't want to bore you with typing in a bunch of HTML that isn't really Vue specific. So let's copy this from our GitHub repo. So back over here in this source folder, in the build folder, you can see I've created an HTML and CSS file for this component. So let's click on the HTML file, and then we'll click on raw and copy this, and then we'll paste that back into our template here. Okay, so you can see that we just have a bunch of HTML in here. There's nothing specific about Vue here, but you can see that we have a top section, a middle row section, and a bottom row section. And you can see the part selectors here. They basically are comprised of an image and buttons for left and right or up and down for changing the selected part. Just as a reminder of what we're actually building here, it's this build page here. So this is our top section, our middle section, and our bottom section. And then here are the part selectors, what I'm calling part selectors, which consist of an image and buttons to select the individual parts. And so that's what all this HTML is here. And these buttons are not wired up to do anything yet. But you can see I have a lot of classes here. So let's go grab the styles for this file also. So back over here in our repository, we'll go back and back again. And I'm going to click on this robot builder CSS file and grab the content out of here. And then we're going to go ahead and paste that into the style section down here. So this is just all the styles for positioning each of those part selectors and the buttons and everything. And again, there's nothing really Vue specific here with regards to what I pasted in. This is all just CSS styling. The only thing that's Vue specific here is that I put the CSS inside this style tag in our single file component. Okay, and then you can see these image tags are pointing to images that we haven't downloaded yet. So let's go grab those. And back over in our GitHub repo, you can see inside the build folder, there's an images folder. And there's a lot of images here. I could just click on each one of these and download them one at a time. But it will be easier to just clone this repo and then copy them locally. So I'm going to go back over to my terminal and stop my server. And then I'm going to move back a directory. And then I'm going to git clone this repo here. Okay, let's go ahead and clone that. Okay, now that that's there, I can go back into my build-a-bot directory. And then we'll change into the source build directory, and we'll make a images directory here. and we'll move into that directory. Okay, now we can just copy those images from the cloned helper repo like this. So we'll just grab everything out of the images directory and copy it into this directory. Okay, so now you can see we have all those images in here. All right, now that we have those, let's move back to our application directory, and we'll go ahead and start the server. All right, now let's go take a look at what our new page looks like. Of course, how are we going to get to this page? We don't have routing set up yet, and so how are we going to view this robot builder instead of the home page? Well, for now, we'll just have to import it over here also. And then we'll just go ahead and render this here instead of the home page component, and we'll comment this out for now. And then we just need to use this up in our template here. Okay, so now this should be showing our robot builder instead of the home page. So let's go check that out. Okay, perfect. So you can see that we have our new robot builder component rendering here, but these buttons don't do anything yet. But this is awesome. We have a new component, and it's just got some really basic HTML and CSS. And all we're doing so far with the component is just exporting it and then using it here in our main app component. So let's make this page more interesting next by adding some bindings so that we can start selecting the individual parts. In order to make our new build page a little more dynamic, we need to start by binding it to data from the component instead of these images being hard-coded in the HTML template. In order to provide data to our component, we need to update our component options to have a data function. So down here, we'll add that right here. So this is just going to be a function, and right now we'll just return an empty object. If we look at our build page, we have all these different parts: heads, arms, torsos, and bases. And eventually, when we click these buttons, the corresponding part will be swapped out for another one. We're not going to wire up these buttons just yet, but let's get the images wired up to a list of parts. First, we need some data. Eventually, we'll get the data for the parts from an API, but for now, we'll just create a file with all the data in it. So let's create a data folder inside our source folder. And inside that folder, we'll create a new parts.js file. And this folder is also going to contain our images. So let's move that images folder from our build folder into the data folder. Okay, now we need our parts data. So let's go back to our GitHub repo. Let's go into the data folder and grab this parts.js content, and we'll paste that into here. So this is mostly just JSON data, but you can see up here, this first line, there's some Webpack goodness here. So we're using Webpack's require.context here to make Webpack aware of the image URLs so that we can just use them throughout this JSON data as relative URLs. So down here on line 10, you can see that we're calling this images function and passing in a relative URL. When this is compiled by Webpack, this will point to the relative URL of this image file. So other than that, this is all just JSON. And you can see that we have this parts variable up here, or constant, and that we're exporting it down here. And just so we understand the shape of our data a little bit, if I collapse each of these sections, you can see that the parts object is an object with properties for heads, arms, torsos, and bases. Each one of those is an array of parts. So this data is perfect for what we need. So let's jump back over to our robot builder, and then let's import that data here. So we will import available parts from data parts. So the ESLint plugin for Visual Studio Code is a little bit funny. You might notice that I hit save multiple times there, and it reformatted according to my linting rules a couple of times. Okay, so now we just want to return these available parts as part of our data object. So we can just return it like this. So now our data object is an object with an available parts property that is set to that JSON data. Now let's see how we can use this data in our template. At the top of our template here, we have this image that is displaying currently the head image for a robot. And instead of setting the source to a hard-coded string like this, we want to bind it to an expression. We can do that like this. So this says bind the source attribute of this image element to this expression in the quotes. And inside that expression, we can access available parts. So this is the available parts object that we exposed in our data function. And then available parts has a heads property, which is an array, and we'll just grab the first head and then grab the source property. So this source property, thanks to Webpack, and we talked about this just a minute ago, this is the relative URL to the image for this head. Okay, so let's copy this expression down to each of the other parts. So we'll set these to vbind also. And for now, we'll just bind them all to the heads. Okay, there's just one more here. Okay, so if we look at this, we now have a robot with all heads. Not a very useful robot. So let's just update each one of these to point to the correct part type. So here, instead of heads, this is going to be arms, and this is going to be torsos, and this one is also arms, and then this is bases. So now if we refresh, there we go. Now we have a functional robot again. And that's all thanks to the vbind syntax, which is binding the source attribute of the image element to these expressions. Of course, you can bind any attribute of any element using vbind. So now our image source attributes are all bound, but we can't change them. We still are not changing the image when we click these selector buttons. To do that, we're going to have to bind to the click event. Let's see how to do that next. In order to react to actions by the user, such as clicking on these buttons, we need to bind to the events of those elements. That's just as easy as binding to data was. All we need to do is use the v-on syntax. So on this button, I'm going to add a v-on binding to the click event. So now whenever this button is clicked, the expression inside these quotes will be called. So what I want to do here is I want to call a function. So I'm going to call select next head. So this is the next button for the head image. So when the user clicks on this button, we're going to call this select next head function. And that function needs to exist on our component. To do that, we're going to introduce a new property on our component called methods. And that's an object. And then you define each of the functions inside of here that you're going to call from your template. So we need select next head. And for now, let's just console log select next head called. So let's go see if that works. So over here, let's open our console and then click this button. There you go. You can see each time I click it, this select next head called gets logged. So our v-on click binding is working. But what we really want to do is have it select the next head instead of just console logging. So we're going to have to track some index and increment and decrement it when the buttons are clicked. To do that, let's add a selected head index to our data object. And we'll initialize that initially to 0. And then in our select next head function, we will increment that like this. And then to make that work up here in our template, instead of hard coding this to 0, we're going to use our new selected head index. So now this will grab the head that matches that index and bind the source property to the URL of that head. Okay, let's go check this out. Cool. So now as I click on this button, you can see that Vue is calling our select next head function, which is incrementing the index, which updates the binding for that image. Okay, let's do the same thing for select previous head. So we need on this previous selector, we need a v-on click binding. And that will call select previous head. So now let's go create that function down here. And that will decrement that index. Let's go check that out. close our console here. All right, cool. Now I can move back and forth between the heads. Of course, we have a slight problem here. If I open the console, clicking on this next button, you can see that at some point I start getting an error. This is because we are incrementing that index out of range. So basically we need to make it so that when we get to the end of the heads, then when you click the next button, it resets the index back to 0. So to fix that, I'm going to create a couple of helper functions up here at the top of my script block. Okay, so we have a getPreviousValidIndex function and a getNextValidIndex function. And if you're following along, go ahead and type this in. But you can see it's just going to, when you're clicking Get Previous, it will deprecate it until it gets to 0, and then it will set it to the last head, and then vice versa with the getNextValidIndex function. And then notice that these functions take in the index to increment and the length of the current parts array. So down here, instead of incrementing this, we're going to call getNextValidIndex, and we will pass in this dot selected head index and the length of the heads array. Okay, and then we'll do the same sort of thing for getPreviousHeadIndex. Okay, so that should fix this problem. And then these functions don't mutate the index, they just return a new index. So I need to set the selected head index to whatever is returned from these. And our linter is complaining because these lines are too long, so let's just wrap them, format them a little bit better. Okay, let's go check this out. So now, as I increment, you can see that it is wrapping around and we're not getting any errors. And same for going to the previous heads. Awesome. So now we know how to bind to the click events. And of course, we could bind to any event that is fired by any element. So we've updated the head, but we have not yet updated the other parts. So let's go fix those bindings. So if we go back up to our template, I'm basically going to need to copy these bindings down to all the other buttons. So there's the previous binding and then the next binding. And then this will have to call, this is the left arm, so I'm going to call select previous left arm and select next left arm. Okay, I'm going to go ahead and do the same thing for all of the rest of the parts. But I'm going to go ahead and do that off screen because it's not too interesting to follow along. Okay, so you can see here that I've updated the bindings for select previous torso and next torso, right arm, and base. And then notice also that in the vbind source bindings, I've also updated the hard-coded 0 to the selected base index, right arm index, and torso index, and same thing for the left arm index. And then you can see down here that I've initialized them all to 0 here in our data function, and then I've added methods for each one of them. Select next head and previous head, left arm, torso, right arm, and base. So if you're following along, go ahead and copy and paste all those and update them appropriately. Okay, so let's go check this out. So now we can move to the next and previous head and left arm, torso, right arm, and base. Awesome, we have a functioning robot builder. In the next clip, we'll take a look at an abbreviated syntax for these vbind and von bindings. We just created all of these bindings in our robot builder HTML, and I just wanted to take a second to call out a more abbreviated syntax that's really nice. Anywhere we use this vbind syntax, we can replace it with just a colon. So this is a shorthand syntax for vbind. And then anywhere we use von, we can replace that with an @ sign, so no colon here. I really like this syntax because it's very non-obtrusive, but it's also really clear that we're creating bindings. So let's replace all of these with a search and replace. So I'm going to search for vbind and replace it with just colon. So I'm replacing vbind colon with just a colon. And I'll just replace all of those. And then I'm going to search for von colon and replace it with just an @ sign. Let's replace all of those. And our robot builder should still be working. Let's check it out. There we go. We can still see our images or bindings are working and our button bindings are all working. So from here on out in the course, we'll be using this abbreviated binding syntax. Next, let's take a look at how we can create and bind to computed properties. Sometimes you want to be able to easily bind to something in your HTML template that involves a complex calculation. Doing complex calculations in your HTML template isn't really a great idea. We can solve that and move the complexity into the component with computed properties. All of these expressions are a little ugly. What would be nice is if we had a selected robot property on our component that we can use. So if we come down to our component, we can add a computed property here. And like the methods property, this contains methods. So I'm going to add a selected robot function. And this will return an object that represents our selected robot. And then that object will have a property for each part like this. Now let's add the other parts. So there's the left arm, and then we'll do the torso, and then the right arm, and then finally the bases. So now selected robot.head will return the currently selected head, and so forth. So now up here, instead of these expressions, we can just replace these with selected robot.head.source. So let's copy this down to each one of these. So there's the left arm, and then here is the torso, and now the right arm, and finally the base. And then I think I might have had a typo down here. Yeah, I didn't say left arm index here. Okay, so that should be working great. So if we come over to our robot builder, now we can still use our robot builder, but our code is a lot more simple in our template, where we don't have this complex expression here, but we're just binding to the head of the selected robot. So this is better, and while this one just helped simplify our template a little bit, there are cases where it can simplify them a lot. You really want to be careful not to do too much logic in your templates, and computed properties make that easy. Our robot builder is looking pretty good, and we've learned how to bind to attributes and events, but we haven't yet learned how to simply just display raw data on the page. We do that with interpolation. To demonstrate that, let's display the name of our robot just above the robot head. If we take a look at the parts data over here, you can see that each part has a title, and the names of the heads actually make for a pretty good name for our robots. So let's display the name of the currently selected head above our robot. Because of our computed property, this is going to be really easy. So let's add a new div right here, and we'll give it a class of robot name. And let's add that class down here in our styles. And I'm going to position this absolute. And I want to position it about 25 pixels above the top of the head. And then we'll align the text to the center. And then we'll set the width to 100%. Okay, now for the interpolation part. Back up here inside our div, we're just going to add an expression like this. So the double brackets is used for interpolation, and inside there we'll just put an expression. So we just want to use selected robot .head .title. And this is it. That's all there is to interpolation. And you can put any valid expression in here. Although again, it's recommended that you only use simple expressions in your template. Okay, let's go check this out. All right, awesome. You can see here that our robot has a name. And then you can see as I click through the robot heads that the robot name up here is changing due to that interpolation expression. So interpolation is really simple. Before we wrap up on interpolation though, let me mention one more performance option. We can add a vOnce tag to any element like this. And when you do this, any bindings inside that element will be evaluated once and then never again. This is handy for performance reasons if you have a page with a lot of bindings that are going to render once and then you don't expect the data to change. In our case though, this isn't what we want. If I come over now to our robot builder and cycle through the robot heads, you can see that the binding isn't updated. It updated once when the page was rendered and then it's not being updated anymore. So we don't want that here, so let's remove it. But it's good to know about for performance reasons. Now that should be updating again. Okay, cool. So next we're going to take a look at ways to dynamically show and hide our content on our page. Vue supplies two directives that we can use to conditionally show or hide content, vIf and vShow. Let's check them both out and talk about when to use each one. To demonstrate this, let's add an indicator next to this title right here that indicates whether the robot is on sale. If we look at our parts data again, you can see that some of the parts have an on sale attribute. So we'll bind to the on sale property for the heads, and if the head shows that it's on sale, we'll indicate that the robot is on sale. So back in our robot builder, right here next to the interpolation expression that's showing the title, we'll add a span with a class of sale. And then we'll just add the text sale exclamation point inside here. Okay, let's go add that class to our CSS down here. Okay, so if we go look at this right now, it appears that all of the heads are on sale, but that is not accurate. There is actually only one head that's on sale, and it's our friendly bot. So let's use vIf to only show this sale span if the head is on sale. So right here I'm going to add a vIf binding. And then the expression inside of the vIf just needs to be a Boolean. If the expression evaluates to true, the element is shown. So we'll just put selected robot dot head dot on sale. Okay, so now if this on sale element exists on the head and it's set to true, then this span element will be displayed. Otherwise, it will not be displayed. So let's check that out. Okay, cool. That's working better. Now only our friendly bot appears to be on sale, which is correct. Okay, so that's vIf. Now let's check out vShow. It actually works identically. So I could change vIf to vShow. And then if we go look at this, it's still working just the same. So you might wonder, well, what's the point? Well, the difference is what's happening behind the scenes. If we take a look at this element, we'll inspect it here. And then let's navigate to one that is not on sale. Okay, you can see that the element is actually still here, but it has a inline style now that says display none. And so that is how Vue is showing and hiding this element when we're using vShow. It does so by adding style display none. However, if we change this to vIf again, and then look at this again, you can see that actually the element isn't even here. It's been removed completely from the DOM. And as I move through this, if I hit the one that is on sale, then the element shows up again. And so vIf actually adds and removes elements from the DOM, whereas vShow leaves the elements there and just styles them differently. So the question is, when should we use vIf and when should we use vShow? Basically, if the content that you are showing and hiding is expensive to generate and it's going to be shown and hidden frequently, then you should use vShow, because Vue won't have to go through the expensive rendering process each time it's redisplayed. But if your content is not expensive to render, like our current example, or if it's not going to be hidden and redisplayed frequently, then vIf is perfect. Right now, we're just showing and hiding a span element. But imagine if this was a Vue component that we were showing and hiding, and imagine that that component had a child component, which also had child components. You can see how that can get really expensive to re-render. In that case, vShow would be better. In our case, vIf is perfect because it's just a span. It's not expensive to render at all, so we'll leave it with a vIf. Next, let's take a look at how to repeat elements using v4. Let's take a look now at how to repeat an element based on repeating data, such as an array. A great use case for that would be a shopping cart, which would list all of the robots that we've added to our cart. But before we can really have a functional cart page, we need to still learn about routing and state management. So for now, let's just add a cart section to this page, and later we can move it to its own cart page. That way we can add multiple robots to our cart and then see how to use the v-for directive in order to list them all on the page. Let's start by adding an add to cart button. So we'll just put this here at the top. We're actually going to absolute position it. So I'm going to add a button here, and the class for this button is going to be add to cart. And we'll add a click binding, which we'll call an add to cart function. All right, and we'll just have this button say add to cart. Okay, and since we're going to absolute position this button, we need to have a class on its container div that is positioned relative. So we'll add a class, and this will just be content. It's the content of this component. And then down here in our styles, we will add a content class and set it to position relative. And then we're going to add our add to cart class. And we will position that absolute 30 pixels from the right with a width of 220 pixels and a little bit of padding. And we'll set the font size to 16 pixels. Okay, so our button is going to call an add to cart method that we need to add still. So down here in methods, we will add an add to cart function. Okay, and then when we add a robot to the cart, we'll be basically adding it to an array. But a cart needs to know the cost. So let's calculate the cost and add that to the robot. So each of the parts already has cost data associated with it. So we'll calculate the cost like this. We'll create a new variable, cost, and we'll set that to the sum of the cost of all the parts. So let's create a variable up here for the robot, so we don't have to keep saying this dot selected robot. And then here we will set the cost to robot.head.cost plus robot.leftarm.cost plus torso cost plus right arm cost, and finally plus the base cost. Okay, so we now have a cost variable that represents the cost of our robot. Now we can add it to our cart. So up here in our data function, let's add a cart property, and we'll default it to an empty array. And it's important that we initialize this variable here in the data function. If we don't do it here, Vue won't notice that the data is changing. Vue's change detection works by hooking into the getters and setters of properties in the data function. And so even if we were to add a cart variable below by saying this.cart equals a new array, Vue wouldn't even notice it because it never hooked into it. And so any data that you're going to want to bind to that's going to change, that you need to make sure to initialize it in the data function. Otherwise, Vue won't be able to notice when it's changing. So we've initialized that up there. And now down here, we can just push our robot onto that array. So we'll say this.cart.push. And then just for immutability purposes, I want to use object assign here so that the robot that is in the array isn't the same instance as the selected robot property. This isn't really a Vue thing. This is more of a good programming practice in JavaScript to make sure that you don't have inadvertent pointers to the same object in your code. So I'm just going to do an object assign and start with an empty object and assign robot, and then I'll assign the cost. So the result here is that we will have our robot object plus the cost property on that robot. and then we're pushing that onto the cart. Okay, so if we go look at our page, we now have an Add to Cart button, and when we click it, it will calculate the cost of the robot and add that robot with its cost to an array. But of course, clicking that does nothing right now because we're not displaying anything. Actually, it is doing something behind the scenes. We just can't see that it is. So let's go display the contents of our cart. For that, we'll need v4. So back up in our template here at the bottom, let's create a new div. And that's just going to have a header in here that says cart. And then also inside this div, we'll create a table. So this table will display the contents of our cart. So we'll have a table header with a single row and just 2 columns. One that is the name of the robot, and another one will have a class on this one for the cost so that we can align it to the right. Oops, missed an S here. So this will say cost. Okay, so there's our header row, and then we're going to have a T-body here. And then we'll have a table row here. And this is where we want to start repeating data. So basically, we want a new table row here for every robot in our cart. So we can do that with v4. Okay, so now we have the v4 directive, and the binding here is an interesting type of binding that is specific to v4. We're going to add a binding like this. So this is basically saying for each robot in the cart, and then robot is actually a variable that we can use within this element. So we'll get a new table row element for each robot in the cart, and then down here inside the table row, we can create a table data element, and we can say robot.head.title. So this robot here is the same robot here. And then we'll add another table data for the cost, and that will also have class equal to cost. And then that will bind to robot.cost. Okay, so for each robot, it's going to create a new table row element with all of this content inside of that each table row element and the binding specific to each robot. There's just one caveat here. Whenever you're repeating data, Vue needs to be able to, for performance reasons, identify each element in there for updates. And so we need to add a unique key attribute to our repeated table row element. So we can do that like this. We'll just set a key attribute equal to an expression. But what unique value can we provide here for the key? The value needs to be unique for each repeated element. So to make that easy, we can just access the zero-based index of each of the items like this up in our v4 expression. Instead of just grabbing robot, we can also grab an index. So this is a zero-based index for each item in the array. And now I can, on the key here, I can set the key to index. And actually, this key attribute, right now as it is, we're just setting it to the string index. We're not binding, and so we need to add a binding. So this is a vbind binding key to the index expression. Okay, so this v4 should work perfectly now. And for each robot in the cart, we will get a new row. We just need some styles for this. So let's come down here to the bottom, and we're going to add some styles around table data and table header. And we just want to, by default, text align left and have some padding and a little extra padding on the right. And then we need our cost class, and we're going to text align it to the right. Okay, let's go take a look at this. Okay, so here we have our robot, we have our add to cart button up here, and down here we have our cart. So I'm going to go ahead and add this robot to the cart, and you can see we now have a large Cyclops in our cart. And then let's also add a small Cyclops, and we'll change some of the parts on this, and then add that to the cart. Okay, so now you can see we have a large Cyclops and a small Cyclops, each with a different cost. So our v4 directive is working, and it's repeating over each robot that we've added to our cart array. Okay, one last thing that I want to mention is a performance warning that you should never use vif and v4 on the same element. So up here on our v4, right here, I should not ever do a vif here also. If you need to hide and show data on the same element that's using v4, you need to use some other mechanism, such as using an internal element or something like that, so that's not on the same element as v4. This is just a performance warning that you'll see in the Vue docs, so it's just good to be aware of that. All right, next we'll take a look at a number of considerations around styling our components. By now you've probably gotten used to the idea that we can style our components down here in the style section. Although we haven't talked about this directly, as we've proceeded this far in the course, we've been adding to these styles, and you've seen how it immediately affects the component. But we haven't really explored what's actually happening here, or how far-reaching these styles are. To explore this a little more, let's jump over to our app component. Notice in the styles of our app component that we're styling things like this main tag and the header tag. And you can see those main and header tags up here in our template. But what about this body tag? That body tag does not show up at all up here in our template. And yet, if we look at our app, the gradient that we're adding to the body tag is showing up here in the background of our app. So how is it that the body style that we're adding here is getting applied to a body tag that's not part of this component? The body tag is actually part of this index.html file that was generated by the CLI. So notice we have a body tag here. So this index.html file is what is actually loaded when our app first loads, and it has a body tag. And then you can see down here on line 14 that we have this app element.
And in our main.js file, this is the element where we mounted our Vue app.
But it's concerning that we have a style in our app Vue component that is styling something outside of that component. But not to worry, there's an easy solution to this. Back here in our app component, on the style tag right here, we can add a scoped attribute. And if we go back now to our page, you can see we've lost our gradient. So we just essentially scoped all of the styles inside this style element to only this app component. That's pretty awesome, but how does Vue accomplish it? Let's take a look at the source of our page in the browser. So I'm going to inspect this, and then notice on this header element that it has a data attribute with a hash after it. And if I go back over here and remove this scoped attribute and then refresh, notice that the randomized hash has disappeared. So first of all, the scoped attribute is adding those data attributes. So if we go back over here and put that scoped attribute back, and then take note of the header styles that are being applied here, the background color, the width, and the margin. Now if we go look at the source again and refresh, take a look over here in the inspector that is showing the styles for header. Notice that it's not just being applied to any header element. It's actually only being applied to header elements with this data attribute. So that's how Vue handles scoping styles. It puts these randomized hashes on scoped elements and then targets them specifically with that hash. So a header element on another component would either not have this data attribute at all, or it would have a different data attribute because it's in a different scope. And the same concept applies to child components, as we'll see in the next clip. With some exceptions, if you add the scoped element to a parent component, its styles won't bleed into the child component. We'll take a closer look at this in a minute, but first let's talk a bit about scoped versus global styles. As a general rule, you should not have global styles in any component other than your top-level app component. So let's go fix our robot builder so that it has scoped styles. So over here, in the style element, we'll add the scoped attribute. And so now we don't have global styles in our robot builder. But the app component is a good place to have some global styles. So let's do that. And the interesting thing is that in our app component, we want some global styles, but we also want some styles that apply only to the app component. But that's okay. You can do that. You can have multiple style blocks, and one can be scoped and the other not. So now we have a global style block here and a scoped style block down here. And let's move this body style up here to our global style. And the rest of these styles are specific to the app component. And so we want to leave those in the scoped style block. So now if we go back and refresh, and let's close our console, you can see that we have our gradient background again. And so the body style is being applied globally, whereas the rest of these are only being applied to this component. Okay, cool. So now we'll take a look at how this all affects child components. It's important to understand what it means when you add the scoped attribute to a parent component and how that affects child components. Right now, our robot builder is a child component of our app component. And if we take a look at our robot builder, you can see right here we have this robot name class. Let's add an element in our app component with that same class. So right here, just above our robot builder, we're going to create a div element with a class of robot name, which happens to match the robot name class inside our robot builder. And then we'll close that div here, and we'll just say this is a test. And then down here in the scoped styles, we will add that robot name class with color red. Okay, so if we go take a look at this, you can see that the robot name styles got applied to the element in the app component, but not to the element with the matching class name in the child component. So this is what we would expect. It is scoped to our parent component. But I want to point out something. Watch what happens if I come up here and wrap this div around the robot builder. So now this div is wrapping the robot builder. So let's see if that changed anything. Now you can see that both the parent component and the child component got styled. So it appears that the parent component's styles are bleeding into the child component. And this is sort of true, but not really. At least it's not true as far as Vue is concerned. Let's see what happens if we also add a border to this style. So down here, I'm going to also add border, and we'll add a 2-pixel solid blue border. So now if we come back over here, notice that we do have a border that is wrapping the div in the app component, and that div stretches across this because the robot builder is wrapped by this div. But the interesting thing is that even though the border is being applied to the robot name class, it is not bleeding down into the child component's robot name class. Otherwise, we would see a border around this robot title here. So it seems that the font color is bleeding into the child component, but the border is not. So when Vue says that its styles are scoped, what it means is that it's not going to apply that style directly to classes or elements outside of the scope. But that doesn't mean that the child elements won't be affected due to CSS inheritance. That's just the nature of CSS. In CSS, there are a number of CSS properties that get inherited. Font color, for example, is inherited, whereas border is not. That's why you see a difference here. So know that when you style something in a parent component that wraps a child component, traditional CSS inheritance will still be at play. But Vue won't specifically target elements outside of the component if the style is scoped. So it's important to understand that difference between Vue targeting an element or applying classes to an element in a child versus styles just getting inherited because they are applied to a parent element by CSS. But what if you do want to be able to style a child component from the parent? Vue does allow a parent to style child component within the bounds of scope CSS. So let's take a look at how to do that. The easiest way to think about this is to consider the root element of a child component part of the parent scope. So over here in our robot builder, this element is the root component, or the root element of our robot builder. And notice that it has a content class. So if we go to its parent component, the app component, and let's remove this test div, we don't need this anymore. And now down here, instead of robot name here, let's change this to just content. So now we're applying these styles to the content class. And there is no content class in our app component. It's only in our robot builder. So let's go back over here. And there, now you can see that the red text and blue border are being applied to the content class in our child component. This is only because that content class is on the root component of the child. And so you can use the root component of a child component to allow a parent to apply styles to the child component. But what if we want to access this robot name from our parent and style it? So over in our app view, we could add .content.robot name. So generally, you can target things in CSS like this, where you can target a robot name class that's contained within the content class. And since we're able to target the content class from the parent, the question is, are we able to target elements inside of that content class? So we would expect now to see a blue border and red text around the robot name. So if we come take a look at this, you can see that our style is not getting applied anywhere. If you want to be able to do deep targeting like this, you need to use the deep selector that looks like this. So now if we take a look at it, there, now you can see that we can target it. So you can target child elements within scoped styles like this by starting with the class of the root element and then using the deep selector to select other items within the child component. But you need to be aware that this deep component is truly deep. Like, it is not just the child component, but this will also affect child components of your child component. So it will keep going down the chain. And it's possible that this won't work with some CSS preprocessors. And so in that case, there is also the deep selector, and that has the same effect. Okay, we don't want to keep this here, so let's delete that. That covers everything for styling child components. Next, let's take a look at conditionally applying styles to elements. Sometimes we want to apply a style to an element based upon a certain condition. That's quite easy to do with Vue. Let's use a style binding to make it so that the border around the head turns red if it's on sale. So over here in our template, we're going to style this div right here. It's the one that contains the head. So a style binding looks like this. And really, this is just binding to the style attribute. And you provide an object, and we're going to set the border to a 3-pixel solid red border. And this should be working if we go over here and take a look at it. However, it's not yet conditional, right? So every head has a red border, not just the ones that are on sale. And so we'll get to conditional in just a second. But first I want to mention that there are some CSS attributes that have hyphens in them. For example, background color. But this isn't valid JavaScript. For this to be valid JavaScript, you have to add brackets around this because this is object notation here. But Vue actually makes this easier by allowing you to use camel case for CSS attribute names that have hyphens in them. So just keep that in mind. We don't need this though, so we'll just change this back to border. So for this to be conditional, we need to not just have it be hard-coded to a string. So we can just change that to bind to a computed property on the component. So instead of this object here, we're just going to bind this to head border style. Now the style binding will be set to whatever object is returned by head border style. So let's go add a computed property for that. So that's a method, and it's just going to, for now, we'll have it just return border, and we'll hard code that again to 3pix solid red. Okay, so this still isn't dynamic. We still are just getting a red border on everything. But now, because this is a computed property, we could just use a ternary here. So let's bring this down onto a separate line. And instead of always setting border to this string, we'll set it to a ternary statement. We'll say if this dot selected robot dot head is on sale, then return 3pix solid red. Otherwise, return 3 pics solid gray. Okay, let's go check that out. Okay, looks like this is working great now. So now only the item that's on sale has a red border. Okay, one last thing to be aware of is up here in our style binding. Sometimes it's necessary to apply styles based on multiple calculations. In that case, we could add an array or bind this to an array instead. And this could be a second calculated property so that it applies these styles, the head border style first, and then more styles second. And more styles will override head border style. So the second one overrides the first if there are any conflicts. We don't have a need for that though, so we'll just go with the simple object syntax. Of course, it's better to use classes than inline styles. So now let's take a look at how to conditionally apply CSS classes. Let's see how to replace this style binding with a class binding so that we can use classes instead of inline styles. First, let's start by adding a class down here. We'll call it Sail Border. And that will just have a border that is 3 pixels solid red. And then back up here where our style binding is, instead of this, we'll use a class binding. And then a class binding is basically an object where the keys are the names of the classes that you would like to toggle. So in this case, we have a Sail Border class. And then you just set that to a Boolean expression that will evaluate to true when you want this class to be applied. So in this case, we want it to be applied when the selected robot head is on sale. So this is just saying apply the Sail Border class when the on sale property is true. And if we wanted to toggle multiple classes, we would just add more properties to this object. So this should be working just like the style binding was. So the friendly bot is on sale and the rest are not on sale. Perfect. Now, one thing that you might not have noticed if we inspect this div where we applied the Sail Border also has the classes top and part. If we go over and take a look at our template, you can see that this element has both a class binding and a class attribute on it. So the top and part classes are going to always be applied, and the Sail Border property is going to be applied conditionally, so you can combine them like this. Of course, this class object could get fairly complex if you were toggling lots of classes. So you could always move this expression to a computed property like we did with the style binding. But like style bindings, there's another syntax that we could use here, an array syntax. So I could just provide an array here, and that array contains the classes that I would like to apply. So this is not conditional. This will always apply a class, so we should be seeing that everywhere. But we could then take this and let's undo a little bit and grab this expression. And with this array syntax, let's use a computed property like we did with our style binding. So I'm going to create a computed property called Sail Border class. And we will add the value of that to our array. So now down in our computed properties, I can change this to Sail Border class. And then this is just going to return the Sail Border string if the robot head is on sale. So we'll just use a ternary like this. So if it's on sale, then return Sail Border. Otherwise, it'll return an empty string. And we need this here. Okay, so that should be conditional again. There we go. And now that we have that using the array syntax, we could actually collapse these class expressions into a single expression. So I'm going to take these out of here and make them strings in here. And then I can get rid of this class attribute. And now it's all taken care of in our class binding. Cool, I like that final syntax. So let's go with that. And next we'll take a look at using CSS preprocessors like SASS. Vue.js fully supports using CSS preprocessors if, for example, you want to use something like SASS instead of plain old CSS. In fact, the zero config Webpack configuration that comes with the Basic CLI includes all of the Webpack config to support SASS, less, and stylus. All you have to do is npm install the appropriate loaders if you want to use them. So here in our terminal, I'm going to just npm install node SASS and SASS loader and save that. Let's go ahead and install that. And since the built-in Webpack config is already set up to handle the SASS loader, we can just jump in using that in our project. So all we have to do to support SASS is come down to the style section, and up here at the top where we define our style tag, all we need to do is specify the language used here. So I can say lang equals SCSS. And now I can start using SASS syntax in here. So I could, for example, wrap this inside of the part class. And then if we come back over here and start our server again, and then come back over to our browser and refresh, you can see that all our styles, so these images are still the correct size, even though we added the SASS syntax for sizing them. So that was surprisingly easy, and you can see how the zero config environment made that really simple. Of course, if you wanted to use a CSS preprocessor other than SASS, less, or stylus, you could do that, but you would have to go in and modify the Webpack config, and we'll talk about that in the deploying to production module. But out of the box, those three are already supported. And now our robot builder is using SASS. This wraps up our discussion of styling our components. We're going to next take a look at the different component lifecycle hooks that we can tap into. There are several lifecycle hooks that we can tap into to take an action based on the various lifecycle states of a component. Let's take a look at the created lifecycle hook. A typical use case for lifecycle hooks is to fetch data from an API when a component is first created. But we're not ready to do that just yet. We'll implement that exact use case later in the module about state management when we start using an API. For now, let's just make it so that whenever this robot builder component is created, we log something to the console. So all we need to do is add a created function like this. And then we can just console log in here. And tapping into a lifecycle hook is that easy. Let's go check this out over in our browser. So let's open our console and clear it. And then I'm going to refresh this. And when this page loaded, the robot builder component was created. And then you can see down here we got this component created message. And again, this isn't a great use case, obviously, but it's pretty common that you'll do things in here like fetch data from an API that's needed for this component. There are a handful of lifecycle hooks, but covering all of them is beyond the scope of this course. If you want to explore more about lifecycle hooks, you can check it out here in the Vue documentation. They provide this lifecycle diagram that shows all of the different lifecycle hooks: before create, created, before mount, mounted, before update, updated, before mount, and unmounted. And it shows you in this diagram here where in the life cycle of a component each of these hooks get called. And at this page here, you can find out more about each one of these lifecycle hooks, where it describes each of them in detail. And again, we'll touch on this more later in the course. If you want to look at it right now to explore lifecycle states further, you can check it out in the passing data to parent components clip, which is inside the enabling intercomponent communication module, or you can also look at it in the state management module when we start talking about making API calls. For now, let's move on and take a look at Mixins. Mixins are a way to share functionality across multiple components. Basically, any component option can be extracted out into a Mixin file, and then when you import the Mixin, they will be merged into the rest of your component options. Let's see how to do that. Let's take this created lifecycle hook and move it into a Mixin. So we'll grab it from here, and then let's create a new file called created hook mixin.js. And then here we'll just export an object. So basically we're just exporting a component configuration object here, and whatever is in this object will be merged in with any components that you use it in. So to use it, let's go back into our robot builder, and we're going to import our created hook mixin from created hook mixin. And then we're just going to use this down here in a Mixin property. So Mixins, and then this is just an array of Mixins, and we're only going to have one, the created hook Mixin. Cool, now this Mixin could be used in multiple components. Right now we're just going to be using it in this one. And if we come back over to our web app and open our console and refresh, you can see our component created message is still getting logged. And so our created hook is still working, but it is now extracted out into a Mixin that could be reused. Again, our application isn't quite mature enough yet for a great example for Mixins. If you want to see a better example of this, in the Managing State with Vuex module, we talk about it when we have a few components that all need the same data. So we'll create a Mixin in order to share the logic that will be used to fetch that data across multiple components. You can find that in the clip on using actions to work with APIs and asynchronous data. I just wanted to talk about it a little bit here in the components section so that you knew about it. And just be aware, you can use a Mixin to share any component option across multiple components, including lifecycle hooks, props, computed properties, etc.
The real value of the composition API is the ability to group logical concerns together in code, but still have them come together in a single component. Consider this search component here, which is using the composition API. I apologize for the small font here, but I'm trying to give you an idea of a somewhat complex component. This component is really handling three major concerns in a single component. In orange, you have the search-related code. In blue, you have the code related to filtering, and in green, you have code related to pagination. Even in the small amount of code we have here, it's getting difficult to reason about these three major concepts. It's a little easier right now because it's color-coded, but in your editor, it'll look more like this. Now looking at this, try to reason about all of the filter-specific functionality, for example. It's getting difficult because the filter-specific logic is spread throughout this component along with the search and pagination logic. And now imagine that this component is hundreds of lines long instead of the couple of dozen lines that we see here. The composition API can help us separate these different logical concerns while still having a single cohesive component. So we can take all of the orange lines on the left and create a composition function from them named useSearch like this. This function could be in the same search component file, but you can see I'm exporting it, so I've opted to put it in a separate file. And then we can do the same thing with the filter logic and the pagination logic. Now all the stuff on the right replaces everything on the left. We are missing some important pieces with regards to reactivity, so the code you see on the right won't quite work. We'll get into that in the next clip, but this gives you an idea of how we can start breaking things up into logical concerns. And now you can see how the three different major pieces are much easier to reason about individually. So now how do we pull each of these into our search component on the left? Well, if there was just one of them, we could simply import it and then call it, returning its value. So now when setup runs in our component, it will call the useSearch function, which will execute a search and then do whatever it needs to on mount and return the search related data and methods. And then those fields will get returned by our component setup method, making them available to the template. But then how do we call and return the data from use filters and use pagination? Well, we could simply import them, and then down here where we call them, we could return a new object and then spread the results like this. But there is one problem with this. It would technically work, but if you're looking at the template for this component and saw that there was, for example, a result count field, you couldn't really tell by looking at the setup function which of these three functions is returning the result count property. So it's a better practice to call them each separately and then destructure them like this, and then return each of the results individually. This is a little more verbose, but you can now see which of the composition functions each of the fields comes from, which is better for maintenance in the long run. Plus, this gives us access to these properties internally. So the search results returned here, I can then use, for example, to pass into our useFilters function, like this. Okay, so this is the basics of the composition API, and we're going to show all of this working in a real component in our app here soon. Before we do this though, we're missing something critical in our examples. So let's learn about the Reactivity API, which is critical to making all of this work. Alright, so we just learned about the composition API and how we can use that to break up large, complex components into logical concerns using composition functions. But there was an important piece missing from the discussion, and that is reactivity. Reactivity basically refers to Vue's ability to notice and react to data changes in our app. So notice this very simple component, which is using the composition API. In the template, you can see that we're just displaying a count field, and we have a button that is calling an increment function to increment that count. And in our setup function, you can see that we're declaring a count property, and here's our increment function, which simply increments our count field. And then we're returning them both to make them accessible in the template. So this will compile and run, but it won't actually work because Vue will not be aware of changes to our count property. Actually, most of this will work. When a user clicks on the increment count button, it will call the increment function, and the count variable will be incremented. But the browser won't be updated, so the user will have no idea that the count field is indeed being incremented. That's because we haven't done anything to make Vue aware that it should track our count field and re-render things in the browser when the count field changes. If you consider a comparable Options API example, it would look something like this. And the key point here is that with the Options API, when we declare our count field in the data section, Vue essentially wraps the count property in a reactive object, which it can then use to track and respond to when it observes changes. But the same isn't true in the setup function in our composition API component. Variables in our setup function are not automatically wrapped in reactivity. And that makes sense when you think about it, because you could declare lots of variables in here that are just used internally in this function and don't need to be reactive, and making them all reactive would be inefficient from a performance perspective. And so Vue gives us control over what we want to observe and be reactive to. There are 3 different functions that we can import to do this, including reactive, ref, and computed. Reactive is used to make objects reactive. It cannot, however, be used to make primitives reactive. Primitives are basic data types like numbers, strings, and booleans. Ref can be used to make objects or primitives reactive. And computed is like computed properties in the Options API. They are used to execute functions when any of the values in the function's dependencies change. We'll demonstrate each of these in a moment, but you may already be asking, if ref and reactive can both make objects reactive, why use reactive? Well, there is discussion in the community about that, and my current thinking is that I probably would not use reactive in my apps. To understand why, let's explore a little bit more about how each of these works. So back to our simple example. This count field is not reactive. So when we click the button to increment it, it will increment in memory, but Vue won't know that it needs to re-render anything. So since count is being set to 0, which is a primitive, we need to use a ref to make it reactive. So we'll import ref from Vue, and then we'll just wrap this 0 in a call to ref like this. And that's it. We have now made Vue aware that we want it to track this property and perform any necessary re-renders when its value changes. Well, I said that's it, but it's not exactly the only change we need to make because count is no longer just a primitive. Instead, it is now an object, and that object has a property named value, which is where the number we're interested in is actually stored. So whenever we access our count in code, like we are here, we need to actually access the value property on our now reactive object like this. This can feel a little bit cumbersome and difficult to remember at first, but it's something you get used to. It's actually the only thing that I don't like about using the composition and reactivity APIs, but it's not enough to turn me away from using them. And it only comes up when you reference the variables in code. Note that I do not need to add .value up here in the template. That's because our setup function unwraps it for us. So remember, when using ref, you have to use .value in code, but not in the template. And now this will work fine. Our count variable is reactive, and when the user clicks the button to increment the count, Vue will notice the change and re-render the appropriate parts of the template. Now let's take a look at an object example. In this example, we're displaying the user's first and last name, and we have buttons to set the first and last names. But this user object that we've declared here is not reactive. And since it's an object, we could use either reactive or ref. To start with, we'll import reactive, and then we'll wrap our object in a reactive call. So this part is identical to ref. And really, since ref can be used for either primitives or objects, we could have used ref here. But there is one key difference with reactive. When using reactive, we are not required to use .value when we reference it in code. The way this code is right now will work just fine. No need to use .value here. This is really nice, so you might wonder why I say I prefer not to use reactive. And indeed, I'm going to recommend that we use ref here too, which means that we need to add .value in these two places. So why do I prefer ref? Well, first of all, I have no issue if anybody wants to use reactive in their applications. I can definitely see value in it. But there are two reasons why I prefer ref, and those are consistency and flexibility. To understand that, let's first look at the computed function. Here's a final example similar to our last one, but notice that we're displaying the user's full name here, and it's calculated down here. But this won't work even though we've already made the user property reactive using the ref function. And when you think about it, it kind of makes sense. This is because when we set this full name property to this expression, we're not setting it to a reference to this expression or anything. In other words, full name is not a pointer to this expression. Rather, we're just setting full name to the string that results from this expression. And that string is not reactive. We can solve this by using a computed property. So we'll import computed and then wrap this expression in a computed function like this. Now this will work great. Just note that the user object still needs to be reactive even though we're using a computed property here. And this makes sense because the computed property needs to be recalculated whenever the user object changes. And making the user object reactive with ref allows Vue to know when to recalculate the computed property. Okay, now that we understand reactive, ref, and computed, let's revisit why I prefer to use ref over reactive. Consider this table which shows the attributes of each of the different reactivity methods. The reactive function works with objects, and it does not require or allow you to use .value to access the wrapped value. Ref works with primitives and objects, and it requires the use of .value. Computed allows us to create computed properties, and it requires the use of .value. So reactive is inconsistent with these other two, in that it does not use .value to access the wrapped or computed value. So if we only use ref and computed, this gives us reactivity for objects, primitives, and computed properties, and in all cases we will expect to use .value. We don't have to try to remember in which cases we should use it and in which cases we should not. So that's the first reason, consistency. But let's also consider the flexibility that this approach gives us. Consider this example, which is using a reactive array of products, and it also has a filter function that is returned to the template. The intent of this function is to filter the products array for items containing the text passed in. So let's think of how we would have to do this. With both ref and reactive, we can't change the reference of the products variable. So for example, we can't do this. This actually changes the product variable to point to a new array in memory, and this breaks reactivity. With all three of our reactivity methods, ref, reactive, and computed, it's important that you do not change the reference for those variables. So really, this products variable should be declared as a constant, which means we'll need to change our filter function to something more complex like this. Notice that we're now filtering the products here, which returns a new array. And then we're having to use the array splice function here. We're using splice because it mutates the array in place, which retains the variable reference on the products variable. And we're required to do things like this when using reactive. Compare that to this ref example. Because ref uses .value, we can replace what is stored in the value property without actually changing the products variable reference. This allows me to use the much more simple filter syntax, which returns a new array and replaces what is stored in .value. Of course, I could also mutate the value as well, using splice in this case, which is the flexibility that I like with ref. You can see how being able to use .value here allowed me to create a little simpler code. So my recommendation is to focus on using ref and computed. Of course, if you really like reactive and you disagree with my recommendation, there's no reason for you not to use it. Just remember that you won't need to use .value on the objects that you wrap with reactive, and you will with ref and computed when using them in code. And again, you never have to use .value in the template. Okay, we've covered a lot of info here with regards to the composition and reactivity APIs. Let's jump into code and take a look at an actual working search component using all of this. Now that we've seen the basics of how the composition and reactivity APIs work, let's see it in practice. So for this, let's create a new search folder right here. And then I've already built a functioning search component for this, complete with composition functions and reactivity. So let's jump over to our helper repo. And in our source folder, we have this search folder. And in here, you can see we have 4 files, a search component and 3 composition functions. So let's go ahead and download these and put them in the new search folder that we just created. I'll go ahead and do that off camera. All right, so you can see I've downloaded these 4 files here. Let's go ahead and open up our search component. And before I dig into this, I also want to point out that I've updated our app component to temporarily display this new component. So you can see I've commented out the robot builder component and import and replaced it with the search component. So if we take a look at our running app, you can see that we're rendering this functioning search component. And if I type in our search box up here, you can see it filters the robots or searches for them. And then here I can click on these filters to filter them, and I can clear the filters here. And then notice that we have some pagination down here. So let's take a look at the new files that created this. So back to our search component. You can see that in our template we have a search box and the filter buttons here. And then if I scroll down, this is where we're rendering the search results by looping over a page results field with v4. And then you can see here is the pagination section. Okay, so that's the template. Now let's take a look down here in our component code and see how this is working. So first of all, notice that I'm importing 3 composition functions for searching, filtering, and pagination. And then down here is our setup function, which is our clue that this component is using the composition API. And right off the bat, you can see we're using the useSearch composition function, which is returning the search results and a search function. Notice that I'm passing a search term from props into the useSearch function, which makes it so that later if I added routing, I could land on the search page with an existing search term. We're not really using this yet, but I put it here just to demonstrate the use of props and that we can pass those into our composition functions. And then notice that this search function is being returned down here so that our template can access it. And if we take a look at the search box at the top of our template, you can see that the input event of this text box is bound to that search function. So basically, whenever the user types something in the search box, we call our search function from our useSearch composition function and pass in the value from the input box. All right, so back down here, we also have the search results field being returned from our useSearch function. We're not actually returning that to our template. Instead, we're passing the search results into our useFilters composition function when we call it right here, so that that function can filter the search results further. So we'll dig into that in a minute, but first let's go understand what our useSearch composition function is doing. So we'll open up useSearch here, and then to simplify this a little bit at first, let's minimize this search inventory function. And let's just call out a few things. First of all, notice that we're declaring a results array right here, and we're using ref to make it reactive. That array is then updated inside this search inventory function that we'll get into in a moment here. But notice that right after declaring the search inventory function, we call it with the original search term passed in from props. That's because we want it to perform an initial search right when the component first loads. Keep in mind that the composition function itself is only executed once. So this will execute when the component first calls our composition function when it's first loading. Okay, then notice that we're hooking into the on-mounted lifecycle hook. And we're not doing much with that, it's just here for demonstration purposes. And finally, we return 2 things from our useSearch function. We return the results from our search, and we return our search inventory function, aliased as just simply search. So now the search results and the search function are available to our component. And if you remember, we bound this search function to our search input in our component's template. All right, now let's dig into this search inventory function. You don't need to worry too much about what's happening here unless you're interested, other than to know that this section uses the search term to search through our array of parts, which is created up here from our parts data, and then it updates our results array with the search results. Notice that because I'm using ref, I can simply set the value to the new array containing the search results. If I was using reactive here, I'd have to do some funky splicing to avoid breaking the results variable reference like we talked about in our previous clip. And that's it. The search results and the search function are then returned from our composition function. And you can see how this is really nice and cohesive. We're not having to filter through filter and pagination logic while we try to understand search logic. Cool, now back to our search component. You can see that the next thing that we do is call the useFilters function, where we pass in the search results from useSearch, so that the useFilters function can filter the search results further. And that function returns the list of current filters, 2 functions for applying and clearing filters, and the filtered results. All of these are returned below so that they can be used in the template. So let's jump into this useFilters composition function so we can see how that's working. Okay, don't worry too much about this filter results function unless it's something you want to dig into. There's nothing particularly interesting going on here with regards to the composition and reactivity APIs. It's just the logic filtering the results. So I'm going to just collapse that for now. And here's our useFilters composition function right here. So in here, we're just declaring a reactive filters array with ref. And here are our 2 apply filters and clear filters functions, which both modify our filters array. Or more explicitly, they modify the value property on our filters ref object. And then notice that we're using a computed function right here, and that is computing our filtered results. So remember that I said that computed will recalculate whenever its dependencies change. So what are its dependencies? Well, it's these search results and filters fields, both of which are refs, so Vue will know when they change, causing the filtered results to be recomputed. So the filtered results get stored in this filtered results computed property, and then we return that down here. And back in our search component, you can see that down here, we're calling our usePagination composition function and passing in those filtered results. The usePagination function is responsible for breaking those results up into pages, and you can see it returns the current page number, 2 functions, next page and previous page, the start and end index of the current page of results, and the actual page results for the current page. So let's jump into this usePagination function. So first off, notice that our current page variable is wrapped with ref, so it is reactive. Next, we have our next page and previous page functions that increment that current page variable. And then down here we have 2 computed properties that calculate the human readable or one-based start and end indexes based on the current page and page size. And finally, down here we have a page results computed property right here. This is where the real work of this function occurs. It converts the start and end indexes to 0-based and uses those to return the appropriate slice of the array given those indexes. And then all of those fields are returned down here, and then eventually returned from our search component down here so the template can access them. So that's it for our search component. And you can see how nice it is to have each of these 3 concepts broken up into their own cohesive functions where it's easy to reason about them independently. But you can also see how the composition API makes it so that we can pull them all together to compose a single component. Feel free to play around with this component a little if you'd like to get to know it a little bit better. But you can see how easy it was to create that and have this nice functioning search page with independent pieces that are easy to reason about. All right, I'm just going to go back to our app component, and we'll delete the search stuff in here from now and uncomment the robot builder so that we can continue using it in the rest of the course. All right, now that we know the various ways to create components, in the next module, we'll learn more about inter-component communication.
In this module, we learned about the following component concepts: creating components, using bindings to display data and handle events, conditionally displaying elements with vIf and vShow, repeating elements with v-for, the various ways to style components, working with component lifecycle hooks,
reducing duplication with Mixins, and using the composition and reactivity APIs.
In the next module, we'll explore various ways to communicate between components.
There are a few topics to cover, including using props to share data with child components, validating component props, passing data to parent components with events, injecting content into a child component with slots, using teleport to render content outside of the current component, and using provide and inject to pass data to deeply nested components. Understanding how to do all this will allow us to build rich client-side applications with Vue. So let's dive in.
So far, we haven't really done much with creating child components, other than the fact that our app component uses our robot builder component. If we take a look at this robot builder template, you can see a lot of repeating code here for each of the individual part selectors. Let's turn this into a part selector component and reuse it in each of these places. When we do that, we'll need to pass down to the part selector component the parts that we want it to select from, and that will be a great way to show how to communicate between components. So we'll start by creating a part selector component, and rather than completing this whole thing from scratch, let's start with a partially completed component. So over here in our helper repo, in the source build folder, we have this part selector Vue file. So let's grab that and paste that into our new component. So if we take a look at what we've pasted in here, you can see that at the top here, we have some HTML that looks a lot like the HTML that was being repeated multiple times over in our robot builder. And then down here in the component script, you can see that we have some functions for getting the next and previous index, and down here, methods on our component for selecting the next part and the previous part that call those functions. This should look a little bit familiar because this same code, or code a lot like it, existed over in our robot builder. So we've just moved that over into our part selector. And then notice up here, we're importing all of the available parts, and we're setting here on line 13 this parts variable to the heads from the available parts. This is just temporary so we can get up and going. The parts for the part selector will actually be passed into us by its parent component. So we'll delete this pretty quick here. So just to bring you up to speed with what the plan is, if we look at our robot builder, each one of these parts is going to be a different instance of the part selector. And the robot builder will be responsible for giving each instance of the part selector the correct list of parts for it to work with. So in the robot builder, when we create this instance of the part selector, it will pass in a list of heads. And when it creates this one, it'll pass in a list of arms, etc. This will be a great way to learn how to communicate with child components. And now that the part selector will be taking care of all of the selecting of the parts, then over in our robot builder, we can delete a bunch of stuff here. So we can delete these functions here that we saw exist now over in the part selector. And then we can delete all of these functions down here. And notice how many of these there are that we're going to be deleting. And all of these will be replaced with just 2 functions in the part selector. So you can see how this is going to be eliminating duplication, and it's going to be a lot cleaner. All right, and then we're not going to need these selected indexes here either. And then we're just going to initialize each one of these parts in our selected robot to just an empty object. So each one of these will be just initialized like this. And actually, now that this doesn't have any complex calculations anymore, it doesn't really need to be a computed property. So let's just move this up to our data object. And this will just be a property instead of a function. And it'll just return this object. And now we're just going to go ahead and import our part selector. All right, and then this is something that you may not have noticed in the app component. But whenever you reference a child component, not only do you need to import it, you also need to list it in a components array on the parent component like this. This is what makes our component aware of this selector so that we can now use it up here. Okay, so now we're going to replace each one of these with just a part selector. So we have 1 at the bottom for our base, 3 in the middle for the left arm, torso, and right arm. And then up here in the head, we have a little bit more going on. So we can go ahead and replace all of this here with the part selector. And we can get rid of this div here. This stuff, however, we're going to want to reuse later. And so I'm just going to comment that out for now. Okay, so now we can use these part selector elements because we have declared them down here. Oh, and actually this is not supposed to be an array. This is an object. So this is really an object that where we're saying that we have a part selector component that is set to that part selector, but we can just use the shorthand syntax like this. But you can see already how much cleaner our template is because we cleaned up so much duplication. So let's go check this out. Okay, well, we've got all heads again. So not exactly what we want, but it is what we expected, since our part selector is currently just hard-coded to return heads. To fix that, each instance of our part selector needs to receive its list of parts from its parent component. So we'll do that next, but you'll also notice that our arrows on our buttons are missing, and the buttons aren't exactly in the right place. So depending on where the part selector is, sometimes the buttons need to be on the top and bottom of the image, and sometimes they need to be on the left and right. So the part selector will also need to know what position it's in before it knows what type of buttons to display. So we'll fix that too. We'll get into all of that in the next clip when we start talking about how to pass data down to child components. We need to update our robot builder to pass in the parts to the part selector for it to cycle through. So we'll start with this first one, which should allow the user to select which robot head they want. So that means over in our robot builder, right here, we want to tell the part selector which parts to use. And we'd like to do that like this. So available parts is already available to us in our robot builder's data object. And then we're just grabbing the heads off of it. And then notice that we're binding it to a parts attribute of the part selector. This won't work yet because the part selector doesn't have a parts attribute to bind to. We'll add that next. We can do that over in the part selector by just adding props to the component like this. And then the most simple syntax for this is just to pass in a string array. And that's all there is to making props available to be bound to by parent components. And now that we have that, we can stop hard coding the parts up here, which means we don't need this import here. And then down here inside the component, wherever we're using parts, this needs to be the start parts now, since we're getting that off the props. Okay, so now that we have that prop, let's go ahead and pass in the correct parts in each of these instances. I'll just copy and paste this. And this is torsos, and this is arms again, and then this one is bases. Cool, let's go see how this looks. Awesome, now we're getting the correct parts, even though the arms aren't quite positioned right. And even though our buttons are still missing their arrow icons and aren't quite positioned right, if I click them, they do work. And you can see our part selector even supports indicating if a part is on sale. Now, in order to fix the arm positions and display the buttons correctly, we need to apply a CSS class to each one of these part selectors based on the position of each part selector. So, for example, this part selector for the head is in the top position. This left arm selector is in the left position. This one's in the center position, this one's in the right position, and this one's in the bottom position. And if we take a look at the part selector down in the styles, you can see that I've already created CSS classes to handle displaying those correctly. But these position classes aren't being applied yet anywhere in our part selector component. And that's partly because the part selector component doesn't know what position it's in. So let's come back over to the robot builder. And in addition to specifying the parts for each one, let's specify the position. So I'm going to set position equal to top. And notice there's something different about this binding. Notice the parts binding is using a colon, but the position is not. That's because position isn't really actually a binding. It's really just an attribute on the parts selector, and we're setting it to the hard-coded string top. Whereas parts is an attribute, but we're binding to that attribute and passing along available parts.heads, which is an expression that needs to be evaluated. So let's go ahead and add this position to each of these others too. So we've got left and center, and then this is going to be right. And then finally down here for our base, this is going to be bottom. Okay, now we're passing to our part selector what position it's in. So over here we need to add a position prop so it can receive that value. And now we're just going to use that in a class binding. So up here in the template, right here on this div, in addition to the part class, I also want to bind to the position. So remember, we can specify both a class and a class binding, and they'll get combined. And so in the case of the head, this div will have two classes, a part class and a top class. So whatever value is passed into the part selector for the position prop will become a class here. And then based on those classes and the styles that we specified below, everything will get styled correctly. So let's go take a look at our component again. There we go. Now our buttons are all positioned. You can see that some are on top and some are on bottom versus left and right, and the arrows are all there. And that all came from our CSS styling. So just to review the important parts of this, we can pass data into child components using attributes like this. And for each attribute, you just need to specify props in the child component. It's really that simple to pass data to a child component. We can, however, take this a little bit further and actually validate the props that are passed in to make sure that they're the right type, etc. Let's take a look at that next. Our part selector component now takes in two props, parts and position. But there are no restrictions on the type of data or values that could be passed into these props. We'd like to provide some validation to prevent parent components from passing in bad data. That's actually quite easy to do with a little different syntax. Let's start by requiring the parts prop to be an array and the position prop to be a string. So instead of using an array here, we'll use a keyed object, where the keys are the names of the props, and the values are objects that specify validation information. So for the parts prop, we expect its type to be an array. And for position, we expect its type to be a string. And now that we have these in place, if we come back over to our robot builder, and on one of these, instead of passing in an array for the parts, we'll just pass in a string. And now if we come back over here, obviously our left arm selector isn't going to be working because it's a string, not an array of parts. But if we take a look in our browser, you can see that we have a validation message here because we passed in an invalid data type for the parts. And you can see right here it says expected array, but got string. So we now have type checking that can help us identify problems during development. So let's go back and fix that. And then we can also make our props required. So here I'm going to, in addition to specifying type, specify required true. And then we'll do that for position too because it's also required. And now over here in our robot builder, let's not pass in the left position. So if we come back over here, let's clear this and refresh. Well, you might be surprised to see here that there is no message. There's no validation error. And that's because if we look at what we passed in, we didn't pass in nothing. We actually passed in an empty string. And so because we are providing a value for position, it's not triggering the validation message. If we remove this altogether, however, and come back over here, now you can see it's saying that there is a required prop that's missing. But what if we actually do want to ensure that users cannot pass in an empty string here? Essentially, we want to indicate what are the valid values for position. So we can do that with a validator function. So in addition to specifying that position is required, we're going to supply a validator function. And that is a function that takes in the value that's being passed into the prop. And then we just want to ensure that it is one of these values: left, right, top, bottom, or center. So basically, I just want to make sure that the value is included in that array, or that this array includes the value that's passed in. Okay, now because we are passing in an empty string, we should now be seeing an error over here. And sure enough, if we refresh here, you can see that we are getting an error that the custom validator failed for prop position. Cool, so let's go back to our robot builder and pass position back in here. And then if I clear this and refresh, you can see we're not getting that error anymore. And our robot looks great. So awesome, we're now validating the props that are being passed into our child component. Next, we'll take a look at how to pass data back to a parent component from a child component. We now have a fully functioning parts selector, and we're passing data from our robot builder down to the parts selector via its props. However, notice when I click this Add to Cart button that I'm getting weird results down here in the cart. This is because our robot builder, which is the parent component, isn't aware of changes that are happening inside the parts selectors, which are child components of the robot builder. If we look at the code, you can see that the Add to Cart method expects there to be a selected robot. And in our data function up here, you can see that we are initializing each of the parts in that selected robot to an empty object. And before we extracted the parts selector component, each of these parts was getting updated whenever the user selected a new part. But now that selection is happening inside our parts selector child components. So when we click on each of these buttons, the robot builder has no idea that anything has changed because these buttons are inside the parts selector component. So we need a way to tell our parent component when a different part is selected. Let's take a look at how to create events in the child component that the parent component can bind to. This will allow the parent component to react to changes in its child components, and it will allow us to pass data back to the parent component from the child component. So over here in our part selector component, down here in the methods, you can see that we have these two methods, select next part and select previous part. We want both of these to emit an event that parent components can listen to by binding to them. This is surprisingly simple with Vue. Each Vue component has an emit function available that we can call to emit an event. So right here in the select previous part function, down here at the bottom, I'm just going to call this dot emit. And then I'm just going to pass in the name of the event that we want to emit. So let's emit the event part selected. This now means that a parent component can bind to a part selected event when it creates the part selector component. We'll see how to do that in just a sec. First, when we emit this event, we want to be able to pass along some data with it. It won't do us much good to let the robot builder know that a part was selected if we don't tell it which part was selected. So let's pass along the currently selected part like this. Remember, we have a computed property up here on our component called selected part, so we're just using that here to pass it along. All right, and we're going to also want to emit that inside the select next part function. So let's copy this and paste it here. Okay, cool. Now let's go see how to bind to this in the parent component. So over here in our robot builder, up here we have our part selectors, and we'll start with this one here. We just want to bind to this new part selected event. Binding to a component's event is done the exact same way you bind to any other element's event with the v-on syntax or the @shorthand syntax. So we're going to bind to part selected. And then we could bind that to a method on our component like this. But actually, I think that this is going to be simple enough. I just want to handle it in line like this. So this is a function that takes in a part. And then this is the part selector for the robot head. And so I want to set the selected robot's head to this part. So we'll do that like this. So remember, this selected robot is an object that we already have on our component. And we're just setting the head to this part that's being passed in. And that's it. Easy peasy. All you have to do to pass data to a parent is emit an event in the child component and then bind to it like this. So let's go ahead and do this for the other part selectors. So this is the left arm. This is the torso. This is the right arm. And this is the base. Okay, so that's it. The robot builder is now aware of the selected parts because we're binding to the part selected events and setting the selected robot parts. So if we go back over to our browser now and select each of these parts and then click Add to Cart, you can see that that works just fine because the robot builder is now aware of the data that's being passed back to it. But actually, we still have a small problem here. If I refresh this page and then click this Add to Cart button without changing anything, you can see that we're still getting our broken state. So it doesn't work when the page first loads, but if I change all of the parts and then click Add to Cart, you can see that it works just fine. This actually makes sense when you remember how we implemented the events. If we go back over to our part selector, you can see that we only emit the events when the select next part or select previous part functions are called. And these are only called when the user clicks the buttons. So when the page first loads, the part selectors haven't emitted these events yet. And so the robot builder doesn't have any selected parts. This is actually a great opportunity to tap into a component lifecycle method. So let's add a created function, and then let's emit the part selected event when the component is first created. But instead of copying this line again, let's create a new function called emit selected part. And then we will move this up into here. And then right here, we can just call this dot emit selected part. And then we'll do the same thing down here. And then in our created event, we'll also call it here. So now the currently selected part will get emitted when this component is created, in addition to when clicking the buttons. And you can see up here that in our data function, we initialize the selected part index to 0. So when the selected part component is created, the first part in the list of parts that's passed in is always the selected part. So we have a default selected part that will get emitted whenever this component is first created. So now if we go over to our page here and refresh, you can see that I'm not going to change any of these parts, and I'm going to go ahead and click Add to Cart, and now it's working just fine because those events got emitted. So this is working great, but it's a little bit hard to see the events as they flow in as we click on the buttons, because we don't see that the events are working until we click the Add to Cart button. For that reason, in order to see this a little bit better, let's add a little preview image up here above this Add to Cart button that shows a preview of what our currently selected robot looks like. And as the events are emitted from the child components, you'll see the parent component changing. So we'll grab the HTML for that preview element over here in our GitHub repo. In source build, there is this robot builder preview.html. So let's grab that. And then we'll come back to our robot builder, and right here at the top of the template inside the content div, just above the add to cart button, we'll add that here. And then there's some styles for this too, so let's go grab those. So that's this robot builder preview CSS. So let's copy that, and then back over here, we'll just drop those in the bottom of our style section. Okay, let's go take a look at that and see what we've got. Okay, so you can see our preview is showing up here, so that's great, but the add to cart button is on top of it. So let's go fix that. So over here in our template, let's move our button into our new preview section. We'll just move that up here. And then down here in the CSS, we just need to find the add to cart style, and we'll no longer need this right position. And we want to change the width a little bit to just 210 pixels. Now let's go take a look at that. Okay, there we go. Now the add to cart button's below, and there's our preview image. And now that we have that preview image, we can see the events coming in as we change them by clicking the parts here. And you can see that the preview image, which is on the parent component, is changing as we change the parts in the child component. Okay, this is awesome. And this is a great example of how to emit events from child components to pass data back to parent components. And I just want to take a short detour here to talk again about lifecycle hooks, because we have a great use case now. If we go back and look at our part selector component, you can see that right here we are emitting the selected part in the created lifecycle hook. And then down here in the select next part and select previous part methods, we are emitting it again. We could simplify this a little bit by using the updated lifecycle hook. And that is called whenever the data for the component is updated. So let's change this created hook to an updated hook. And then let's come down here and just delete these so that they're not emitted. These aren't going to be necessary because when we click the buttons, we end up changing the data. And because the data is changed, the updated lifecycle hook will get called and emit our selected part. So now if we come back here, you can see that our data is not being updated. But if I click this, then updated is being called. But this isn't quite what I want because we started out with a blank. And so we actually need both updated and created. We need those both to call emit selected part. So now if I refresh, now as I change the parts, then you can see that the preview looks accurate. Cool, I just wanted to take that little detour to show you how lifecycle hooks work now that we had a better use case. And this is awesome. Now we've seen how to pass data to parent components with events, and we learned a little bit more about lifecycle hooks in the process. Next, let's learn how to inject HTML or Vue content into a component. Sometimes you want to create a component that you can pass content into and have it be displayed in the appropriate place within that component. Imagine, for example, a component that is used as a collapsible drawer that expands and collapses as you click on a header, showing and hiding its content when clicked. In that case, you want a component to be reusable so that you can just wrap some part of your template in a collapsible component and it shows and hides that content. To experiment with this, we'll do just that. Let's create a collapsible component that we can use to show and hide this preview image over here. So over in our robot builder, we want to be able to use it like this. So around this preview content, I want to have a collapsible section component. And I'll wrap all of this content, the preview image, but not the add to cart button, in that collapsible section component. And then basically this collapsible section component will have a header that says expand and collapse. And when we click on it, it will show and hide this content. So let's go create this component. And I'm going to put that in a shared folder since this is likely to be used by other components. And in there, I'll create a new file, collapsible section.vue. And the template for this will be really simple. So we'll just type that in. So here's the template section of our component, and it's going to have an outer div, and then it's going to have an inner div that is the header. So we'll give it a header class. And then it's going to have a couple of spans in here, and those spans will say collapse and expand. And these are going to be shown or hidden based on whether the collapsible section is currently open or not. So we will add a vif, and we'll say if it's open, then show collapse. And down here, if it is not open, then show expand. And then on each of these spans, we're going to bind to a click event, and we will just toggle open to not open. And we'll do that for both of these. And then I just want a down and up arrow here, so I'm going to add these Unicode characters. So that is an up arrow. And then we want a down arrow here. Okay, so there's our header. And then basically we want to be able to add right here our toggleable content here. So this is where we want our injected content to appear. So we'll come back to that in a second. First, let's add our script block. And we're going to export our component definition object. And this component will be named collapsible section. And it will have a data object, which has the open variable that we're toggling with our click handlers up above. So our data object will just return a new object with open set to true by default. Okay, and that's it for the component script, and then we just need a few styles here, and we'll have those be scoped as always. And we just need to style our header. I want it to have a background color of gray and a little bit of padding. And we want it to have a pointer cursor. Okay, so now we have a component that has a header, and when we click on it, it toggles the open flag between true and false. Now we just need to know how to display injected content right here where we want our toggleable content. For that, we use slots like this. So this slot element is a Vue specific thing. And now that we've added it here, when we create a collapsible section element like we have over in our robot builder over here, this content that we put inside of our collapsible section will be shown right here where this slot element is. It's really that simple. Of course, since this is a collapsible section, we want to hide this slot when it's not open. So we'll put a VIF on here and only show it when open is true. Okay, so if we go back to our robot builder component and we want to import this, and it looks like I must have missed something here. Yep, this collapsible section needs to go down here actually. You may have already noticed that when I did it before. Okay, so if we come down here now and import our new collapsible section component, so I'm going to import collapsible section from /shared collapsible section.vue, and then we can use this down here in our components. Now that is available to be used, and so now this collapsible section component should be working. Let's go take a look at that. There we go. Now you can see that we have a header here above our preview, and actually that's not working. I must have got my click handler wrong. Oh, yep. Here I meant this to be equals not open. So basically clicking on these spans will toggle the open variable. So now let's come back over here. And when I collapse this, there we go. So our collapsible content is working, and you can see how we injected content into our collapsible content using a slot. And then one last thing to be aware of, this is maybe a little less common, is the concept of default content for a slot. So in our collapsible section, inside this slot element, I can provide any content that I want. So I could say here div default content. And then this will be displayed if no content is passed in. So let's add another collapsible section here, just above this one. And we won't provide any content for that. And now if we come over here, you can see that we have default content here instead of any data that was passed in, because we didn't pass in any content here. And as soon as I pass in something here, then that will show instead of the default content. And that's all there is to working with slots. I'm going to go ahead and delete this. And that wraps up this module on intercomponent communication.
We just looked at how to render content in a child component using slots. Teleport is similar, but it allows you to render the content from one component to anywhere in your application, even outside of the Vue application. To demonstrate this, let's display some info about each one of these robot parts. If you look at the parts data, you can see that we have extra info about these parts, like cost and description. Let's make it so that when you click on one of these parts in the robot builder, we display the information about that part. To demonstrate this, we'll display the part information right here, which is part of the robot builder component, whereas these parts are part of the part selector component. We could render it anywhere, like in the body tag of our HTML document, for example, which is completely outside of our Vue application. We'll start by rendering the content right here in the part selector, and then we will move it or teleport it elsewhere. So right inside here, we will add a div right here. And then inside here, from the selected part, we will display the cost, the title, and the part type. And then below that, we'll just display the part description. And finally, we'll just draw a line underneath that. And then we'll just add a VIF on this div here to show or hide this based on a showPartInfo Boolean flag. And then we'll toggle this on and off up here when the user clicks on the part image. And for that to work, we'll have to declare that flag down here in the data section, and we'll just start it off as false. Okay, cool. So this should show up now when we click on the part image, and it's not going to look pretty, but let's go take a look at it. So notice when I click on one of these parts here, there's the information showing right there, and I can click on it again to hide it. So, and that's true on all of these different parts. But this doesn't look great here, so we need to teleport it so that it's showing up over here in our robot builder. So back over here in our robot builder, we'll add a new div here, and we'll give it a class of part info, and we'll also give it an ID of part info. And then down here in the styles, We'll just copy this preview class and name that part info. And then we'll just change that here to be displayed on the left. All right, so now we have this empty div here, and that will be positioned right here in our robot builder. So back to our part selector. Here's the content that we want to teleport over to our robot builder. So we will just wrap this in a teleport element. And then we just need to tell it where to teleport to. So we add a to attribute, and then we just need to add a selector here. And these selectors work like CSS selectors. So I'm going to say hash part info. So this will target the div with the part info ID, which is what we created over in our robot builder. All right, now we just need to move this vif up to our teleport command. I'll explain why in a moment, but let's go take a look at this. So now if I click on these robot parts here, you can see that it shows the part info over here. And notice that when I click on multiple, it just keeps appending. That's because we have multiple part info components, and each one of them have that teleport section in it. And so each one of them are teleporting their content into this part info div that we created on our robot builder. And since there's already content there from the other parts, it just appends that content to the part info div. Cool, that's pretty awesome how easy that is. There's just one last thing that's good to understand though. Remember how I said that we needed to move this vif up to this teleport element? Well, let's move that back down to the inner div and see what that looks like. So now let's go see what's happening in our app. So if I refresh here, if I click on these, you can see that it is no longer working. And if I open my console, you can see that we're getting some errors in here. And if we scroll up to the top, you can see this warning, failed to locate teleport target with selector part info. Note, the target element must exist before the component is mounted. So the problem is that the part info div doesn't yet exist at the time that we're rendering our teleport element. So an easy way to avoid that problem is just not to render the teleport element while components are mounting. And that's why I moved the vif from this inner div up to the teleport element, because now this teleport element won't try to render until the user clicks on the part image. And that way everything's all mounted and everything before we try to teleport anything. So now you can see we're not getting errors and this is working again. This is less of an issue if you're teleporting items outside of the Vue app completely. So for example, I can come over here and instead of teleporting this to the part info element, let's teleport it to the body element, which is outside of our Vue application. So if we go take a look at this now, when I click on this, it's actually rendering down here at the bottom of the body. So that demonstrates that you can teleport really to anywhere where you have a CSS selector for. And since we're teleporting to the body now, we could actually move this vif back down to the inner div and it'd work just fine because the body tag is always rendered before the Vue app is even created. But let's change this back and we'll let it render where we had it here, which is a much better place. Okay, so that's how you use teleport. Pretty easy. Later when we learn about routing, we're going to create some dedicated pages to show this part info. So now that we've demonstrated how to use teleport, let's remove it since we don't need it. So I'm going to delete this teleport section here completely. And back in our robot builder, we'll delete this part info div and the class that we created down here. All right, now that you know how to use teleport, in the next clip, we'll learn how to pass data from a parent component to a deeply nested component using provide and inject. In this module, we've seen how to provide data from one component to a child component using props. And this works well for the majority of the cases when you're passing data from a parent to a direct child component. Sometimes, however, you have data in one component and you need to pass that data down to a component that is deeply nested several layers below. To do this with props, you end up passing props down through lots of components that don't really need the data just to get it down to the target component. This isn't always bad, but in some cases this can be cumbersome and we can use the provide and inject syntax to help us with this. Our current app isn't quite complex enough to have a need for provide and inject, but we do have enough components to demonstrate it. In our current app, we have our app component here, and it is rendering our robot builder component. And our robot builder component is rendering part selector components. Imagine a use case where our part selector needs to know who our current user is in order to determine discount pricing. And imagine if our app component is where the state existed for who our current user is. So we might have a data property over here in our app component like this. So here we have a data property that's exposing a username field set to the string Jim. Using simple props, we just need to pass this username to the robot builder as props, even though the robot builder doesn't need the data, and then the robot builder would need to pass that data down to the part selector components. We can use provide and inject to simplify this. Provide in its most simple form is just an object on the component metadata like this. So here I'm providing a username to all descendant components, and that username is the string Jim. And now I can inject that in my part selector. To do that, I'll just add an inject property to my part selector component metadata, and I just set that to an array of the provided properties that I want to inject. In this case, I want to inject the username property, which was provided by the app component, which is this component's grandparent. So I'll just add the string username to this array. So I've provided it in the app component, and then I've injected it in the part selector component. And now I can just use it however I need to in this component. To demonstrate it, I'll just display it up here at the top of my part selector. So I'll just add a new div, and I'll display the username here, like this. Cool, now let's go take a look at this. There we go. Now you can see that the username Jim is passed down to all of our part selectors. So this is the most simple use case for provide and inject. But if we look at our app component, we've provided the username to child components, but it's not actually available to the app component itself where we provided it. We do have this username data property here that we've defined, but that is currently unrelated to the username that we've provided. So if I comment this out right here, and then up here I try to print out my username, then notice that it does not show up here. So I can come over here and uncomment this here, and then we see it here. But of course, it is not the same instance as this down here. So if I provide John to my child components, it still says Jim here and John down here. So what we really want to do is something like this. I want to provide this.username. But this won't quite work like this. Using the current syntax, provide does not have access to the keyword this. To do this, we need to use the function syntax for provide. So we'll change provide to be a function. And then down here, we will return an object with the property username set to this.username. Okay, now over here you can see this is working. We have access to it in our parent component and in the components that have injected it. And if we change this to John, then it changes everywhere. Okay, so this is working, but not totally. So what we've built here isn't actually reactive. In other words, if the username changes in the app component, the child components injecting the provided username won't be aware of this change, so they won't be updated. To demonstrate that, let's add a button back over here in our app component, up here by where our username is. And when the user clicks this button, we'll call a change username function that will change the username. So now down here, we need to add that method where we'll add this change username method, and that will just set this.username equal to Fred. Okay, so now when the user clicks the button, it will change the username to Fred. So now notice if we come over here and we change this, notice that it changed up here, but it did not change in the components that are injecting this value. So we have two ways that we could fix this. The first way is that we could use the Reactivity API. We covered the Reactivity API in a previous module in this course, so I won't demonstrate that in depth here. But you could use the Reactivity API's ref and computed functions to make this property reactive. The other way to make this work is just to provide an object instead of a string. So if I change my data property here to an object, so I will return a user object and it has a username property on it. And then down here, I can just provide a user object and set that to this.user. And then up here in my template, I need to change this to user.username. And then over in the part selector, I now need to inject user instead of username. And then same thing up in the template here, I need to use user.username. All right, now I just need to, in my app component, in the change username method, I need to set this .user.username to Fred. All right, now if we go check this out, okay, there, everything is set to John, and when I click change here, you can see it changes both in the parent component that's providing the value and in the child components that are injecting the value. So just remember, you're most often going to want to use objects when using provide and inject, but you could also use the Reactivity API. I just want to point out one thing, however. Notice that down here, when I change the username, if I actually set this .user equal to a new object, like this actually is not going to work. So I click change here, it changes in the parent, but not in the components injecting the value. And that's because I've broken the reactivity by changing this reference to this user object. So just keep that in mind, that if you change the actual object, it will break the reactivity. So you just need to handle that correctly. But that's really all there is to provide and inject. You're just providing values from a parent component and then injecting them in child components. All right, we don't need any of this demo code, so let's go ahead and delete the data, provide, and methods sections of our component. And we will delete the user object up here. And then over in our part selector, we will delete this user section and we will stop injecting user. All right, and that's it for provide and inject. And really, that's it for this module on inter-component communication. In this module, we learned about using props to share data with child components, validating component props, passing data to parent components with events, injecting content into child components with slots, using teleport to render content outside of the current component, and using provide and inject to pass data to deeply nested components. In the next module, we'll explore Vue.js routing and navigation.
All modern front-end frameworks provide some sort of routing mechanism for defining routes and navigating between pages in your single-page app. Vue.js, of course, is no different. In this module, we'll explore how to do this with Vue. This will include adding routing to our app, linking to routed pages, styling links based on the active route, navigating from code, working with Route Params, using nested routes, using named views, enabling HTML5 history mode, and preventing navigation with navigation guards. Our Build-A-Bot app really needs some routing love, so let's go check it out. If we take a look at our app component, you can see we're importing the homepage component and robot builder components down here. But without routing, the only way we've been able to see each of these pages is by replacing this element up here. What we really want to do is make it so that we can get each of these pages and others by changing the URL or by clicking on links. In order to do that, we'll need to install routing. If you remember, when we first created our project with the Vue CLI, we had the option to select routing, but we opted not to. However, adding routing to an existing project is really quite easy. First, we just need to install the Vue router package. So over in my terminal, I'm going to stop my server from running, and then I'm going to npm install Vue router. All right, since we're using Vue 3, we need to specifically install version 4 of the router. If we don't specify a version here, we're going to get router version 3, which is for use with Vue 2. So I'm going to add @4 here to install the right version. And then I'm going to save that. Okay, and then let's go ahead and start up our server again. And then back over in our app, we just need to have a place where we can define all of the routes for our application. So let's create a new router folder. And inside there, we'll create a new index.js file. Okay, now inside here, we just need to import the create router function from the Vue router that we just installed. And then we're going to export a new router from this file that we create using the create router function like this. And then notice we're passing a new object into our create router function. This is the metadata object where we'll define all our routes. Before we do that though, let's jump over to our main.js file. And in here, we're going to import our new router. And then right here, we'll tell Vue to use our router. This makes Vue aware of our router so that we can access it in our components.
All right, now back to our router. Let's start creating some routes in here that we can use for navigation. To do that, in our router metadata object, we'll just add a routes property,
which is an array. Okay, now we're ready to add our first route. This will be a route to our home page, and it will look like this. Okay, so this is our first route. This just says when I navigate to this URL, then display this component. And then this is just a name that we're giving to our route, and we can use that in various places in our code. So this is pretty simple.
Now we just need to import our homepage component to make this complete. Cool, so there's our homepage route.
And while we're in here, let's go ahead and create our route to our robot builder too. So let's copy this, and we'll add another one, paste that in here. And the route for our robot builder is /build, and we'll name this route build. And then we just need it to render the robot builder component. And we'll just have to import that. Okay, so this is our routes file, all built out for the 2 pages that we currently have in our application.
There's just one piece missing here. We need to specify the history mode for our router. I'll explain this in a sec, but up here, we're going to also import create web hash history from Vue router. And then right down here, we're going to add a history option and set that to create web hash history. This option affects whether we use hashtag routing or HTML5 routing. And right now we have it set up to use hashtag routing, and we'll explore HTML5 routing in a minute. Okay, so our routes are good to go now.
The last thing we need to do is tell our app where to display routed components. So over here in our app component, right here where we've been hard coding the component that we want to display, what we really want to do instead is display the component that matches our current route. We can do that by replacing this with the router view tag. So now Vue will display the component that matches the current route right here. And we don't need these imports anymore. And we don't need this components property anymore. Okay, cool. Let's go check this out. So if we come over to our browser and put in this URL, we're navigating to the root of the website, you can see that it loads the home page. You may notice, however, that it also added this hashtag. And this part of the URL after the hashtag is currently what Vue is looking at for matching the routes. And we'll talk later in this module about how to get rid of that hashtag using the HTML5 history mode. But for now, I can navigate to my pages by changing the route here. So now I want to navigate to /build, and you can see that takes me to my robot builder page. Okay, awesome. So our routes are working great, but the only way we have to get around is by manually changing the URL. Let's go see how to create links to these routes. Now that we have a couple of routed pages, let's see how to link between them. We'll start with this Get Started link right here. So over in our homepage component, you can see that we have this Get Started link right here, and it's just an anchor tag. In order to link to a route, we instead need to use Vue's router link element like this. And then instead of an href attribute, we use a to attribute. So we're going to route to this URL or this route. And I'm going to just say /build here. So I can put in a string here that represents the URL for one of the routes that we've added. And then I just need to add the correct closing tag here. And now if we go check this out, I can now click on this Get Started link, and there we go. It navigated me to the build page. So that's working now, but how do we get back to the home page? Let's make this logo and text here a link to the home page. This will give us a chance to look at a little bit different syntax. So this is going to be in our app component, and that's up here in our nav section. So you can see here is my logo, and here is the Build-A-Bot text. So let's go ahead and add a router link around the logo and text. And then in our last example, we just used to, and we bound that to a URL like this. Instead of using this syntax, let's actually use a binding here, and we're going to pass into it an object. And in this object, I'm going to specify the name of a route. So I want to navigate to the home route here. And if you remember, over in our router index file, each of our routes we gave a name. And so we're routing to the route that has a name of home, which is going to be this route here. So let's go check that out. So over here, you can see that we have a link now for our text up here, and the logo is also a link. So if I click on that, you can see it takes me to the home page. The only problem is that we don't want this link styling that we have here. So let's go add a class for that. So back over here on our router link object, let's add a class. And that class will be navlink. So notice that I can put a class on a router link element, just like I can any other element. And then down here in the styles, let's just add that navlink class. And we'll set text decoration to none. And we'll tell the color to be inherited. So this will avoid changing the color of the link. Okay, so if we come back over here, there we go. Now our link is styled, so I can go back to the build page and then back again to the home page. And this looks great. So now that we know how to link to our routes, let's go see how to style the currently active link based on the current URL. It's really easy in Vue to set up a style that will be used on links that match the current route. It'll be helpful to demonstrate this if we have a couple of links up here in our nav bar. Right now we only have one for the home page. So let's add another one up here that goes to the build page in addition to that get started link. So in our app component, let's duplicate this list item and paste it here. And we'll change its router link to the build route. And then we can get rid of this image here and we will just call this build. Okay, so now we have two links in our navigation area, a link that goes to the home page and a link that goes to the build page. And you can see those here. So this one goes to the build page and this one takes us back home. Now let's make it so that the link that corresponds to the current URL shows up in a different color. So we can easily do that over here in our template by adding a class down here in our styles. So I'm just going to add a router link active class. And this is a special class used by Vue, and I'm going to just tell it to change the color to white. So this is a class that Vue applies to any links that match the current route. So let's see how that's looking. So over here, you can see that the build-a-bot link, which links to the home route, is currently white because we are on the home page. But if I click on build here, you can see that build turned white. However, we have a small problem in that these are both white and the homepage one should not be white anymore. That's because Vue by default is using an inclusive match on the route. If you look at the URL, technically it includes both the homepage route, which is just the slash, and the build route, which is /build. So they're both white. What we really want for this is for it to be an exact match on the full URL. We can do that back over in our template by adding an exact attribute to our router link. So I'm going to add that on both of our router links. And now over here, that should be fixed. There we go. So now only the exact route that matches the URL is being highlighted. So that's working great. Now you might be wondering, what if I don't want my class name to be called router link active? So down here, we call this router link active, which is required in order for this to work. But we can use our own class name here. So I'm going to use foo here. And then back up here, I could add an active class attribute here and set that to foo. So now it will use this as the active class, and I could put that down here also. And that should be working just fine. But we don't really have a need for that. I kind of like just using the built-in router link active class, so we'll leave it like that. Next, let's take a look at how to navigate to a route from JavaScript code. In order to demonstrate how to navigate to a route from within our JavaScript code, let's create a new page. And we'll use this page in the next few clips too, in order to demonstrate route params. But basically, we're going to create a page that if we click on one of these parts, like the head or this arm, it will take you to a page where it describes that part. So let's start by creating a parts folder. And then inside that folder, we'll create a new component called part info. And for that, we'll just have a basic template that looks like this. If you're following along, go ahead and pause this and type that in. And we'll have a pretty basic script section also that looks like this. So notice that we have a part info component and that the data function is returning a part object, and that object has a title and a description. So this is just hard-coded to display this fixed text right now. We'll fix this later. Until then, let's go ahead and create a route for this and then update the part selector to navigate to this page. So over in our routes file, let's add another route down here. And that will be the parts route. And it will load our new part info component. So let's import that component up here. Okay, so now that we have a route for this, let's go ahead and go navigate to it from code. So in our part selector component, let's add a click handler on our image component. So add click. And we could use a router link here. There's no reason not to use a router link here. But we're going to navigate from code in order to demonstrate this. And you'll find better use cases for this where you might want to do some sort of processing or something before you navigate. But this will work to demonstrate it. So we're going to have that call a show part info function, which we'll add down here in the methods. And here's where we'll tap into Vue's router in order to navigate. Because we injected a router into our Vue instance in our main.js file, we have a router available to us here like this. And all we need to do in order to navigate is call push and pass in the URL of the route to navigate to. And just like the router link element, I can either pass in a URL string here, or I can pass in an object. We'll leave this as a string for now, and we'll change it to an object when we explore how to pass route parameters. Okay, let's check this out. So back over here, at first it seems like this is not clickable because my cursor hasn't changed. But if I go ahead and click on this, you can see that it did navigate me to the parts page. And this is happening via our programmatic navigation. Okay, cool. Let's just change our pointer styling so that it looks like this is clickable. So back in our part selector, you can see up here that we already have a class on here on this div that is surrounding the image, and it's class part. So down here, we should find that class, a class that targets that already right here, part image. So in here, let's just add cursor pointer. So now you can see I'm getting a pointer here, and when I click on it, it takes me to this page, but it's still displaying hard-coded information. This is not displaying information about the part that I click on. For that, we'll need to pass some route params to our parts component. So in the next clip, we'll start exploring working with router params. Our part info component is just currently hard coding the title and description here on the page. What we'd like to do is to be able to specify the part type, like heads, and the part index, and then use that information to look up that part and display its info. In order to do that, we're going to have to update our route to expect those parameters, and then we need to grab those parameters off of the route in our component. So let's update the route first. So first we need to update the URL for this route to add the params, and you use a colon here followed by a variable name, so part type, and then colon ID. So this route now expects a part type like head, arm, torso, etc., and then a part ID. With this information, we'll be able to look up our part from our parts list and display its information. So now let's go over to our part info component and update it to grab these route parameters. So first we'll import our parts data. We'll import parts from data parts. And now we'll need a computed prop. So let's add computed. And we'll have a part property that is a computed prop. So we'll return an object here, and that will look like the one down here in data. We're just going to cut this out of here and paste it into here. And now we can get rid of data. We don't need that anymore. And then this is what we want to do the lookup for from the route params. So we want to look up the part and get the title and description for that part based on the params that are passed in on the URL. So the route params are available to us on the component's route property. So we can get the part type, for example, like this. So we're going to say this.route.params.part type. And then this part type right here needs to match the parameter name over here. So with that information, Vue can parse the part type off of the URL. And then we can get the ID in the same way. So ID equals this.route.params.id. Okay, and this is red because our linter is telling us that we should prefer destructuring here. And so I can change this to look like this. Set part type and ID using destructuring, and we'll set it to this route.params. Okay, so now I can use this to look up the part. So instead of returning this hard-coded object, I'm going to do a lookup on the parts array, where the part type is the part type that I get off of the params. So remember that the parts object that we're importing is a keyed object where the part type is the key. And then that returns an array of that part type. So then I'm going to do a find, and I'm going to find where the part ID equals the ID from params. But actually there's a problem here, and that's because the params that are pulled off of a URL are always strings, whereas the IDs on the parts in our data are integers. And so this triple equals actually isn't going to work because it's not going to find a part with an ID that is a string. So we can fix that by casting ID to be a number here. Okay, so now we have our router set up with params, and we have our component set up to use those params. The last thing that we need to do now is just pass the params from the part selector component. So over here in our part selector, down here in our show part info function, we want to pass the URL parameters here for part type and ID. But we can't pass part params using the string syntax. We actually need to use the object syntax in order to pass parameters. So I'm going to change this to an object and use a named route where the name is parts. And then I can pass params. And then I'm going to specify here that the ID param is this .selected part.id, and the part type is this .selected part.type. Okay, let's clean this up a little bit. We'll bring this down here. Bring this down. And we'll bring this down. Okay, so now we are saying navigate to the parts route and pass in the params ID and part type, and we're going to get those off of the currently selected part. Okay, let's go check that out. So back over here, now if I click on one of these parts, there we go. Now we are navigating to parts heads 1, and we get a description of that part, a large cyclops. And if I change this to this part, now it is the friendly bot head. Okay, before we wrap up on this, let's just demonstrate that this is also possible using links instead of code navigation by changing this link to be a router link rather than navigating from code. So back in our part selector up here, let's get rid of this click binding. And then let's wrap this image in a router link. And then we'll use a to binding. And let's grab the route expression down here from this function. So I'm going to cut this out of here, and then we don't need this function anymore. And then I'm just going to paste that expression in here. And I'm just missing a closing bracket here.
And we don't need to use this up here.
There we go. Okay, so this would work just the same as when we were navigating with code. So I can click on these and go to the parts page with the params. Awesome. So this is working great, and we're passing parameters between components using router link. But next we'll see how to decouple our part info component from the router by passing the route params as props instead. One downside of using this route expression is that it couples this component to the router. What if we wanted to use this component as a child component somewhere else and pass the part type and ID as props instead of pulling it off of the route params? Well, we can make this work both as a routed component and as a child component by updating the route for this component to pass the params as props. So we can do that over in the route simply by setting the props property to true on this route. So now Vue will pass the route params that it identifies on the path for this route as props instead of as route params. And with that simple change, we can come over to our part info component and add props for the part type and ID. And now instead of getting part type and ID off of this .route params, we can just get it off of this, which is where the props are. And it's that easy to decouple our component from the route. You can see over here that that is still working just fine. But let's add a little bit of validation to these props. So we'll change the props to an object, and it will have a part type, and we want it to be of type string, and it will have an ID, which will be of type number. But the problem with this is that when this component is used as a routed component, this ID will still be passed in as a string. So we need to allow either a number or a string. But just to be sure that nobody passes in an invalid value here, let's also add a validator. And then we'll just verify that this is a number. So we'll call number is integer, and then we will cast the value to a number. Okay, so now we have some validation around our props, and if we come back over here, this should all still be working just fine. Great, now we know how to use route params and how to pass those parameters in as props. Now let's explore nested routes. In order to understand what we're going to build in order to look at nested routes, let's take a look at the final result. So we're going to be building this browse parts page. And notice up here the URL is parts/browse. And when we navigate to that, it shows us a list of all the different parts. But then as I click on each of the different part types, you can see that the bottom part of this page here is changing, but this top part that includes this menu is not changing. And notice the URL up here as I click on each of these is also changing. And so the URL is changing, but really all Vue is replacing is this bottom section down here. That is possible because of nested routes. So let's go take a look at how to build this. To get started, we'll create a new browse parts component. So I've created that here in the parts folder. Let's go grab the contents from that from our GitHub repo. So in the source folder, in the parts folder, there is this browseparts.vue file. So let's grab that and paste that into here. So there's not a lot going on here. We have a bit of CSS, and then up here we have a menu for the different parts. And then I'm going to need a new page for each of the different types of parts. So I'm going to create a new robot heads.vue and a new robot arms component and a robot torsos, and finally a robot bases. And then I'm going to get the contents for each of these out of our GitHub repo from their corresponding files also. So here's robot arms. And I'll paste that into robot arms here. Robot bases. Paste that in here. And then robot heads. And finally, robot torsos. And each one of these is really quite similar, where you have a title and a description of the type of parts that we're dealing with on this page. And then you can see here that we have a v-for that is looping all over all of the, in this case, all of the arms and displaying the title and description. Whereas here we're looping over bases and torsos and heads. And then in each one you can see that there is a data function that's returning the corresponding parts. So we have a heads property on the robot heads component, and we have an arms property on the robot arms component, etc. So now the trick is, how do we get each one of these pages to be viewed on the browse page underneath this menu whenever we click each one of the links for the different part types? Well, it starts with adding another router view. You'll remember that we have a router view already in our app component. And so we are adding a second one here. And now we can add routes for each one of these individual pages, robot arms, robot bases, etc. This is going to consist of a parent route for the browse parts page and child routes for each of the part types. So over here in our routes, we're going to create a browse parts route. And it's important that this goes above the existing parts route. I'll explain that in a second here. So right here, I'm going to create a new route, and it's going to have a path of /parts/browse and a name of browse parts. And the component is going to be the browse parts component. And we'll need to import that. Okay, now back to why it was important where this goes. Notice that this parts path, where we're navigating to a particular part, that it has parts followed by a part type. Vue has no idea when we type in browse here that we're not trying to type in a part type. And so if we would have put this down below, it would have got picked up first by this route. And so the order is important. Okay, so now we have this browse parts route, and we're going to need to add the child routes now for the individual part types. We do that by adding a children array like this. So the browse parts route now has child routes. And then we just need to specify the child route for each part type. So we're going to have browse heads, and that's going to have a path of heads, and resolve to the component robot heads. And let's copy this and paste it for each of the types. And this one will be browse arms. Path will be arms. Notice that this path is relative to the browse path. So the full path for arms is parts/browse/arms. And that will use the robot arms component. And then we have browse torsos and the robot torsos component. And then finally, browse bases. That's the bases path, the robot bases component. So now let's go ahead and import each of those. Okay, so now we've created our nested routes. So we have our browse parts route that has child routes for each one of the parts pages. Now all we have to do is create links for each one of these on the browse page. So back over here in the browse parts page, I just need to add a router link around each one of these menu items. So I have a router link. And then I'm going to use a to binding. And here I'm just going to specify the name of a route. And notice here that I can just provide the name of the child route. Okay, let's fix this so that it wraps a little bit better. Okay, now we just want to do a similar thing around the rest of these. Okay, so we should be good to go. So we added a browse parts route, and it has child routes, and then we link to each of the child routes here. Okay, so let's take a look. So instead of build here, we're going to navigate to parts, browse, and here we go. So now I can go to heads and arms and torsos and bases, and you can see that the data for the correct corresponding parts is loading down below. Awesome. So pretty simple to add child routes. Now let's go take a look at one more place where we can use a router view, and that's with named views. We just looked at nested child routes. Now let's take a look at named views. You can almost think of named views as sibling routes. Whereas nested routes have a parent-child relationship, named views allow you to have multiple router views on a single component, and the route for the component specifies which two or more views to display. To demonstrate that, let's add a sidebar to our app that will show up here on the left of every page. And each route in our app will be able to specify a different sidebar to display. Right now, in our app component, we have this main section down here that has a router view in it. Let's also add an aside that will show to the left of this main section. So we'll give that a class of aside. And we'll wrap both of these in a container div. And let's go ahead and add those classes. So we have a container, and it's going to be display flex with a margin of 10 pixels, auto, 0 auto. And we will set justify content to center. And then we need an aside class. And it's going to have a 30 pixel padding and a background color that is gray, 100 pixel width, and a min height of 300 pixels, which matches the min height of our main content area. Okay, as we add these asides to our site, we're going to have to make a couple of other small CSS adjustments in order to fit those in. So on our main element, we're going to remove the margin auto, and we're going to change its width to 964 pixels. And then we're going to change the width of the header to 1184 pixels. Okay, that should take care of the styling. So now up here in the aside, we'll go ahead and add another router view. However, so that we can target this router view, let's give it a name. So we're going to add a name attribute, and we will name it sidebar. And we can leave this one without a name. And by default, if we don't give it a name, it has the name default. Okay, now we need some content to display in this sidebar. So let's create a sidebars folder. And in here, I will create a sidebar standard component. And I will also create a sidebar build component. So the build page will have its own sidebar. And our standard sidebar is just going to look like this. So if you're following along, go ahead and pause this if you'd like to type it in. And the only content up here is just the text standard sidebar. And we have a sidebar class here that is giving it a font size of 50 pixels and rotating it 90 degrees. And that's really all that's going on here. And then let's copy and paste this into the build sidebar. And we'll just change this to say build sidebar, and we will name it build. And just to make it stand out a little bit, let's give it a green font color. Okay, now let's come over to our routes, and up here on the route for our home page, we're going to change this component property to components plural. And then we'll change that from a simple property to a keyed object. And this will have two properties, default and sidebar. Remember that these names now correspond to the names of our router views. This one has a name of sidebar, and this one has a name of default. So when our home page is displayed, we want the default router view to display our home page. And then we want the sidebar router view to display our standard sidebar. And we'll need to import that up here. And then let's do the same thing for our build route, except that the default router view will display the robot builder. And in this case, we want to display the build sidebar. So let's import that also. Okay, cool. So now, because our main app component has two router views, we have to specify them both, or we can specify them both, and we can indicate in the route which content to display in each one. So let's go take a look at this. Oh, and it looks like we have an error in our CSS, so let's go back to our app component, and down here in the styles, I'm missing a colon right here, it looks like. Okay, let's check this out. Okay, there we go. So we are on the build page, and notice that on the build route that I have my robot builder and I have the green build sidebar. And yet if I go home, I have a different sidebar. This is the standard sidebar. And notice that if I go to the parts browse page, that there actually is no sidebar here, or I should say there is no content in that sidebar. So this gray background is coming from the aside in our app component, which exists right here. So we have the aside here, and that has a gray background, but there is no content in it because we didn't give it a router view on that page. So our route is not specifying a component for the sidebar router view, and so it's blank. So it is optional to provide data here, But this is how you use named views in order to specify different content for different parts of the same page. Next, let's go take a look at how to get rid of this hash sign in our URLs. All of our URLs so far have had this hashtag in them. That's because we're not yet using HTML5 history mode. So let's turn that on, and then we'll talk about a challenge that is presented by using it.
So all we need to do to turn it on is in the router configuration, we just need to change this history option here. So instead of importing create web hash history, we're just going to import create web history, and then we'll use that down here.
And that's it. Now if we come over here and start navigating around our site, you can see that there are no longer any hash signs in our URL. I really like this approach because the URLs look more professional, but there is one consequence to this that you need to be aware of. Imagine somebody comes to this parts heads 1 URL, and then they bookmark it, and then they come back, they close their browser, and they come back later, and they click on that bookmark. Or let's just say they open a new browser and they type in this URL. Well, this works locally in development because behind the scenes we're using Webpack dev server in order to serve this, and it can handle this. But imagine you have this running on your server and a user types in this URL or clicks on a bookmark to this URL. It's going to request this full URL from your server. So it's going to request /parts/head/1 from your server. And your server doesn't actually have a document at that location. It has an index.html and some other files that are used for serving up your Vue.js single-page application. And your Vue.js application knows how to serve this URL, but your server doesn't actually know how to use it. And so you would actually get a 404 when you try to run this if you have not configured your server correctly. And that is not the case if you're using hashtag routing, because only the part before the hashtag is sent to the server. Everything after the hashtag is handled client side. And so this is a problem only when you turn on history mode routing. So if you don't configure your server correctly, all of these URLs that people deep link to will 404 when they try to hit them. Basically, you need to set up your server to always return the main index.html file whenever you load any URL like this. The way to do this varies depending on which web server you're using. So the Vue documentation contains some instructions for some popular web servers. I'll talk more about this later in the deploying to production module in the clip on handling deep linking. I'll demonstrate how to do this with Express. But just be aware that when you turn on the HTML5 history mode, that this is a concern that you have to take care of on the server. Next, we're going to take a look at navigation guards and how we can prevent users from navigating to or away from certain pages. Navigation guards allow you to either prevent a page from loading or prevent a user from leaving a page based on specific criteria. We'll take a look at both of these scenarios. Let's start with a before enter guard. To demonstrate this, let's prevent this part info page from loading if the ID that's passed in is not numeric. You might think that we've already taken care of this when we added a prop validator that required the prop to be numeric. But this doesn't prevent the page from loading. It is more of a dev time warning that just throws errors in the console if the ID isn't valid. We'd like to actually prevent navigation from happening. Notice that if we come over to our part selector and change ID so that instead of passing in a valid ID, it's just passing in a string, you can see that if I then try to navigate to this, that it actually does navigate. You can see my URL has changed, but I just have a blank page. This is not ideal. What I'd like to do is to prevent the navigation from occurring completely. So let's go back here and change that back. And let's add a route guard to prevent this. So we can add that on a component or on a route. Let's see how to add one on a route. So we'll come over here, and right here in our part info route, I'm going to add a before enter function. And that takes 3 parameters: the route being navigated to, the route being navigated from, and a next function. And if we want to allow the navigation to proceed, we call this next function with a value of true. If we want to prevent the navigation, then we call it with false. So inside here, we want to prevent navigation if the ID is not numeric. So to get the ID, we can get that off of the to route, and then on there is a params object, and that should contain the ID parameter. So basically, if this is a valid integer, we want to allow the route to proceed. So I'm going to set a variable or a constant is valid ID equal to true if the number is a valid integer. So we can do that like this, number.isInteger. Then we cast this to a number. And now isValidID will be true if the ID param is a valid integer. So now we just need to call next, and we need to call it with false if the ID is not a valid integer. So we can just pass in isValidInteger here. And then if that's false, it will prevent the navigation. Otherwise, it will allow it. So this should still be working normally now. I should be able to navigate to each of these parts, and that's working fine. But if we come back over to our part selector and change this again to a string and then try to navigate, you can see I'm clicking on these, but nothing is happening. And that's because our route guard is stepping in and preventing the navigation because the ID is not valid. So before we forget, let's go undo this and put that back how it was. And you can see how creating this route guard was super easy, and it can be really handy. We could have defined this on the component instead, or we could even define it globally. In the next clip, we'll create a before leave navigation guard to prevent the user from leaving a page, and we'll do that in the component so you can see how that works. Sometimes we want to prevent or warn a user before they leave a page. For example, imagine I spend some time configuring the perfect robot that I want here. And then I click the home link up here to navigate away. This could cause me to lose all of my progress on the robot I've built. So I may want to warn the user before they lose their progress. Let's create a before leave route guard to handle this. This route guard is going to need some information from the component. So we'll create this one inside of the component rather than on the route like we did with the before enter guard in the last clip. So over here in the robot builder, we're going to add a before route leave function right here. And notice that this has the word route in it. Well, it's supposed to. Now it has the word route in it. So this before route leave, and we could add before route enter here. But you may remember that when we were adding this on a route as opposed to in a component, we actually didn't have the word route in here. So this is different when you're adding it on a component. So we want a before route leave guard. And again, this has the to, from, and next parameters. And basically, we want to warn the user if they try to leave the page without adding their robot to the cart first. So let's add a property in our data function down here that will track whether they've added it to the cart. So we'll create an added to cart property, and we will default that to false. And now up here in our route guard, we will check to see if that's true. So if this dot added to cart, and if it is true, we will allow them to leave the page. So we'll call next, passing in true, which will allow the navigation. Otherwise, we'll use a confirm dialog to ask them if they want to leave or not. So I'm going to set, I'm going to say const response equals, and then we're going to use confirm. And here we're going to say you have not added your robot to your cart. Are you sure you want to leave? So if you're not familiar with confirm, it'll pop up a dialog, kind of like an alert, but it has an OK and a cancel button. If they click OK, it returns true. Otherwise, it returns false. So if they click OK, then they're saying that they want to leave. And so we will pass response into next. And this is all we need. However, our linter is getting angry because it doesn't like us using confirm. Generally, alerts and confirms are not a great idea, but this is good for demoing this. And it's not bad to use it in the cases where it makes sense. And then we're also getting an error because we're using a global function. So we're just going to disable those alerts here. So I'll just put in these two ESLint directives here, and now it's stopped complaining. There's just one last thing that we need to do here. Remember, we're checking to see if added to cart is true, and it's always going to be false right now because that's what we defaulted it to. So down in the add to cart function, once they've added it to their cart, then we're going to set this dot added to cart equal to true. Okay, let's go check this out. So when I first load this page, if I try to navigate away, I should get a warning. There we go. You have not added your robot to your cart. Are you sure that you want to leave? And if I say cancel, then it does not navigate away. But if I say okay, then it does navigate away. So that's working great. And if we go ahead and configure a robot and add it to our cart, then added to cart is set to true, and now we can navigate away without a warning. Great, so now we know how to use route guards to prevent users from leaving a page. In this module, we learned all about routing in Vue, including adding routing to our app, linking to routed pages, styling links based on the active route, navigating from code, working with route params, using nested routes, using named views, enabling HTML5 history mode, and preventing navigation with navigation guards. In the next module, we'll learn how to manage state with Vuex. Welcome to this module on managing state and server communication with Vuex. In this module, we'll explore how to reliably handle data in a Vue application using Vuex. Vuex helps us by creating a central store where we can store and retrieve data in a way that works well with change detection across an entire Vue application. At the heart of Vuex state management is the Vuex store. The store provides not just a storage mechanism, but an interface for mutating data, requesting asynchronous mutations to data, and managing complex logic for fetching computed data with getters. The interface it provides ensures a shared data store for your application that will work well with Vue's change detection. At the heart of the Vuex store is the shared state tree. This is essentially a single object that contains all of the data for your entire application. When you first create your store, you provide an initial state object with reasonable defaults. This is important to Vue's change detection. We'll talk more about that later. But just know that the store contains a single state object that can be accessed throughout your application. Once the store is created, if you want to make changes to data in the store, you do so by committing mutations. Mutations are synchronous and shouldn't be confused with actions, which are asynchronous. You might wonder what the purpose of a synchronous mutation is. Why not just change the state directly? Essentially, by telling the store to commit a mutation, it keeps everything within the store consistent and working well with change detection. If you want to kick off an asynchronous call that will eventually mutate the store, such as making a call to an API to fetch data, that's where actions come in. Actions contain asynchronous calls using constructs like promises or async await, which when finished commit mutations to the store. Actions and mutations work hand in hand to make asynchronous calls and then mutate the state. Sometimes when you want to access data from the store, you want to perform some complex calculation logic before returning the data. For example, you may have an array of unicorns in your store, and perhaps it's common in your application to want to retrieve only unicorns who can heal fatal wounds. Well, all over your application, you could retrieve the list of unicorns from your store and then filter it as needed. But this distributes and duplicates the logic all throughout your application. For purposes like this, Vuex provides getters. Getters are basically functions in your store that fetch data from the state and do some sort of calculation on or manipulation of the data before returning it. So these four items, state, mutations, actions, and getters, make up a Vuex store. In this module, we'll cover all the fundamentals of working with Vuex, including creating a Vuex store, changing state with mutations, retrieving data from the state, using getters to return calculated data from the state, using actions to work with asynchronous data, using modules to organize a store, and using built-in helpers to work with the store. This will really help us turn our Build-A-Bot app into a full-featured Vue application. So let's get started. The first need that we have in our app for state management is a place to store our cart. As it is right now, we've had to have our cart on our build page because we've had no way to manage state across pages. What we really want, though, is to create a cart page and then be able to add a robot to the cart from the build page and then have it show up on the cart page. Vuex will allow us to do that, but we'll first need to create a Vuex store. So let's create that. But first, we need to install Vuex. So I'm going to stop my server here, and then I'm going to run npm install Vuex. And then because we're using Vue 3, we need to install Vuex version 4. If we don't specify a version, it will install Vuex 3, which is only compatible with Vue 2. Okay, so
We'll save this and then we'll run it.
All right, now let's go ahead and start our server up again. Okay, and now to create our Vuex store. So back over in our project here, let's create a new folder. We'll call that store. And then inside that store, we'll create a new index.js file.
Okay, the first thing that we're going to do in here is import the create store function from Vuex. And then we'll just use that to create our new store. And we'll pass in an empty configuration object to start with. And then we'll just need to export that from here. Okay, so we have a new store here that we're now exporting. So now we just need to jump over to our main.js file where we'll import the store that we just created. And then just like we did with our router, we'll just use that here. All right, so this makes our Vue application aware of our new store so that we can access it from inside our components. Okay, and that's it. So we have a new store here. In the next clip, we'll see how to start adding data to our store using mutations. All right, now that we have a store, let's start storing data in it. If we look at our robot builder, we have this add to cart method. And right now, it's just storing the cart items in this array. We'd like to instead add that to our store so that it can be accessed by other components, specifically by a cart page component when we create it in the next clip. First off, our store needs a state object. This state object is where we'll store all of our data. So we're going to create a cart property in our state object and default it to an empty array. This step is surprisingly important. You might think that we could just add this cart array to our state object somewhere else in our code later, like say when we first mutate the state to add stuff to a cart. But it's important for Vue's change detection that you start with a default value for everything that you add to the store. This is because Vue's change detection works by tapping into the getters and setters of objects in the store. And if you don't add a default property to the state to start with, Vue won't even notice changes when you add that data later. So for everything that you're going to store in the state, you need to add a default property for it here in the state object. Okay, so now that we have a default cart object, let's go ahead and add a mutation. So we'll just add a mutations object. And as we discussed previously, all changes to data in a store must happen through a mutation. You can't just access the store's state directly and start changing data. All changes must go through a mutation. So we're going to add an add robot to cart method here. This add robot to cart mutation will be called from our robot builder component. And the first parameter of a mutation is the state. And then the remaining parameters, if any, are the data that you want to pass into the mutation. So we're going to add a robot parameter. And now in our function here, we can say state.cart.push robot. So we're accessing the state through the parameter that was passed into the mutation. And then we're accessing the cart on the state, which is an empty array initially because we defaulted it up above. And then we're just going to push onto that array the robot that's passed into the mutation. Cool, so this is all we need in order to add data to the store. Now let's go call this mutation. So back over here in our robot builder, instead of pushing our robot onto this local cart array, we're going to access our store, and we can access it like this because our global Vue instance is aware of our store. And so it's made available to our components. So on the store, I'm going to call commit. And then the first thing that we pass into commit is the name of the mutation in our store. So this was the name of this function here, add robot to cart. So we're going to paste that in here. So we're going to commit the add robot to cart mutation. And then the next parameter that we pass in is the data that we want to pass to that mutation. And so that's our robot, which is this expression here. All right, now we can delete this line. Okay, so this is now adding a robot to our cart in our Vuex store using a mutation. And this happens when we click the Add to Cart button on our robot builder. But we can't see this at work until we display the data from the store somewhere else. So in the next clip, we're going to create a simple cart page and see how to retrieve the cart data from the store. And then you'll be able to see this working. Okay, so we've used this add robot to cart mutation in order to add our robot to the store. And now to demonstrate how to retrieve data from the store, let's create a cart page. So first we'll create a cart folder, and then we'll create a shopping cart component.
And let's get the basic content for this from our GitHub repo. So in the source cart folder, we have the shopping cart view file. Let's go ahead and grab that and paste that into here. Okay, so nothing too fancy going on here, just a bit of HTML here with an HTML table. And down here on line 16, we have this v4 that we're looping over to display each of the items in the cart. This may look familiar. We did the same thing on the robot builder page, and we'll delete that soon. And you can see here that our v4 is looping over a cart array, but that doesn't exist yet in our component. We want to get that off of our new Vuex store. For that, we'll use a computed property. So down here, let's create a computed section. And in here, we're going to create a computed property called cart. And then, although you can't mutate a Vuex store state directly, you can access the state directly to read from it. And so we're just going to access the cart on the store like this. So we're just going to return this .store.state.cart. And that's it. Now we are adding items to the cart in the Vuex store from our robot builder and then accessing it here in our cart component. So let's just go add a route and link to our cart page so we can see this working. So over here in our routes, down at the bottom here, let's add a new route, and the path for that will just be /cart, and we will name it cart, and that will use the shopping cart component. Oops, and I got this in the wrong place. Let's just cut this here. This needs to go right here. Okay, so now we just need to import our shopping cart. So right here, we will import shopping cart from cart shopping cart.vue. Okay, so we have a route for it. Now let's go over to our app component and add a link to it. So let's copy this existing menu item. And in addition to this nav item class, let's add a cart class. We're going to go ahead and pull this nav item over to the right-hand side. So there's a cart link in the top right-hand corner of our application. So we'll use this cart class for that. And then we're going to just go ahead and link to a simple /cart route here. And then since that's just a URL string, we don't need to bind. And then right here, we'll just change this to cart. Okay, cool. So now down here in our styles, next to our other nav item, we'll add a nav item.cart class. And we'll position this relative with a margin left of auto and a border right of none. All right, we're ready to go check this all out. So just as a reminder from our last clip, we added a robot to our store using the add robot to cart mutation, and that exists in our store right here. And that mutation is just pushing the robot onto our cart in our store. And then in our shopping cart, we are using a computed property in order to get the cart out of the store. So let's go check that out. So here we have our cart link. So let's go ahead and add this robot to a cart, and then we'll also add our friendly robot to our cart. And then let's go ahead and click on the cart to go to the cart page. And there we go. So you can see that we have our large Cyclops and friendly bot robots that we just added from our build page, and it's accessible to us here on our cart page. So just to make it a little bit more obvious that this is being added to our cart when we click this button, let's add a little indicator up here on our cart link that shows how many items are in the cart. So back over in our app component, let's add a computed property here to also get our cart off of the store like we did in the cart page. So add a computed section that will have a cart, and that will just return this .store.state.cart. And then up here right next to our cart link inside the list item, we're going to add a new div, and it will have a class, and we'll call that class cart items. And then we'll go ahead and close this div. And then right in here, we're exposing cart from our component. So we'll just say cart.length here. Okay, great. So this will display the number of items in the cart. And then we just need to add this cart items class. So let's just come down to the bottom here. And I'm just going to go ahead and paste this in. And if you're following along, you can go ahead and type this in. And you can see we're just positioning this absolute in the top right-hand corner next to the cart link. And we are giving it a border radius, so it'll be like a round pill, and then just a background color of sea green. Okay, so let's go see how that's working. There we go. We can see that we have 2 items in our cart. If we go to our cart, and here's our route card that we added earlier. You can see that we do have 2 things in our cart, and we go back to build, and let's add another item to our cart. And you can see immediately that changed to 3. I'll click it again here, it'll change to 4. So now we are accessing data from our store across 3 different components. It's being added from our robot builder component, and then it's being accessed by our cart and app components. Okay, that's awesome. So let's just go clean up this extra cart stuff here that we're not using anymore on our robot builder page. So here in our robot builder, down here at the bottom, we have this table data and table header and cost classes that we can delete. And then up in the HTML, we have this whole cart section here that we can delete. Okay, so that is gone now from our robot builder page, and when we add items to our cart, they are showing on our cart. So accessing data from the state is pretty simple. Next, we'll take a look at how to add getter functions to the store so that we can compute derived state in the store when necessary. So far, we've been accessing state on the store directly, just like this. Sometimes you want to have a computed property on the state that returns a value that is a calculation or derived value of some sort based on data that's in the state. This is what Vuex getters are for. To explore this, let's create a getter on our store that will return only items from the cart that are on sale. This is going to be based on this cart value from the state, but we'll basically filter the cart for just the items that are on sale. We could just do this in the component, but sometimes you want to reuse logic like this, and encapsulating logic like this in the store can be helpful. So first, let's go back over to our shopping cart, and we will duplicate our cart here. So we'll grab this header and this table, and we'll just duplicate it here. And then let's change this to an H2. And we'll change this to say, you saved money on these robots. And then let's just add a class on this H2 called sale items. And then that class just looks like this. So it'll have a margin on the top to separate it from the normal cart. And we'll give it a font size of 18 pixels. And we'll give it a red color since it's sale items. Okay, now back up in our HTML. Instead of looping over the cart, we're going to loop over a new computed property, and that will be called cart sale items. Okay, and then let's add a computed property down here for that. So this will be cart sale items. And then again, we could just grab the cart from the store and then filter it right here, but we want to do this in a getter in the store so it's reusable. So let's go back over to the store, and we'll add a new section for getters. And then we'll add our cart sale items getter. And the first parameter for getters is the state. And now we can do whatever calculations from the state that we want to do here. So we'll go ahead and return state.cart.filter. And then we'll filter that for just the items where the head is on sale. Of course, a robot would be on sale if other parts are on sale, but this is simple and you get the idea. You can go ahead and enhance this if you'd like. So now you can see that we're just filtering for any items where the robot's head is on sale, and this calculation is based on data that's in the state and then exposed as a cart sale items getter. And now this logic is nicely encapsulated here. So now the only question is, how do we access it? Well, that's pretty simple. So back over here in our cart where we created our computed property, we can access it just like we do with the state, this .store. But instead of saying .state, we'll say .getters, and we'll ask for cart sale items. Okay, let's go see how that's working. So here's our cart, and here's our new section, although it is not styled correctly. So let's come back over here and see what we did. Oh, here we go. This should be class. You probably saw that when I first did it, and it was probably driving you nuts. But now that that's styled, let's go take a look. Okay, there we go. So that's working now. So let's go ahead and add this robot that is not on sale. You can see we now have one item in our cart. And now let's go ahead and add this one that's on sale. And now let's go take a look at our cart. There we go. So you can see that we have 2 items in our cart, and only one of them is on sale. So using getters is really easy and a nice way to encapsulate any calculation logic into your store. Next, we'll start exploring how to access data from a remote API. And that gets a little bit more interesting due to the asynchronous nature of HTTP calls. Everything that we've done so far with Vuex has been synchronous, simply modifying and reading from the local state. But of course, most web applications today deal with asynchronous HTTP calls to fetch and update data from a remote API. With Vuex, we can accomplish that with actions. But first, we'll need an API to work with. To make this easy, I've already created this API over here. So let's clone this by copying the remote URL here. And then over here in our bash console, I'm going to open a new tab and change directory to where I keep my projects. And then I'm going to go ahead and git clone that. And if you're using the same bash console, you paste by right-clicking. So I'll paste my remote URL in here and go ahead and clone that. Okay, so let's change directory into that new directory. And then I'm just going to do an npm install. All right, now we can go ahead and start up this server by just saying npm start. Okay, now you can see we have a server listening at port 8081. So if I come back over to my browser and go to localhost port 8081, then I have an endpoint right here that I can hit API/parts. And there we go. So you can see now that this parts endpoint on our new API is returning all of our robot parts data that we previously have had hard-coded in our application. And now it's time to finally start getting this from a real API. So we'll do that with a Vuex action. So back over in our store, let's add an actions section. And in here, we'll create our first action. We'll call it get parts. And the first parameter to an action function is a context object. The context exposes several items for working with the state. So instead of passing in this, we could actually deconstruct it to grab what we want. It provides things like state, getters, a commit function, and a dispatch function. But all we really need right now is the commit function. So that's all I'm going to deconstruct out of the context object. The commit function is how we call mutations on the store. You may recall that we're already using the commit function in the robot builder currently to call the add robot to cart mutation. So we'll use this commit function here in just a minute. First, we need a way to make HTTP calls. Vue doesn't provide any of its own custom AJAX or data access methods or libraries. Instead, they allow you to use whatever you want to make HTTP calls. So we're going to use Axios, which means we need to install it. So back over in our console, on the tab that's running our Build-A-Bot app, let's go ahead and stop it. And then I'm going to npm install Axios, and we'll save that. Okay, let's go ahead and start our server back up. And then back over in our app, we're going to go ahead and import Axios. And now down in our get parts function, I can use Axios to get data. So I'm going to say axios.get. And then the Axios get function takes a URL for the endpoint that you want to hit. But what can we put here? Our API endpoint that we created is right here. So we could put http://localhost port 8081/API/parts. But of course, there's a couple of problems with this. First of all, we're going to get CORS issues if we do this because we're accessing a different port than what our application is running under. But also, localhost is not going to work in production. And in production, this is typically solved by hosting your application and your API on the same domain and port. But we don't have that luxury in development without some effort. That's not a problem though, because Vue provides a way for us to configure a built-in proxy so that we can proxy the API through our dev server that our Vue app is being served from. This will solve our CORS issues locally and enable us to just use a relative URL like this. So in order for this to work, we need to configure the Vue proxy to proxy our API. We can do that by creating a file at the root of our project named vue.config.js. So I'm just going to right-click here and create a new file, vue.config.js. And then in here, we just need to configure the proxy like this. So we'll do a module.exports, and we'll just export an object from here. And in here, we'll just provide a dev server configuration, and we'll configure the proxy. And we want our proxy to be running at /API. So now we can configure this API to be proxied to where our server is running. So the target for API is going to be http://localhost:8081. And then we just specify change origin, and we'll set that to true. So this is actually Webpack config. And Vue behind the scenes is using the Webpack dev server. So that's why we're using Webpack config here. So this is how you configure the Webpack dev server. So now we have a proxy running at /API that will proxy all requests from /API to http://localhost, spelled correctly, port 8081. So now this API/parts URL will get proxied to our API that's running on port 8081. So now that that's set up, we can continue working on our action. So when this Axios call finishes, we want to commit the data to our store. But before we can do that, we need to add a default value to our state. So up here, I'm going to set parts by default to just null. Remember, anything that you add to your state, you need to add here a default value for it to start with. And again, when this Axios call finishes, we want to mutate our state. But we can't do that directly. We do that through mutations. So let's add a mutation next for update parts. And that takes in state and our parts. And then we'll just set state.parts equal to the parts being passed in here. Okay, so back to our action here. When our Axios call finishes, we want to then commit the data to the store. So we'll take in our result here from our Axios call, and then we will call commit that we've destructured there from our parameters. And we want to commit the update parts mutation, and then we'll pass in the data that we get back from our API call. So that will be results.data. So Axios returns a result object, and it has a data object that has the payload that was returned. Okay, cool. And then in the event that an error occurs, I'll catch it, and then I'll just pass that to console.error. Of course, you might want to do something more useful than this in a real application, but for now, I'll just log any errors to the console. Okay, so with all of this in place, we use Axios to call our API, and then we commit the returned data to our store through the update parts mutation. Okay, cool. So now wherever we need this data, we need to first dispatch this action and then get the parts from the store instead of from the hard-coded parts.json file we're currently using. So let's start in the robot builder. So first up here, we are importing available parts from this parts file. So let's delete that. And then in order to kick off the Axios call, we need to dispatch an action. And then we want to dispatch that action as soon as this component is created. So let's go ahead and add a created hook. And then in here, I'm going to access the store with this.store. And then there's a new function we haven't used on the store yet, and that's called dispatch. And we're just going to tell it to dispatch the get parts action. So you use commit to commit mutations, and you use dispatch to kick off actions. And I'm using the wrong get here, so that's get parts. Okay, so that will kick off our Axios action, which is asynchronous. And then all we need to do is create a computed property that will return the parts from the store when the Axios call is finished. So down here in computed, let's add a new computed property called available parts. And this will just return this.store.state.parts. Okay, and then this is just complaining because we have available parts declared in two places. We don't need it in data anymore since it's now a computed prop. So our created lifecycle hook now dispatches the Axios call. And then once that's available, this computed prop will get updated whenever that data returns. And now up here in our template, in all these places that we're calling available parts, we'll now get available parts from the computed property. Okay, so this is pretty much it. We've dispatched our call, and then we're getting the data off of the store after the action in the store has committed the data via a mutation. But we still have one problem. So if we come over here, you can see our build page is not rendering. And if we look in here, we have errors. Notice that it says here, cannot read property heads of null. So back over here, that's right here. So it's saying that it cannot read property heads of null. So available parts is null. And that's going to happen everywhere below where we're using available parts also. Well, that's because over in our store here, our default value for parts is null. And so because our action is asynchronous, when the component first loads, the store returns null for available parts or for this parts property. And we could fix this in two different ways. We could provide an empty object as the default value in our store, or we could prevent the robot builder page from rendering until the available parts is populated. I'm going to go with the latter solution because the first solution would have some other cascading problems with an empty object. So let's just use a vif on this outer div here. And we will just say vif, and we will only show this if available parts is truthy. So this won't render if it's null. So this should be working now. If we come back over here and refresh. Okay, and now we're getting a 404 error, but that's just because when we created our proxy, updated our proxy config, we needed to restart our server. So I'm going to stop my server and start it again. And now let's go ahead and refresh here. There we go. No more errors here. And you can see that we are getting our robot parts just fine. And now it's coming from an API call. So if I look at network over here and refresh this page, you can see that I made this call to port 8080 API parts, and that got rewritten by our proxy server to port 8081. All right, awesome. So we have now dispatched an action which kicked off an asynchronous API call, and then we're getting that data. Now we just need to update the other places in our app where we were importing that old parts.json file and use the action instead. So let's start with these 4 files in the parts folder. So this is for the part info pages that display information about each of the parts. And these 4 files are very similar, and they're all going to need to dispatch the get parts action. And then they'll each need to have a computed prop to get the parts off the store. And since that will be repeated across all 4 of these components, let's create a mixin to do it, and then we'll reuse it. So we'll create a new file, and we'll name it getPartsMixin.js. And then this will just export a component options object. And in here, we'll add a created hook. And this will dispatch the get parts action. And then we just want a computed prop. And that computed prop will be called parts. And it will return this.store.state.parts. And this should actually be a colon here. There we go. And actually, I'd like this computed prop to do a little bit more than just this. I'd like to make it so that we don't have to do a vif check in all of our components while we wait for the parts action to complete. So we'll return the parts unless it's null, in which case we'll return a default object. So that default object will just look like this. It'll have heads, which is an empty array, arms, and torsos, and bases. Okay, so this is dispatching the get parts action and then returning parts from the store or a reasonable default object if the parts are not in the store. Okay, so let's just go use that mixin in each of these components. So here in the robot arms, we'll get rid of this import, and we can delete our data function since our mixin is going to handle that via computed props. And let's go ahead and import our mixin, get parts mixin from /get parts mixin. Okay, and then our mixin we use down here by specifying mixins and passing that in the array. Okay, and then up here we just need our v4 to loop over parts.arms instead of just arms. Okay, so now let's do the same thing for robot bases. Specify the mixin And then up here, this will be parts.bases. And then same thing here in the robot heads. And update the for loop. And then finally on robot torsos, update the for loop. There we go. Okay, so now all of these parts components are updated, and you can see how helpful a mixin was in this case. It's made these 4 components incredibly simple. And actually, we can use that mixin in one more place. This part info component also needs parts, so we can get rid of this import here and import the mixin instead, and add mixins. And then down here, we just need to change this to this.parts, since that's a computed prop now from our mixin. Okay, and that wraps up our changes. So now our whole application is getting parts data from the API via a Vuex action. And that means that we don't need this data folder anymore. Okay, cool. This should all be working now. So let's go check it out. So our robot builder page is working. And if I click on one of these parts, you can see that this is working, looking up the part information. And if I go to the parts browse, then you can see that I'm getting the heads information, arms information, torsos, and bases. Awesome. So that was a fair amount of work to retrofit our application to use the new action and API, but the amount of work that was actually involved in creating the action on our store, which we can see again over here, was not that much work, and accessing it in each of the components wasn't that much work either. It just felt like a lot of work because we were retrofitting a bunch of places. But you can see that creating actions and making asynchronous calls is actually pretty straightforward. So in the next clip, we'll take a look at how to use actions to save data to our API. We just learned how to use actions to retrieve data. Now let's look at using actions to save data to an API. The concept is fairly similar. We'll start by creating a new action in our store, and we'll call it the add robot to cart action. And again, we'll need the commit function. And then we'll also want to destructure the state off of our context parameter. We'll use this here in a minute. And then unlike our get parts action, which doesn't take any other parameters, we are going to pass in a robot to our add robot to cart action so that we can pass that along to our Axios call and add it to our state. Okay, so our API takes in a fully populated cart. So we're going to need to get the current cart off of the state, append this one, and then pass it to our API endpoint. So let's create a new cart variable, and we'll set that to an array, which contains all of the items from the old cart, plus our new robot. Okay, so this is what our new cart looks like. Now let's save it to the API with an Axios post. And that hits the API cart endpoint, and we're going to pass in our new cart. So we're posting to the API cart endpoint, and then we're passing the cart object as the body. And when this post finishes, I want to update my local Vuex state to include the robot that was saved, but I don't want to do that until the Axios post is successful. And we need to add it to our local state. Otherwise, we'll save it to the server, but our app won't reflect that we have a new item in our cart. So let's go ahead and add a .then here. So Axios post returns a promise. And then we basically want to just call our add to cart mutation to add this robot to the cart. If you remember, we do that with commit, and that needs the robot to be added. Okay, so now we have an action that will save our robot to the cart on the server, and then also insert it into the cart in our local store after that succeeds. Now we just need to call this action. So we'll do that over here in our robot builder. So we have our add to cart function here. And right now, the add to cart method is just calling the commit function on the store to commit a mutation. And we want to use our action now. So instead of commit, we'll use dispatch. And we'll now dispatch the add robot to cart action instead of calling the mutation. And the rest of this is just the same. So we're calling the add robot to cart action, and we're passing in the robot to add. So basically, the only difference between calling a mutation and an action is that you commit mutations, whereas you dispatch actions. Okay, let's go check out how our app is working now. So if you watch this indicator up here on the cart, when I click add to cart, you'll notice that there is now a delay as it makes the call to the server, and then only when it succeeds do we add it to our cart locally. And then if I open my DevTools and on the network tab, I click the add to cart button again, then you can see that we are calling the API cart endpoint, And down here, you can see that for the payload, we are passing along the cart array. Excellent. We're now using an action to save data to our API. In the next clip, we'll see how to tap into the promises that are returned by actions. If we look at our add to cart method in our robot builder, we're dispatching an action, but we have no idea here when it finishes. What I would like to do is redirect to the cart page after adding the robot to the cart succeeds. But how can I know when the action has completed successfully? Well, over here in the store, in our add robot to cart action, all we have to do is return this Axios post call. Axios post returns a promise, and we can return that from our action. And now that this returns a promise over here, I can add a .then to my dispatch call. And so when that action completes successfully, then I'm going to call this .router.push, and I'm just going to navigate to the cart URL. And now when I add an item to my cart, you can see that there's a little bit of a delay as it goes out to the server, and then when it succeeds, it navigates to my cart page. So even though we're calling dispatch here, we're not actually calling our add robot to cart function directly. The promise returned from our action still gets returned to us from this dispatch call, making it easy to respond to the asynchronous event when it finishes, or even to catch errors when it fails. So that was easy. Next, we'll take a look at how to organize our store into modules. So far, we've been adding all of our actions, mutations, getters, and state objects to the single store file. This has been fine for this small application, but imagine a larger applications with dozens or even hundreds or thousands of items in it. A single file would quickly become unmanageable. This is where modules come in. They allow us to break up a single store into multiple modules for maintainability. So let's imagine that our application had need for some other actions in here related to users, such as a sign-in action, for example. We could change our store to have two modules, a robots module and a users module. So let's create a robots module. That's easy. First, we'll create a modules folder inside our store folder, and then we'll create a new file for our module. I'll call it robots.js. And then I'm going to move all of this that is all related to robots, starting with state all the way down to my getters. I'm going to cut that out of here. And then over here, I'll export a different object, and I'll paste that in here. And we'll need our Axios import, and we won't need it over here anymore, so I'll move it from here and import it here. And then back in my store file, I'll import my new robots module. So import robots module from modules robots. And then finally, in my configuration object down here for my store, I'll just add a modules section. And then you just add a property for each of the modules. So I'm going to create a robots module, and that will use my new robots module. Okay, we'll come back and add a users module in just a sec. But for now, let's go take a look at our site. Okay, this is not looking great. So if we look at our console, you can see that we are getting this error, cannot read property length of undefined. And that's happening in our app component. So if we come back over here and look at our app component, we come up to the template up here, that error is occurring right here where we're trying to show the number of items in the cart. So the problem is that the cart is undefined here. And if we go down to our computed property for that, you can see that we're getting it from this .store.state.cart. But we just added a robots module. And if we go look at that robots module, you can see that the cart is in the robots module state, not in our root store state. And so over here, we need to access our cart with state.robots.cart.
And notice that robots matches the name that we gave our module over here.
Okay, so that should fix our error. And you can see our site's rendering. If I refresh, we have no errors here. So we're now working fine again, and we are accessing the cart through our robots module. So I want to call out something important here, and that is that we still have a single state tree or a single state object. So we still have a single state object, and on that state object, we have a robots module. Okay, so we've fixed this here, but there are actually several places in our app that we need to fix this. And right now, everything is in the robots module. So I'm going to undo this change here, and then I'm going to do a global search and replace, which you can do by hitting Control-Shift-H if you're using VS Code. And I'm going to replace this $store.state with this $store.state.robots. And that should be good. Just for a little more safety, I'm going to put an extra dot here on the end. And then I'm going to go ahead and replace everything here. Oh, you have to execute the search first, and then I will replace everything. There we go. So that updated 4 occurrences across 4 files. So now everything that was accessing state is now accessing the robot's state, which is where all of our state currently is. Okay, so now everywhere in our site should be working. We get our robot parts and we can add to the cart, and we're getting our cart data here. And that data is all coming through the state in our robots module. Now, you might be wondering about the fact that we have fixed everywhere where we're accessing state, but we didn't go in and add robots to the places where we're calling actions and mutations and getters. We'll talk about that more in the next module, but just realize that state is a little bit different than those other pieces of the store when it comes to modules. Okay, so just keep that in mind. Now, back over in our store, we currently have a single robots module. In order to see just what it looks like if you have 2 modules, and also to set us up for working with namespaced modules in our next clip, let's add a second module. We'll call that users. So in our, I'm going to hit Control-Shift-E to get my Explorer back here, and then in my modules folder, I'm going to create a new file, and that will be users.js. And then we'll get the contents of this from our GitHub repo. So over here in the repo, I'm going to click on source and then store/modules and users. And let's grab the contents of that and paste it in here. All right, now we have a users module, and notice that it has a sign-in action. And the sign-in action commits the update current user mutation. And that mutation just puts the user returned from the Axios call on the state. Now, don't worry too much about what's happening in this users module. We just needed a couple of modules to demonstrate a few things. So let's go add this to the store. So back here in our store, we will import it. So we'll just copy this one, and we will import the users module from modules/users. And then we can just add that down here. So we'll create a users module and paste in users module here. Okay, and this is it. So we now have a store with multiple modules in it. And in the next clip, we're going to take a look at namespacing our modules, which will separate these two even further from each other. There are a few nuances to working with modules in the store that we should cover. First of all, let's take a look at how actions are dispatched. If we take a look at the robot builder component, you can see that when we add an item to the cart, we dispatch this add robot to cart method. And you can see in the app that this is working. So if I click add to cart here, it does indeed get added to the cart. But if you look at our store, we have 2 modules, right? And they each have their own set of actions. So robots has a set of actions here, and users has a set of actions here. And if you think about this for a moment, you might wonder, how in the world is this dispatch working? Because we never told it which module to dispatch this action to. We updated all of our state calls to get data from the robots module, but we didn't update any of our dispatch calls. How in the world did Vue know that the robots module should be the one to handle this? Well, the answer is Vue didn't know. As we have it configured now, both modules will respond to this dispatched action as long as they have an action that corresponds to this add robot to cart name. We can demonstrate this by adding an action to the users module. So right here, I'm going to create an add robot to cart method. And we'll just have that log to the console so that we can see that it's getting called. So I'll add a console log, and I'm just going to say users add robot to cart called. All right, so now if we come back over here to our builder and open our console, now you can see that if I click this add to cart button, it did get added to the cart. So it had to have gone through the robots module to do that. But it also logged this users add robot to cart call. So you might be asking yourself, what good are Vuex modules then if it doesn't keep things separated? Especially in a larger application, you could easily make the mistake of giving 2 actions in different modules the same name and not even realize it. Well, don't worry, Vue can keep them separated if we tell it to. That's where namespaced modules come into play. So over here in our robots module, I am going to set it to be a namespaced module by just setting here namespaced to true. So now over here in the robots module, I need to add the namespace to the action name that I'm dispatching. So this will be robots/add robot to cart. I need to change this for all of my actions throughout the app. So let's do this in a global search and replace again. So I'll hit Control-Shift-H. And again, since the robots module is the only one that we're using, that we're dispatching actions to, I can just update all of my dispatches. So this is going to replace this.store.dispatch with an apostrophe. We'll replace that with this.store.dispatch with an apostrophe, and then we will prefix everything with robots/. Make sure you get all of the periods and apostrophes and everything here correctly. So then I'll execute that search and do that replace. And that updated this one extra, so I'll undo that. Okay, and then let's just make sure we do a save all after that. All right, now if we go back to our app here, and now if we go add another robot to our cart, you can see it got added to the cart, but it did not log the message from the users module. So now we are successfully only dispatching items from the namespaced robots module. Okay, so it's important to note here, I mentioned this earlier, I'll probably mention it again. So the state on a module is always namespaced, whether the module is namespaced or not. You may remember that when we first added our robots module, we had to immediately go and add robots dot to everywhere where we were accessing the state. And that was before we namespaced this module. So state is always namespaced, even if your module is not set to namespaced. But mutations, actions, and getters are only namespaced if you set namespaced to true. That caught me up a few times when I was first learning Vue, so that's important to note. Okay, so now we know how to create a namespace module and how to access the actions on namespaced modules. Next, let's take a look at how to access namespaced getters. If you remember on our cart page, we are displaying down here any robots that are currently on sale, but that's actually broken currently. If we go add a robot that's on sale, like this friendly robot, to our cart, and then come over here, you can see that it's not showing up down here. This is because we namespaced our robots module, but we never actually updated the way that we're accessing the getter right here. And if you look at the way we're accessing state up here, you might think that we would access it the same way. We could just say robots right here. But getters.robots is not actually defined. You have to actually access getters using this notation here, where we use a string to access the property, and then we preface the name of the getter with robots/. So now if we go take a look at our cart, you can see that we are getting our sale robot down here. And if I add this one that's not on sale, then it is not down here. So our getter is working now. So a slightly different syntax for accessing getters in namespaced modules. Next, let's take a closer look at how our Vuex state is structured and used inside of our modules when using namespaced modules. We've discussed how we have one single state tree or state object. But to remind ourselves of how that state is structured, let's add a couple of variables to our state. First, we'll add a state object on our root store config. So we'll add state here, and then we're going to put a variable in here called foo, and it will just be set to root foo. Okay, so we now have a foo property in our store, and this is called the root state because it's not in a namespaced module, so it's part of the root state. And actually, any state that you add to non-namespaced modules is also part of the root state. Now let's add this same property to the other modules. So we'll add a foo property here, but it will be set to robots foo. And then we'll do the same thing in the users module, and this will be called users foo. Okay, and then let's do something similar with a getter at each level. So in our root store, let's add a getter. So we need a getter section, and we'll create a foo getter, and we will return root getter / and then the value from the state property, state.foo. So this is just prepending root getter to that string and returning it. Now let's do the same thing for getters in the robots module. So down here we'll add a foo getter, but it will prepend robots getter. And then we'll do the same thing for users. So right here in getters, We'll add a foo getter, and it will prepend users getter. Okay, so now we have a foo property on the state at each level and a foo getter at each level. This will help us demonstrate some interesting things about how state works across different modules. So let's go print those out in our app component here, and we'll put it right here at the top. So I'm just going to print each of these out like this. So you can see that here I'm printing out each of the foo properties from the state, and then down here I'm going to print out each of the foo getters from the state in each of the modules. So we'll need some computed props for that. So down here in computed, I'm going to create a root foo computed property, and that will return
this.store.state.foo.
And then we'll do the same thing for each of the modules. So this will be robots foo, and this will return this.state.robots.foo, and the same thing for users. Okay, and now I just need computed props for each of the getters. So I'm going to have a root getter foo going to return this.store.getters.foo, and then the same thing for robots, but it will return this.store.getters, and we need the string syntax robots/foo, and then same thing for users. Okay, so let's go take a look at this, see what it looks like. Okay, so there's something interesting at the top here in these first three variables that we're printing out. So these are the items that we got directly off of state. Notice that users does indeed have its own namespaced state, even though it is not a namespaced module. So in our app component, we're accessing it with this.state.users.foo, which is a thing. So even though users is not a namespace module, it does have its own namespaced state. So again, just a reminder that state is always namespaced in a module, even if the module itself is not set to be namespaced. And then another point to make is that root state is not inherited by modules. And so if I get rid of this foo property here and save it on the users module, and then come back and look at this, it is empty. So this.state.users.foo is not set to anything. So it is not inherited from the root state. So let's go ahead and put that back. Okay, so let's come back and look at this, and let's look at the getters. So first of all, notice that the users getter did not return anything. And that's because in our app module, in the computed prop, we were accessing it with this.store.getters users/foo. And so we're trying to access a namespaced getter on a module that is not namespaced. So that's not too surprising that that's not showing up. But what might be surprising is if we look at the console here, you can see that we're getting this error, duplicate getter key foo. This is because the users module and the root store are sharing the same namespace. And yet over here, you can see that we've created in our users module a foo getter. And we also have on our root state or our root store a foo getter. And so we're getting an error because we've created a getter with the same name in two different places that share the same namespace, specifically the root namespace. So let's see what happens if we get rid of this getter that's at the root level. And so now if we go back to here, it shouldn't be too surprising that when we called the root getter, we got the users getter value. And so in our computed property, in our app module, the root getter is calling this.store.getters.foo. And in the users computed property, we're calling getters user/foo. And we've already talked about that this is not a thing, this is not defined. So it's interesting that the root getter is getting the value from the users module. And that's because this is not a namespaced module, and so its getters are shared with the root store. And so the root store doesn't have a getter, but we added one here, and technically we're adding that to the root namespace. And so when we requested the foo getter from the root namespace, it retrieved this one, even though it was defined in the users module. Okay, now let's explore something else with this getter. So I'm going to remove this foo property off of our users state. And then I'm going to come back over here and let's see what we're getting. Okay, so now when we call the foo getter, we're getting users getter /undefined. And so That's kind of interesting because we've already established that we would get into this getter here because we don't have one defined on the root and they're shared. But why is state.foo undefined? If the user's module is not namespaced, why are we not getting the value here from state.foo? Well, remember, state is always namespaced. And the state that's passed into getters and other places like actions and mutations, within the module, it is always that local module's state. And so this is trying to get state.foo off of our user's module, and there is nothing. And so that is printing undefined. So that's the other important point, is that the state that's passed into mutations, getters, and actions is always the local state from that module. But what if we did want to access the root state from this getter? Well, that's available to us as the third parameter in our getter function. So the second parameter is the getters, and the third parameter is root state. So in a non-namespace module, this is all the getters in the entire store, including getters from namespace modules. In a namespace module, these getters are only the local getters in case you need access to them inside another getter. And then we have the root state. So let's use that here. Okay, now if we go take a look at this, there we go, perfect. So we are now getting from the getter inside the user's modules, we are now getting the value from the root state. And that remains true even if we come back over here and put a foo property on here, set to users foo. Over here you can see we're still getting root foo, and that's because we're using the root state here. And everything that we've said here about getters is also true of actions and mutations, except that root state is not actually available to mutations, so it is not passed into mutation functions. But in an action, I can get access to root state by destructuring it, just like we do everything else off of the context object. And then you can access root state here, but we don't have a need for that, so we'll remove that. So as a reminder, root state is not actually available to mutations. There's been some discussion about whether it should be added here, but for now, if you need access to the root state in a mutation, do it in an action, not the mutation. Hopefully this has helped create a little bit more clarity around some of the nuances with what data and methods exist where in a namespaced and non-namespaced modules. Next, we're going to take a look at some helper functions that Vuex provides to make it a little less verbose to access items from the store in our components. If we take a look at the methods that we just added on our app component, you can see that there's a lot of boilerplate here just to get these three props off of state. Vuex provides a MapState helper to simplify this. So let's import that helper. So up here, I'm just going to import MapState from Vuex. And then we can just use MapState right down here in the computed section. So the most simple form of MapState looks like this. So you spread the results of calling the MapState function, and then we pass along to that an array of strings. So this is basically saying, take the foo property off of the root state and provide it as a computed prop with the same name. So it basically replaces this syntax down here, except that we're actually renaming this property to root foo. If you want to give your computed prop a different name than what it's called in the state, like root foo in this case, then you need to use an object syntax instead of the simple array syntax. And if I had additional props here with the array syntax, I could just add the other props here. But if I want to rename it, I need to use a different syntax. So instead of an array, I'm going to use an object, and I'm going to set root foo on that object to foo. So this is a shorthand syntax that now is exactly equivalent to the syntax below. So we can remove this. We just need a comma here. Okay, but what about this robots foo? We would like to be able to just say robots foo here, but what would we pass in here since this is coming from the robots module? Unfortunately, this requires a little bit more verbose syntax. So we set this to a function, and then we can pull whatever off the state we want to, like this. And then we can delete this right here. So now we have our MapState function boiled down to just a single line, whereas it was 6 lines before. Granted, this is wrapping, and frankly, we should probably clean this up by moving this down here like this. So that syntax is a little bit more verbose when you are working with modules, but you can see this is still a lot cleaner than it was when it was 2 separate properties and we were using 6 lines. But actually, there's another syntax that we can use when working with modules. So let's use this other method for this user's foo property. So I'm just going to use a second MapState call here. But this time, the first parameter is going to be the name of the module. So now this MapState function will work with anything on the users module. And since we're renaming foo to users foo, then I can just pass it an object users foo and set that to foo. So this syntax is now equivalent to this code here. So we can delete this code. So that's a pretty clean syntax that we could use, and we could use that up here for robots foo also, but we'll leave this how it is so that you can see the different examples. And actually this is plural users. However, we have a small problem here. If we go over here and look at our site, you can see users foo is not rendering. And if I look at my console, you can see module namespace not found in MapState, and it's referencing our users module. Well, the problem is, I think this is kind of unfortunate, but the problem is that this syntax only works with namespaced modules. And so we're actually going to be forced to use this syntax for the users foo property. So I'll use the function syntax state.users.foo. But we could use this syntax for robots since it is a namespaced module. Now if we go take a look at this, now everything is rendering correctly, and if I refresh, we don't have any errors here. So just keep in mind that this syntax can only be used for namespaced modules. Okay, cool. So just like there's a MapState function, there's also a MapGetters helper. So let's go take a look at that next. Using MapGetters is identical to using MapState. So let's go ahead and import that up here also. And then we can use it in the exact same way. So down here, I'm going to spread MapGetters. And then for the root getter, I will just use the object syntax because I want to rename it to root getter foo. And that is going to grab the foo getter off of the root store. And then I will use the module syntax for the robots getter, like this. And then we can delete these 2 functions here. And actually this users getter foo is leftover code from an earlier demo. We're not actually using that, so we can delete that there. And we can delete the binding for it up here also. Okay, and that should be working fine. There we go. The getters are now working just as we'd expect. And again, this code is a lot less verbose than it was before. And so these helpers are nice. And next we'll do the same thing for actions, although MapActions is a little bit different. So let's take a look at that. MapActions is similar to MapState and MapGetters, but it's got a little bit different syntax. So first of all, we will import MapActions right here from Vuex. And then the first difference with MapActions is that instead of using it in the computed section, we will use it in the methods section. So right here, I'm going to spread MapActions. And there are a couple of actions in here that we want to map, and both of them are in the robots module. The first one is up here in this created hook. It is this dispatch right here where we're dispatching get parts. And the second one that we want to use is this add robot to cart action down here. So we'll map both of these actions here, and we'll start out by specifying the robots module since it's a namespaced module. And then we don't need to rename these actions at all, so we'll just use the array syntax and we'll pass in get parts and add robot to cart. So actually this syntax is identical to the other helpers, but we're putting it in the methods section of our component. And the way we call them is interesting for actions. And this is in the methods section, so that means that these are now methods on our component named get parts and add robot to cart. So if we go up here to where we dispatch our get parts call, we can just call this dot get parts. And the interesting thing about this is that notice that we're not calling dispatch anywhere anymore. Calling dispatch is taken care of for us by the MapActions helper. So that makes using it really nice. And now we can do the same thing for add robot to cart down here in our add to cart function. So we can just call this dot add robot to cart. And then we'll delete all of this, but we'll still pass in our robot. Cool, so now we're not having to worry about any dispatch details, and this feels a lot cleaner. So let's go check this out. So over here in our robot builder is getting its parts, and I can still add to cart here. Awesome, this is working great. Let's go clean this up so that we don't have this extra stuff up here anymore. So in our app view component, I'm just going to comment this out in case you want to reference it later. And there, now our site's looking decent. Cool, so now we've talked about MapState, MapGetters, and MapActions. The last helper that we'll talk about is the MapMutations helper. MapMutations is not any different than all the other helpers. We don't have any mutations that we're using outside of the store, but I can show you how we'd use it if we did. So we'll just import MapMutations, and then down here in methods, we'd map mutations just like everything else. So we spread MapMutations, and then add the module name if necessary, and then the array of mutations that you want to map over. Of course, we could use the object syntax here also, just like we did with the MapState if we wanted to rename the method locally. And that really is all there is to using MapMutations. It's just like using any of the other map helpers. But of course, we don't have any mutations, so I'm going to go ahead and delete this. So with that, we've covered all of the different Vuex map helpers. And in fact, this concludes our discussion of Vuex. In this module, we learned how to use Vuex to manage all of our application state. And this included creating a Vuex store, changing state with mutations, retrieving data from the state, using getters to return calculated data from the state, using actions to work with asynchronous data, using modules to organize a store, and using built-in helpers to work with the store. In the next module, we'll learn how to create our own custom directives and how to create and use filters. Welcome to this module on creating custom directives and filters. In this module, we'll learn how to create and use our own directives similar to directives we've already been using, such as vif. We'll also learn about Vue filters and how to create and use them. We'll learn about creating and using custom directives, passing data to directives, declaring directives locally versus declaring them globally, creating and using filters, and declaring filters locally versus declaring them globally. All right, let's check it out. Vue comes with a handful of built-in directives that we've been using already in our application. For example, this vif attribute is actually a directive. Same with vshow and v4. But what if we want to create our own directives? Let's explore how to do that. If we take a look at our robot builder, when we select a part that's on sale, it shows this sale icon down here. This is happening in our part selector. If we go take a look at that, it's this span right here. And the span is being displayed in the bottom right-hand corner using CSS. Imagine though if I had a common need for pinning an element down in the bottom right-hand corner. Instead of having to always create a class that absolute positions the element in the bottom right-hand corner, I could just create a directive that does it for me. Let's do that for this sale element. So to start with, let's come down to the CSS and remove the positioning attributes out of this sale class. So we'll remove position, bottom, and right. And then I want to be able to pin an element to the bottom right-hand corner just by adding a directive like this. So here I want to be able to just say vpin. And then just because I added this directive, this element will be pinned in the bottom right-hand corner. So let's go create this directive. So in the shared folder, I'm going to create a new file, and we'll call that pin-directive.js. All right, and then to start with, this is just going to export an object. And then a directive has a handful of methods that act as hooks.
One of the most commonly used hooks is the before mount hook. So before mount is a function on our directive object, and this will get called as this directive is being mounted to its parent component.
And the first parameter that gets passed in here is the element itself. So in the case of our part selector, that's going to be this span element right here. And this pin directive is going to be really simple. I just want to apply some styles to the element that is being passed in. So I can do that by just grabbing this element and then setting the style.position property to absolute. And then I'll also set the bottom and right attributes to 5 pixels. And then the same thing for the right attribute. And then that's it. That's all there is to creating this directive. Now back in our part selector component, we need to import our new directive. So import pin directive from shared pin directive. And then we can just declare this locally in our component with a directive section here. And then that takes an object where the key is the name of the directive that you're going to use in your template, and then the directive that we imported, so pin directive. And now because we've defined this as a directive here and named it pin, I can now use that up here in my directive like this. So notice that v- is prepended to the name of the directive that we created. Okay, this should be working just fine, so let's go check it out. There we go, so it's showing in the bottom right-hand corner, and then just to demonstrate that this is coming from the directive, let's remove the directive from this element, and then refresh here. And then there you go, you can see the positioning is off. So let's go ahead and put that back. Awesome, that was really simple. Now let's go take a look at how we can pass some data into our directive. Our new pin directive is kind of cool, but it's not very flexible. It's always going to pin items to the bottom right corner. Let's make it so that we can tell the directive where to pin itself. There are a couple of different ways that we can pass information to a directive, so let's explore them both. The first is through the use of args. So back over here where we're using our directive, we can use args to tell our pin directive we want it to be pinned to the top right like this. So here I'm using args to say I want to position this in the top right corner. It's fairly expressive and to the point. The first part of this expression, position, is called the arg, and the parts that follow it, separated by periods, are called modifiers. So position is the arg, and top right are the modifiers. And then back over here in our directive, we can get access to that information through the second parameter, which is binding. And the binding has a couple of properties that we're interested in, arg and modifiers. So let's just console log those out for a second to see what those look like. So we'll console log the arg and then the modifiers. Okay, let's go look at that. So if we open our console here, there we can see that we're getting a couple of things logged out. So arg is position, and modifiers is an object with two properties, right, which is set to true, and top, that is set to true. So modifiers is an object that contains each modifier set to true if they exist. So back in our directive, we'll check the first arg to make sure that it's set to position, and if not, we'll just do nothing. So get rid of our console log here, and then we'll just say if binding.arg does not equal position, then we'll just return and do nothing because the data being passed in is not in the format that we expect. And then basically I want to loop over each of the modifiers and apply the style that pins the element to the corresponding position. So to do that, I'm going to use object.keys, which enumerates all the keys on an object. And so we want to enumerate over all the keys on the binding modifiers object. And then for each of those, we will call this function, and that key will be passed in. And then for each key, and the keys here are going to be top and right, I just want to say set element.style with that key equal to 5 pixels. So this will set element.style.top to 5 pixels and element.style.right to 5 pixels if those are the modifiers that are passed in. Okay, and then we can get rid of these down here. So we'll always set the position to absolute, and then we will set the top and right, in this case because we're passing in top and right here, we will set top and right to 5 pixels. If we send in something else other than top and right, those will get set to 5 pixels. Okay, let's go see how this is working. So if we look at a sale item, there we go. It is pinned to the top right now. All right, let's go see what happens if we change this to be pinned to the bottom left. And let's refresh that. And you'll notice that you saw some really weird behavior there when we came back here before we refreshed. And we'll get into that in a minute here. But notice if I do a full refresh on my page that it is now in the bottom left. So when I first came back to here, before I refreshed, keep in mind that hot module replacement is at work here. And so as we're making changes, hot module replacement, which is part of the Webpack server, is applying those changes to our website without doing a full page refresh. And what was happening here is hot module replacement was still doing its job, but our directive wasn't noticing all of the changes. And that's why it was pinned actually to the top right and the bottom left. And so it made the entire image red. So in the next clip, we'll cover why it wasn't noticing those changes. But first, I had mentioned that there are a couple of ways to pass data into a directive. So let's look at the other way. The second way isn't quite as expressive, but it's much more flexible. So instead of using args and modifiers, we're going to pass everything in as an object. So I'm going to set vpin equal to an expression, and that expression is going to be an object. And we'll use that object to define the position. So let's say we want this to be pinned to the bottom with 10 pixels of spacing, and to the right with 5 pixels of spacing. So this object is going to be passed into the directive. And you can see how this is more flexible than the args notation, because I can actually pass values for each one of the arguments that I want to pass into the directive. So over in our directive, we can access that with binding.value. Okay, and then we're going to delete this check here for binding.arg. And then we're going to change our loop to loop over the keys in binding.value. So binding.value is set to whatever we passed into our directive here. So it's this bottom right object. And then we will set that to binding.value.position, where position is the value being passed in here. So let's rename this to position just to be a little bit more clear. So for example, in this example here where we're passing in bottom 10 pixels and right 10 pixels, then position here is going to be bottom and right. So we're going to set element.style.bottom to binding.value.bottom. So this would set bottom to 10 pixels in this case. Okay, let's go check that out. There we go. Now you can see that this is showing in the bottom right, but you can see there's 10 pixels from the bottom and 5 pixels from the right. Okay, and to show that we can now configure it, let's come back over here and let's change right to 50 pixels and see what that does. Okay, notice that again, we changed it, but we're not seeing any change here. And we won't see that change until we refresh. So there, now we can see that it's 50 pixels to the right. So the question is, why are we not seeing this unless we refresh? Because our hot module replacement is working, but this is actually a problem with our directive, where our directive is not noticing the changes. So in the next clip, let's take a look at the different directive hook functions. This will help us fix this problem. You may have noticed throughout this course that we've had hot module replacement working, which causes our dev changes to be immediately rendered without having to refresh the browser. And you may have also noticed that our changes to our directive have been requiring us to hit refresh. And this is due to the lifecycle hook that we're binding to in the directive. So over here in our directive,
you can see that we're using the before mount lifecycle hook. This hook gets fired when the directive is first mounted to the component.
So this code only gets fired once. But demonstrating this with hot module replacement is obscuring the issue. So let's create a better way to demonstrate the problem. So over here in our part selector component, instead of hard coding the padding here, let's bind to it. We'll use a new pin padding property. And we'll use that in both places here. And then to help demonstrate that, let's also just display that pin padding right here. And then let's just make it so that when we click on this sail element, it sets the pin padding to 30 pixels. Okay, so the attributes for our bottom and right are set to pin padding, and then when you click on this element, we set pin padding to 30 pixels. In order for this to work, we need to add it to our data function down here. So we'll add pin padding, and let's default that to 10 pixels. So when the component first loads, this will be set to 10 pixels, and then when we click on the sail element, it will change it to 30 pixels. Okay, so let's go take a look at this. So let's refresh, and then over here, okay, so you can see that the pin padding is set to 10 pixels, and actually where we placed this is not very easy to see. So let's move this interpolation up here to the top. That should make it easier. There we go. So you can see that our padding is set to 10 pixels. And when I click on this element, it will change it to 30 pixels. There you can see it changed it to 30 pixels up here, but notice that our directive didn't get updated. And this is because we are only binding to the
before mount lifecycle hook in our directive.
So there is another lifecycle hook that we can bind to, and it's the
updated hook.
So right here, let's add
an updated function.
And that takes in element and binding also.
And then this updated function is actually going to do the exact same thing as our before mount function.
So let's extract this out here. We're going to cut this out of here, and we'll create a new function called apply style. And that will take in element and binding. And then we'll just paste that code in here. Okay, so now we have this apply style, and we can actually call that from
before mount
and from updated. Okay, so now our directive will also get updated whenever its parent component is updated, which includes when the directive's bindings are updated. So let's go check this out. So if we come back over here now, and let's refresh one last time and then come over here. Now notice when I click on this that the directive is updated. So the directive is noticing changes now on the bindings of its parent element. Okay, now there are 3 other lifecycle hooks that can be tapped into, including
created, which is called before the host element's attributes or event listeners are applied. Mounted, which is fired when the directive is mounted in its parent node. Before unmount, which is called right before the host element is unmounted. And unmounted, which is called right after the element is unmounted.
We're not going to demonstrate these 3 lifecycle hooks in this course because they're much less common.
The before mount and updated hooks are by far the most common.
In fact, it's actually so common to use
before mount and updated together
that there is a shorthand for creating a directive that hooks into both the bind and update hooks. And since that's what our directive is doing, let's change ours to the shorthand syntax. So here, instead of exporting a object, we're going to export a function. And that function is going to take in the element and binding parameters. And then the body of this is just going to be this function here. So we'll cut this out here and paste it in here. And then we can delete the rest of this. And we can delete our apply style function. Cool, so you can see how this is much more to the point and a lot less ceremony going on in here. And we are now binding to both the bind and update lifecycle hooks. So this is a really common way to write directives. And that should still be working fine, so let's refresh this. And there we go, our directive is still working as expected. All right, awesome, and that's how we create directives. Now let's go clean up this extra 30 pixels display here. We don't need that. There we go. Cool. So now let's go take a look at how to make directives available globally. So far, we've only been making our directive available to a single component by importing it here. This is a good idea if the directive is really only related to a single component or just a couple of components. But often we'll want to create directives that we want to use throughout our app on lots of different components. When we do that, it's better to declare the directive globally so we don't have to declare it in every component like we have here. So let's see how to do that with our pin directive. It's really quite easy. So we'll delete this directives section here and we'll delete the import. And now, of course, if we look at our site, that directive is no longer working. Otherwise, this would be pinned in the bottom right. And if we go look at the console, you can see that we're getting errors. Failed to resolve directive pin. So our component doesn't know about this directive. So now let's go declare it globally. We just do that in our main.js file. So if I come in here, so let's import our directive here. So import pin directive from shared pin directive. Okay, now we can make our Vue application aware of this directive by just calling
.directive on our Vue app.
And then we will pass in our pin directive, but first we have to give it a name. So this is the pin directive, and then we pass in our imported pin directive. Cool, and that's it. This directive should now be available for use in all components in our app. So if we go check that out over here, you can see we're no longer getting an error here. And if we come over here, there we go, it's pinned to the bottom right. Awesome, so directives are really quite simple to create, and they can be really useful for sharing some functionality on elements around your site. Next, let's take a look at using filters in Vue. Vue filters allow you to easily transform data in your templates, but sometimes the name can be a little misleading. Sometimes when we think of a filter, we think of something that takes a list and filters out items from the list. While Vue filters can certainly be used to do that, that's not all they do. When you think of the word filter, maybe it's easy to compare them to a filter on a camera, which takes a photo and transforms the way it looks in some way. Vue filters do something similar for data. They take data in as input and output something different. To demonstrate how to create and use a filter, let's create a currency filter.
The way we use filters in Vue has changed significantly in Vue 3. The old filter syntax has been deprecated, so I'm going to first demonstrate how filters were created in older versions of Vue prior to Vue 3, and then I'll show how the new syntax works. Okay, let's jump into the older syntax.
You can see here on our cart page that we're displaying the cost of each robot, but it's not formatted very nicely, so we'll create a currency filter to format it. To do that, we'll create a currency filter here in our shared folder. So I'm going to create a new file here, and we'll call this currencyfilter.js. And a filter is really just a function, so we will export a function here. And a filter always has a minimum of one parameter, and this is the input for the filter. So we're going to specify amount here since this is a currency filter. And then our filter is just going to return a string. And we'll use a string template here. And our string template is just going to prepend a $sign to the amount. So this looks a little bit weird because we have two $signs, but this is just the string template syntax. And then we're prepending a $sign here to this amount variable. And then we're just going to format this amount with 2 decimal points. So we'll just say 2 fixed here. Pass in 2 decimal points.
Okay, so far all we've done is created a function and exported it. And this works for both Vue 2 and newer versions of Vue. It's how we use this function that has changed. In Vue 2, adding a filter to a component is similar to how we added a directive. So
over here in our shopping cart component, we're going to import our currency filter from shared currency filter. And then we'll just add a filter section. And we'll add a currency filter and set that to our currency filter. Now up here in our template, we can use that right here inside this interpolation expression. So right after cost, I'm going to add a pipe and then the name of our filter, so currency. So as you can see here, the first parameter that is passed into the filter is the value that precedes the pipe. So robot.cost is going to be passed in as the first parameter of our currency filter. And then we'll just copy this here and paste it down here where we're showing the cost also.
Okay, now this syntax does not work in Vue 3 and beyond, so if you try to do this in a newer version of Vue, you'll get an error page that looks like this, which is indicating that filters have been deprecated. So we'll come back to how to handle this in Vue 3, but for now, let's look at how this would work in a Vue 2 app.
So we have our currency format here, and if we add a robot that's on sale, then that's getting formatted down here also. Excellent, so that's formatting really nicely, and that was really easy. But what if we wanted to be able to specify our currency symbol here? Right now we have it hard-coded to the $sign. Well, we could do that by passing a second parameter to our filter. So let's see how to do that. So back over here in our currency filter, let's add a second parameter called symbol. And we'll use that down here instead of this $sign. So we'll use another expression here, pass in symbol. And now that symbol is going to be prepended to the amount. All right, and if we go take a look at that right now, you can see that undefined is being prepended to our amount, and that's because we are not passing in a currency symbol yet. So back over in our template, we can just pass that in like this. So I'm going to pass in a $sign here, and then we need to do the same thing up here. So let's pass in the currency symbol here. Okay, now if we take a look at this there, we can see that we're getting a $sign here.
Okay, so that's the Vue 2 syntax. To use filters in Vue 3, however, we just need to import them and call them like functions in our methods section. Or we could just create a computed function and put the logic right inside that computed function. But since we've already got a separate function imported here, let's go ahead and show how to use that as a filter. So all we need to do is add a methods section to our component. And then we can just expose this currency filter function to our template as a currency function like this. And now we can delete this filter section. And then up here, instead of using the pipe syntax, we will just call our new currency method and pass in the cost and symbol like this. And then we need to do that up here too. So we'll call our currency method right here also. So not too hard to move from the Vue 2 syntax to the newer syntax. And now this is working in our newer app too.
Okay, so we now have a currency filter that takes in additional parameters. And of course, you can do any type of data transformation you'd like with a filter, since it just takes data in and returns data out. And since filters are just functions, we could also just import them inside our component or anywhere else in our application and use them in a component like as a computed prop or whatever. They're just functions, so we can use them however we want. Next, let's take a look at how to declare this filter globally. Just like we did with directives, we can declare filters globally. Right now, our currency filter is just imported and exposed only in our shopping cart component. But using a currency filter is pretty common, and so we might want to use that elsewhere in our app. So let's declare it globally. So we'll start by removing this import here and the filter here. And then over in our main.js file,
you used to do this similar to the way you do directives, so .filter. But that actually has changed now in the latest versions of Vue. What we need to do is declare our app as a variable, like this. And then down here we can say app.use. And now we can use Vue's global API to declare our filter globally. So we're going to say app.config.globalproperties.$filters. So this is now an object with methods on it that we want to expose as filters. So I'm just going to say currency is my currency filter. And then I need to import that. Okay, so our currency filter is now declared on the global properties. And that means back in our shopping cart, we can just access it in our template like this, $filters.currency. And we'll use that up here too. Okay, so now the currency filter is available to all of our components without having to import them. And if we go back over to our app
and add something to our cart, there we go. Our currency filter is now working and it's being shared globally. So awesome. Now we have a currency filter that we can use anywhere in our app. In this module, we learned about creating and using custom directives, passing data to directives, declaring directives locally versus declaring them globally, creating and using filters, and declaring filters locally versus declaring them globally. Now that we've explored all the fundamentals of building applications with Vue, let's explore how to build and deploy our app to production in our final module of this course. Welcome to this final module on deploying Vue applications to production. In this module, we'll explore everything from packaging our application for production to production configuration options to actually deploying to a production server. The basic Vue CLI build is a zero config build with reasonable defaults that can be extended or modified whenever necessary. This means that you could very reasonably create a new project with the CLI, develop it, and then use the CLI to create a production-ready build without having to do any configuration, Webpack or otherwise. Of course, in reality, that rarely happens. It seems that we always need to be able to tweak configurations as we make changes to support our development decisions and to support our development and production environments. Luckily, the configuration is very extensible and easy to customize with whatever Webpack configuration changes you need to make. We'll take a look at how to do just that. But first, let's take a look at what a zero config build includes. So just what is included in an out-of-the-box zero config deployment? Well, the answer is a lot. I'm not going to read through all of these, but this is what I found when looking through the Webpack config generated by the Vue CLI at the time this course was produced. There's a lot here, and it includes all the things you'd typically want from a Webpack build like minification, concatenation, cache busting via chunk hashing, CSS preprocessor support for the most popular options, etc. Everything you'd typically think about when creating a build. And so there's a good chance you'd do just fine right out of the box. But in the event that you need to add or remove something to config, you can always do that. In this module, we'll cover creating a basic Vue.js build using the CLI, using environment variables and build modes, deploying to a production web server, handling deep linking when using HTML5 history mode for routing on the client side, inspecting the built-in Webpack config, and customizing the Webpack config. Once we're done with this last module, you will have mastered all the fundamentals you need to know to get started with creating and deploying Vue.js applications. So let's jump in and wrap it up. Once you've finished development and you're ready to deploy your changes to production, creating a deployable build is simple. Typically, all you need to run is npm run build. So this script will tell the Vue CLI to create a deployable build utilizing all of the built-in Webpack config that the CLI generated for us when we first generated our project. This will result in a production deployable distribution folder. This build will contain all of the latest best practices identified by the Vue team for generating a deployable web application, including all of the optimizations we mentioned in the previous clip. All of this without us even having to think about it. Of course, if you want to dig into it and make modifications, you can. More on that later. So let's go ahead and run this. Now that this is finished, we have this deployable dist folder. All we need to do to deploy this to a production server is copy this dist folder to a place where it can be served by our web server. We'll do this with an express web server later. If we take a look inside this dist folder, you can see that we have CSS, JS, and IMG folders, in addition to a favicon and an index.html. The CSS, JS, and image folders are the Webpack contents of all the code that we've written for our application. But where did this favicon and index.html come from? We never created those. Well, those came from this public directory right here in our project, and they were generated by the CLI when we first created our application. And actually, any file that we put in this folder will be included in the final dist folder. But this index.html file is an important file. This is the starting point for our entire application. When we deploy this to production, our web server needs to serve up this index.html file whenever anyone hits the URL for our application. That will then load up our entire Vue.js application. And that's all there is to generating a zero config deployment for production. Next, let's take a look at some other options that we have when building this dist folder, and then we'll see how to deploy it all to production. When we ran npm run build to generate our deployable dist folder, we didn't pass any arguments to it, which means that by default it ran in production mode. But sometimes you want to be able to generate different deploys for different environments. We can do that with the mode flag. The default build that is created when we run npm run build is actually equivalent to this command, running npm run build with the switch mode equals production. So by default it runs in production mode if we don't provide this mode flag. But we can provide different modes. For example, we could create a development mode build and pass in a development flag. And actually, when you run npm run serve, as we've been doing all along throughout this course to serve up our application in development, it actually creates a development mode build. The important thing to understand is that setting mode by default also sets the node_env variable. And this is really important. The Webpack build that is generated when the node environment variable is set to production is very different than when it is set to development or anything else. Only production mode builds should be used in production. But what if we want to create a staging mode build and have it use the production node environment variable so that we could test a production build in a staging environment prior to production deployment? Well, we can do that with environment variables. To demonstrate that, let's see what happens if we create a staging mode build. So I'm going to set mode equal to staging, and we'll run that. All right, now take a look at what is in our dist folder. This looks quite different from our production build, which had bundled things up very nicely in a way that was appropriate for production. This staging build is basically a development build. So we just have this one app.js file, for example, instead of optimized chunks. But we can change that so that we could have a staging build that runs in production mode. So over here in our project, in the root folder, I'm just going to create a new file. And we'll name that file .env.staging. And then inside here, I can set environment variables, including node environment. And so I'm going to set the node environment here to production. Because even though I'm building a staging build, I want it to be a build that looks just like production, so I can test it in staging just like it will look in production. So I'll save that, and then let's come back over here and let's run our npm run build with mode staging again. Okay, you can see from the output there that it's very different. So if I take a look at my dist folder again, you can see this is all optimized like it was when we did a production build. So we can actually use any word that we want here for the mode. So I use staging, but this could be foo or anything else. And then we just create a corresponding .env file with that mode name appended to the end of the file name. And it will use any environment variables that we put in here for the build. Which leads to another question. What other variables might you put in your .env file? Well, you could have, for example, connection information for connecting to databases or other configuration options like that. Just be sure that if you do that, you don't ever commit secret information to GitHub or anywhere else. You'll want to encrypt those values or find some other solution. But there's another thing that we can use environment variables for. Let's create another environment file, and we will call it .env.development. And in here, let's create a new environment variable. We'll just call it Vue app test. Now, the Vue_app piece of this is important. More on that later. For now, I'm just going to set this to foo. And now that I have that set, let's come over to our home page, and we'll add a created hook in here. And then when our homepage component is created, we're just going to console log process.env.vueAppTest. And we created a development.env file with the app view test variable in it set to foo. Now we just need to start up our server again. So let's come over to our home page now and open up our console and just refresh this. And there you go. You can see that foo got logged here because in our home page we console logged process.env.vueAppTest. And in our .env.development file, that is set to foo. Now let's see what happens if we don't prepend view app to this. So we'll just call this some test bar. And then back in our home page, let's also print that variable, process.env.someTest. Okay, and let's stop and restart this again since we changed our .env file. Now let's come back over here and refresh. Notice that we got foo and undefined. And so in our config file, VueAppTest was available to us, but someTest was not. This is because for security reasons, Vue will only make environment variables available to our client-side code that start with Vue_app_. But there is one exception to this, and that is node.env. So if we were to set this to development or any other value, node.env would also be available to us in our client-side code. And this is because it's not uncommon to want to get access to the node environment in your code. So that one is available without prefixing it with VueApp. But every other variable needs to be prefixed with that. So you can use these variables in order to provide server-specific variables to your application based on the environment that you're operating in. Okay, so now that we know how to configure our deployments with environment files, let's see how to actually deploy to production. We just learned that we can create a production build with npm run build, and that creates this dist folder. Now we need to serve that folder from our web server. Your deployment process will be different based on the production web server you use, but just to give you an idea what a basic deploy looks like, we'll deploy our site to an express web server. If you remember from earlier in the course, we cloned a build-a-bot server that we used as an API. And up till now, that's all we used it for is an API. But let's update it to also serve our newly packaged app. Then we'll just deploy our app by copying this dist folder into our server. So let's open this up in Visual Studio Code. And then we'll maximize that. And you can see here in the index.js file that we have a few routes set up for our API. Let's just add a route to also serve the app from a dist folder. And then we can just copy in the dist folder whenever we want to deploy a new version of our application. So all we need to do is right here at the bottom of our routes, add an app.use. And we'll specify the root URL here. And then we'll use express.static to serve the dist directory. And we'll let express.static know that we want to serve the default index file as index.html. So this line basically says, Whenever anyone hits the root URL and it's not handled by one of the routes above, then serve the index.html file from this dist folder. And that's it. This web server is now set up to serve our Vue app. The only thing that's missing is the dist folder. So basically, whenever you deploy a Vue app, you're basically just deploying or copying the dist folder to your web server. So let's go ahead and copy the dist folder from our Build-A-Bot app into our server. Oops, that should be CP. Okay, so now if we take a look here, you can see that we have a dist folder in here. And this is our Vue.js application. And that's it. We just deployed our app to our server. Now let's go ahead and start our server. We can do that with npm start. And just like before when we were running our API, you can see that this is running on port 8081. So one thing that's different now from when we were running in development mode is that we were spinning up our dev server on port 8080, and that was running with Webpack dev server. And we did that with the npm run serve command from our Build-A-Bot folder. And then we were separately starting our API server on port 8081. So we had our Webpack dev server running on port 8080 and our API running on 8081. But now that we've deployed our app to this production server, both our app and our API are running on port 8081. So let's go check that out. So we'll just navigate to localhost 8081. And look at that. There is our server. And that is being served out of our dist folder. And if we click on build, you can see that it is communicating with our API, which is running on the same server. So congratulations, you just deployed your first Vue.js application to production. And everything here is working great except for one problem, and that is deep linking. Let's take a look at that next. There is one problem with our newly deployed app. You can see that our app gets loaded just fine, and I can even navigate around within my app without any problems. However, let's see what happens if we try deep linking into our app. For example, what happens if I navigate straight to this build URL here? So I'm going to open a new tab and navigate to that URL directly. So you can see that I got a 404 error here. Why is this? Well, by navigating directly to this build URL, the browser sent a request to our web server saying, please send me the document at this URL. However, there is no document on our server at this URL. We don't have a route on our server for /build. That is a client-side route. So this is just a manufactured URL created by the Vue router that only the client-side app knows about. And so our server ends up returning a 404 because it doesn't know how to serve this URL. So basically, what we need to do is when someone requests any URL from our server, we need to return the Vue single-page application, or in other words, the index.html file from our dist folder. This is actually only a problem because we're running in HTML5 history mode. You may recall that before we were running in HTML5 history mode, our URLs had hash signs in them like this. If you don't run in HTML5 history mode, the server won't try to load this URL because the server only loads the stuff before the hash. But most people don't want this hash in their URL, so they turn on HTML5 history mode. And when you do that, you need to handle deep linking on your server. So let's see how to make our server work with that. So if you think about how to make this work, basically whenever a call that is made for a route that is not handled by one of these routes here, we'll want to serve the index.html file. That way, we'll serve up the SPA, and then Vue will load everything up and do client-side routing to the correct URL. How you do this in different web servers varies, but in Express, because this is such a common practice, there is an Express middleware that we can use. So back in my terminal, I'm going to stop my server, and I'm going to npm install this Connect History API fallback middleware. Okay, so now that that's installed, I'm going to come over here, and I'm going to go ahead and require that. So we'll set const history equal to require connect history API fallback. And then I just need to use that middleware like this. So right here at the top before our routes, I'm going to say app.use, and then I'm going to call that connect history API fallback function. And then inside here, I'm going to tell it the name of my index.html file, which is just /index.html. In this case, this parameter isn't necessary because by default, it will use index.html. I'm just putting it here for clarity. So basically this says, if a request comes in for a file that is not handled in the routes below, then redirect the request to /index.html. And this will essentially cause it to be handled by this route down here. Okay, so let's go check this out. So we need to start up our server again. And then let's come back over here and let's go ahead and deep link into the build page. Excellent. So you can see that works just fine. And we can try it again here for the cart page. And you can see everything, all the deep linking in our application is working now. And again, the way you set this up on your web server will be different depending on the production web server that you're using. Just know that you need to set up your server to always serve the index.html file whenever your server receives a request that it doesn't recognize. Cool. Now let's take a look at how to change Webpack config. But before we do that, we need to understand what the built-in Webpack config looks like. So we'll take a look at that next. We'd like to be able to edit our Webpack config. But before we can do that, we kind of need to know what is already configured. Without some help from the CLI, this would be challenging because the Vue CLI builds the Webpack config dynamically. So there's no Webpack config file to look at. But not to worry, the Vue CLI provides the inspect command, which outputs the dynamic Webpack config. All we need to do is in our terminal run vue inspect, and then we can tell it which environment or build mode to output the config for. So I'm going to say generate the production Webpack config for production mode. And now I could just run this and it would output the Webpack config to the console here. But to make it easier to explore, let's pipe this to a file. So we'll pipe it to webpack.config.js. Okay, so this is generating the Webpack for us. Remember, you don't ever need to do this. This config file that's being generated isn't going to be used. We're just generating it so we can see what the Webpack config file looks like that the CLI is going to use when it creates a build. So let's go take a look at this file. So over here, we can see our Webpack config.js file. And you can see there's a lot of stuff here, including all the Webpack rules and loaders and everything. And the nice thing is, if we add any of our custom config, which we'll do in the next clip, when you run this command, it merges that all together and generates the resulting file. So not only can you use this to see what the Vue CLI is generating itself, but you can also see how changes that you create are going to get merged into the Webpack config at build time. So this is really helpful in order to see what the Vue CLI is doing before we start making our own Webpack customizations. Let's try that next. Customizing the out-of-the-box Webpack config can be almost as easy as editing an existing Webpack config file. All we have to do is add a section to our Vue config file. If this file doesn't exist yet in a project of yours, just create it. We created this one earlier when we wanted to add our API proxy. So in here, we're just going to add a configure Webpack section. And this object is basically your Webpack options object. So you configure things inside this object in the exact same way that you would your Webpack options. And then the CLI uses Webpack chain and Webpack merge to merge it with its own config. So anything that you add here will be added to or overwrite the default config. To demonstrate this, let's add support for CoffeeScript. We do that by adding the coffee loader. So loaders go in the modules section. And the modules section has rules. All right, and then we're going to add a new rule. And this rule will target files that end in .coffee. And then we'll just tell it to use the coffee loader. And that's it. Now this config will be merged in with the default Webpack config. So now let's go take a look at the new Webpack config. So we're going to come over to our terminal and we're going to rerun this vue inspect command to generate a Webpack config. Now this is going to merge our config with the 0 config that the CLI generated, and we can go take a look at the result now. So over here in our Webpack config, I'm going to hit Control-K and then Control-0 in order to collapse everything in here. And then I'm going to expand this. And then down here in the modules, I'm going to expand modules, and inside rules, you can see how we have a whole bunch of rules, and down here at the bottom is our new CoffeeScript rule. Of course, if we were actually going to leave this in and actually use CoffeeScript, then we'd need to npm install coffee loader. Since we're just doing this to demonstrate how to edit the config, I'm not going to bother doing this. But you can see that we can be confident that the Vue CLI is going to take this rule into account when it creates our builds. But what if instead of adding a new setting, we wanted to edit an existing one? For example, I'm going to come up to the top of my page here, and then I'm going to search for this string right here. So this is a rule targeting image files. And let's go ahead and expand this. And you can see this is a URL loader rule. So what if we wanted to change this limit here? Well, let's try it. Let's copy this rule here, and then let's paste it in over here in our Vue config. So right here, we'll add another rule here. So this is targeting that same rule, and then we'll change the limit here to 5,000. Well, this is actually going to have an unintended consequence. So let's delete our current Webpack config file, and then we will go generate a new one. And now let's see what this looks like. So if we come back in here, and then let's search for this again. So now you can see there are actually two rules in here. And the first rule has it set to 1,000, and the second one has it set to 5,000. This sort of configuration can have unintended consequences, so there's a better way to edit existing rules. Instead of setting our configure Webpack to an object, we can use a function. So up here, I'm going to set configure Webpack to a function. And that function takes in a config object, which is the existing config from the CLI. And then we can just mutate this config that was passed in here. So for our coffee loader, I'm going to just append a rule to the module rule. So I'm going to say config.module.rules.push, and then I'm going to push on our coffee script rule. So I'm just going to grab this here and move it up here. Okay, so you can see I've mutated that config and added our coffee script rule. That one was easy. The next one's going to be a little bit trickier. Let's start by storing our new rule in a variable. So I'm going to say const new rule equals, and then let's grab this rule down here and paste that up here. Okay, so now we have that in a variable available to us. Let's go ahead and delete this down here. Okay, so now we need to do something with this new rule. So first, let's find the index of the rule that we want to mutate. So I'm going to set a images rule index variable equal to config.module.rules.findIndex. And I've got a typo here, the images. All right, let's bring this down onto the next line here. And then we're going to find the rule where the test expression is targeting our image files. And the test object is a regex, so that has a source. And the source is a string, so we can use includes to search for our expression. Okay, so that should find the index of the URL loader rule that we want to modify. And now I can splice the current rules array to replace the old rule with the new rule. So I'll say config.module.rules.splice, and I'll start splicing the array at image rule index, and I'll replace that item, that one item, with our new rule. So this is a little bit complex and maybe not totally safe because we could have multiple rules that have that same test expression. But this will help you get the idea of how you might use the configure Webpack function in order to mutate state. And there are other options for editing existing config using Webpack chain, but using Webpack chain is beyond the scope of this course. Just be aware that if you start running into issues with modifying existing config, you can use Webpack chain to help with mutating the config. Okay, so this rule should now be replaced with our new rule. So let's delete our Webpack config, and then let's go regenerate our config. Okay, let's go check this out. So in our Webpack config here, let's search for this string again, and you can see now that we are only finding it once, and it does have limit changed to 5,000. So now you've seen how you can edit the Webpack config using the object syntax and the function syntax. And that's all there really is to editing the Webpack configuration. You really have complete flexibility here. And all of this without ever having to eject from the Vue CLI, so that we can continue to use the Vue CLI in the future to do upgrades and to handle most of our Webpack config and other configuration for us. Cool, and that's all there is to editing Webpack config. In this module, we learned about creating a basic Vue.js build using the CLI, using environment variables and build modes, deploying to a production web server, handling deep linking when using HTML5 history mode for client-side routing, inspecting the built-in Webpack config, and customizing the Webpack config. And in this course, we've explored all the fundamentals you need to know for building and deploying quality, professional Vue.js applications. I hope you've enjoyed the course, and thanks for joining me on this journey to learn Vue.js fundamentals.